So as far as why you would do this, let's say that I have taste in literature and I only want recent books from odd years. And let's do an order by. There we go. So we get 2001 all the way up to 2017. All the modern books with odd years. But there's still something more. And it doesn't require us to use in or not in. Because if you look at this, this is pretty repetitive. Well, repetitive is the wrong word. It's long and there's a pattern here, right? So there has to be a better way to express this. And what I'm going to show you here has nothing to do with in or not in. So it's a bit of a tangent, but I feel that it's worth talking about. If you're familiar with programming, the solution here is to use an operator called modulo. And basically, this is also known as the remainder operator. What it will allow us to do is test if something is even. So how do we know if something is even in general? Well, it's divisible evenly by 2, right? If we can divide 2 into a number and there's no remainder, that means that it's even. So 4 divided by 2 is 2, and it's just a whole number, so it's perfect. But 3, or let's say 7 divided by 2, is not a clean, even division. So that means that it's not an even number. So there's a way to do that. It looks like this. So the percent sign is known, as I said, as modulo, the remainder operator. So if we just focus on that part, this is saying released year divided by 2, the remainder is not equal to 0. So if we plug in 2000 right here, 2000 divided by 2, the remainder of that is 0. But if we plug in 2001, the remainder is not 0, the remainder is 1, meaning that it's odd. So again, this is above and beyond what you need to know, but I just figured it would come up in the comments. If someone saw this gigantic mess here, someone would probably say there's a better way, and they're right. It just happens to not use in or not in, which is the whole point of this video, but I figured it was still worth talking about. So what we're doing, selecting the same stuff, title, release year from books. First thing is the same, only selecting books that are released after the year 2000 or including the year 2000. And then they also have to be odd years. So released year is not, or released year mod 2 is not equal to 0. 2 does not divide cleanly. And I'll paste that in just so we have a record. Run it. And you can see now I only get same exact result, right? Let me order it so that we can compare. No, I have a typo. Okay, so we get the exact same results that we got earlier, but we didn't have to write all these years out explicitly. And the other advantage is this solution works when we're in 2018 and 2020 and whatever other even numbers we have. As long as they are even and are greater than 2000, it will be filtered out. So this is, in my opinion, a better solution. It grows and it expands more. The other thing, there's a bit of a performance difference. It's not major, but when we look at this, basically, if we're pretending, let's personify or anthropomorphize MySQL, and it's taking a year like 2013. When we have not in, it's going to try, is 2013 equal to 2000? No. Is it equal to 2002? No. Is it equal to 2004? And it's going to keep going down. It has to try every option. There's no way to know unless it actually matches it or tries to match it against every year we have in this set. So that could potentially take a lot more time than doing a single mathematical operation like we have here. We're just checking, is the release year mod 2 not equal to 0? And it's really not a big difference, but it's just something that's nice to be aware of. Okay, so big tangent here. This video was really about in and not in. So just to go back to there, very useful. Allow us to pass in a set of numbers or strings or values, dates, whatever it is, which then our rows are checked against to see if they're either contained or not contained, depending on if we're using in or not in. All right. Okay. So we now have one more video, one new bit of information before we move on to the exercises and wrap up this section and go on to join tables. Very important, big topic. But before we do that, we have this video, which is on something called case statements. This is a pretty, exciting is relative. This is very different than things that we've seen in this section. It has to do with logic, but it's kind of on a bigger scale. It allows us to make decisions. So if you're familiar with programming languages, that's something I've been saying a lot in this section, but if you are, you've probably come across case statements or conditional statements, which allow you to add logic in to do things like conditionally print something out. It's a very simple example, but if a number is greater than 5, print one thing. Otherwise, print something else. Well, the same thing holds true in MySQL. We use these case statements, which I'll show you in just a moment, to do things like this. So over here, I have a genre category or a genre column that is not in our database. And what I've gone and done is basically said, print out title and release year, which are very straightforward. But then take that release year, and if it's greater than 2000, genre should be equal to modern lit. If it's less than 2000, then it should be 20th century lit. Very, very simple genres. We could easily expand that, or maybe genre is the wrong word. Maybe period is better, or era. But I called it genre. It's a lot of work to change these slides now, so we'll just call it that. But again, what's happening here is we have a conditional statement. This depends on this. So if we change release year of the namesake to be 1990, this would also change to be 20th century lit. So it's adding in logic, a new layer of complexity that we haven't seen how to do to make these decisions. And we're not limited just to 2, of course. We could break it up into a whole bunch of things, and I'll show you a few more examples. But let's first identify how this works. And I'll warn you, there's kind of a lot of syntax. Okay, so here it is. This is what results in what we just saw. So the beginning and end are the same. Select title and release year from books. But then we have this whole case thing, 4 separate lines. They don't have to be separate, of course, like anything in MySQL, but it makes it a lot easier to see what's related to what. First thing that we have is case. That's the word that says this is a case statement. It's going to consist of a couple of points of logic that will spit one thing out. And that thing ends right here. And then I have an as. So I don't have to have as genre. Remember, that's called an alias. But if I left that off, it would look really, really gross when it printed out in the table, because instead of genre here, it would say this entire thing, which would make the table gigantic. It would go way off the page and would ruin our formatting. So you usually want to use as. But then the more important part is what we have right here. So case statements take the following form. There's always a when, at least one, and then there's an else, as well as the opening case and the closing end. So let's step through what this says. When release year is greater than or equal to 2000, then return modern lit. And when I say return, it's a programming term, but basically means spit out. Think of it as just making genre equal to modern lit. So that happens when release year is greater than or equal to 2000. Then we have an else, which is otherwise, we're going to return 20th century lit. So this is basically saying if it's greater than 2000, if it was released in the 2000s, then make genre modern lit. Otherwise, it was released in the 1900s, so we're going to print out 20th century lit for genre. And that's how we end up with this. So we have this bit of conditional logic where genre changes depending on the value of release year. So let's actually try this now. Run it. And you can see we get the namesake 2003 is modern lit. Interpreter of maladies, however, is from 1996. And so we get 20th century lit. And I will show you if I get rid of the as, it's a nightmare, because if you look at what we have as our headers here, we have title, release year, and then we have case, when released, greater than 2000, then modern lit, else, blah, 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 blah. So you definitely want to use as when you can. Okay, so that's one example. But I do think this one benefits from a couple because it's a bit weird especially if you don't come from a programming background, so don't panic if you're not comfortable with this type of logic. But if you are, it's very similar. If you're not, it's kind of a big new idea. So here's another one. What I've done here, printed out title, and then stock quantity. And then I'm using stock quantity to then print a graphical representation of how much stock we have. So 1 star is things that are lower in stock, 2 star has a medium level of stock, and 3 stars means we have a lot of stock. And I can't remember the exact numerical breakdown where that happens. I believe if it's 0 to 50 copies, we have 1 star. If it's 50 to 100, we have 2 stars. And then if it's 100 or more, we have 3 stars. So it looks like this. So let me show you. Select title and stock quantity from books. Again, beginning and end is the same. Then we have our case, and then the end of the case with this alias stock. And so that's just going to give us stock right here. And then the important part. So when stock quantity is between 0 and 50, and we don't have to use between, we could use what we saw earlier, our logical and. We could say when it's greater than and equal to 0 and stock quantity is less than 50, then blah, blah, blah. But it's much easier to use between. So when stock quantity is between 0 and 50, then stock is 1 star. So that's how we end up with 1 star. But if that's not true, then it moves on to the next one. So if stock quantity is 100, this is false. So it ignores it. And it tries this. Well, is stock quantity between 51 and 100? If it is, then stock is going to be 2 stars. And if it's greater, let's say it's 153, well, this is false and this is false. So it goes to this last one, else, has no other choice. This is otherwise. If nothing else above was true, well, then this one is 3 stars. So it goes through and it does that for every single one. So we end up with 1, 2, and 3 stars. So hopefully you're getting the idea here. It's pretty powerful. It allows us to make decisions or have different outcomes depending on our data. One thing I definitely need to point out, because I can see this as being confusing, you don't have to have stock quantity printed out in order to reference it in your case statement. Or back here, I don't have to work with release year up here in order to work with it in the case statement. So let's actually copy this one over and run it. Make some space. Here we go. Okay, so we see the same thing. But just to show you, I'm not going to use stock quantity up here. I'm just going to select the title and our stock visualizer. And there we go. So I just wanted to show you, you don't have to have stock quantity referenced in order to use it inside of your case. And another point I should make is you're not limited in this number of how many conditions we could have. So if we wanted to, we could have another one here when stock quantity is between, what would we do, 101 and 150, let's say. Then it's 3 stars. Otherwise, it's higher than that, so we'll say 4 stars. So let's try that. And let's actually add stock quantity back in. It makes sense to be able to see that. And let's copy it over and run it this time. And now we have 1 star, 2 star, we've got 4 stars for 154 and 3 stars for 104. So my point is that you're not limited. Another thing that trips me up personally is I'm inclined to put commas here just because most things in MySQL are separated by commas. If you have a list of values or a list of anything, that will break it. So no commas there. It trips me up all the time. Okay. So one other thing I did want to address is that we could make it shorter if we don't use between. And the way that we can do that is by taking advantage of the execution order of things. So let me show you. Here's the same exact outcome as this line of code where we have 1, 2, and 3 stars. However, it's much shorter because what's happening here? So if it's less than or equal to 50, then we're done. We get 1 star. If that's not true, that means already it's greater than 50. So if this line is running, we know for sure stock quantity is greater than 50. They go in order. So we don't have to necessarily add this between because we know, all right, it's definitely greater than 50. So we can just take advantage of that and just say, okay, well, is it less than or equal to 100, which is the equivalent of saying, is it between 50 and 100? If it is, then it's 2 stars. But if it's not less than or equal to 100, then that means it's greater than 100. And so we get 3 stars. So this is more just showing you a way of cleaning it up if you wanted to. So you don't have to use between. And you can see we get the exact same outcome, 1, 2, and 3 stars. We don't have to use those longer between statements. Although some people would argue between is easier to read. It's more semantic, more understandable when you look at it rather than working with this. Definitely up for debate. So that wraps up this section on case statements, which hopefully you see what I mean when I say they're both very useful, but possibly a little intimidating, especially syntactically. There's a lot there. So definitely take some time on the next couple of exercises. I'm going to have a few that require you to write case statements. Hopefully you'll get some practice there, and you'll see how powerful they are. With that said, we're moving on to exercises. All right, so you probably guessed it, either because in the last video I told you, or because of this gigantic text here, it's your turn to try putting this into practice. So we got a couple of exercises. They range from trivial, simple logic questions all the way up to more complex case statements. So I encourage you to go through all of them, especially the case statements towards the end, but hopefully you don't lose interest before then. Oh, and one thing. This is the last time you have to work with those darn books. Last time that books data, unless you want to keep working with it, you can definitely play around with it. But I'm getting pretty sick of it. I imagine you are. And the good news is we're now moving on to join tables, which allows us to get much more complex and real life data, things that are more accurate and realistic. And that's really exciting. So get excited if you're not. All right. So here's the first couple. Evaluate the following. Now try doing them. Don't just copy them and paste them in and hit enter. Actually walk through and evaluate what you think the result is. So the first one, select 10 not equal to 10. Is that true or false? 0 or 1? Next, select 15 greater than 14 and 99 minus 5 less than or equal to 94. True or false? 0 or 1. Finally, select 1 in 5, 3 or 9 between 8 and 10. True or false? So do those and then move on to these code-based challenges. So the first one here is select all books written before 1980, and that does not include 1980. So everything up to 1980, but not 1980. Once you've done that, move on. I've got some beautiful red text, really expanding the color palette. Select all books written by Eggers or Chabon. I don't know how you say his name, honestly. That guy. Great author. Well, I just Googled it, and apparently it's pronounced Chabon. So, select all books written by Eggers or Chabon. Makes sense now, I think about it. Now, onto the beautiful yellow. Select all books written by Lahiri, published after 2000. So, books written by Lahiri released after 2000. Then, select all books where the page count is between 100 and 200 pages. So our middle length or short books, those are pretty short, between 100 and 200 pages. Next, select all books where the author last name starts with a C or an S. So this one, there's a couple of ways of approaching it. I'll let you discover what works best. You may want to use, you'll need to use things that we've learned in the past, especially when we're working with strings. So you may want to go back or just go to the string documentation to figure out how to do this. Select all books where the author last name starts with a C or an S. Those are my initials, so maybe I'm crazy and I just want books that start with, who are written by authors who start with my initials. I don't know. Now, moving on to the main event, our wonderful case statements. So here is another example. This is done using a case statement, and let me explain it. So we've got title and the author last name, but then we've got a type over here. What type of book is it? Which I'm really bad at this. This should just be called genre. It doesn't matter though. Basically, the way that it works, if the title contains the word stories, we're calling it short stories. So as you can see, where I'm calling from, selected stories, is categorized as short stories. Where what we talk about when we talk about love, great collection, is categorized as short stories because it contains stories. Same thing with Oblivion stories. But then there's another part. If the title is just kids, or it's a heartbreaking work of staggering genius, which I didn't write all the way up here because it's giant, but basically if it's this book or if it's this book, both are memoirs. So we have these two exceptions that you'll need to write in. Finally, everything else, which hopefully sounds familiar, otherwise, everything else at the end is called a novel. And I know some of these aren't actually novels, like Consider the Lobster. It's more of an essay or a collection of essays. 10% Happier is like a self-help book, but I didn't want to get too complex. So just to reiterate, if the title contains stories, type is short stories. If the title is exactly just kids or exactly a heartbreaking work of staggering genius, then it's memoir. Both great memoirs, by the way. And then finally, everything else is a novel. Okay, one more. This is a bit of a bonus. So it's more complex. You have to put a few things together. So we have title of the book and the author last name once again. But then there's this count section. And count, which we've already seen how to do, is a little different. It's not just saying 2 or 1 or 3. What it's actually doing, we can ignore the title part. Actually, you don't need to do that. Just focus on the last name of the author and the count. It's saying how many books each author has, how many they've written. So Carver has 2 books, Gaiman has 3 books, Harris, Dan Harris, or Frida Harris, they each have 1 book. Jhumpa Lahiri has 2 books, and so on. But not only is it printing the number, but there's also the properly pluralized books or book following it. So 1 book, singular, 2 books, 3 books, 1 book, and so on. So you'll need to use a couple things. I can give you hints. If you don't want the hints, then stop right now. But the hints are, you need to use group by. You need to also use a case statement to generate this right here. But it is a bonus because you do need to combine a couple things. It's a decent amount of work. Okay, so that's it. Once you finish that, burn all the books. We're done with them, whatever that means to you. I don't actually condone burning books, but if you want to get rid of the database, go ahead. Although you may want to refer back to it. This is more just me saying that we're done. We're done with the books. This is a turning point. We're moving on to some bigger and better data and to a pretty important section, which is joins. So I definitely recommend you take a break. But I will reiterate that in the solution video, which is coming up next. Okay, so let's go over. Hopefully you're still alive. It was maybe a bit of a challenging problem set. But if you're still here, let's go with these first 3. So evaluate the following. Select 10 not equal to 10. Well, 10 is equal to 10, so this should return false. We get 0. Next one, a little more complex. We've got an and, so remember that means both sides have to be true. Start with the left. Is 15 greater than 14? Yes, so that's true. But how about this side? 99 minus 5, it gives us 94. Is 94 less than or equal to 94? Yes, it's equal to. So that means both sides are true, meaning the whole thing is true, which we get 1. Finally, select 1 in 5, 3, or 9 between 8 and 10. So we've got or, means either side can be true to make the whole thing true. So let's start with this. Select 1 in 5, 3. Remember, I didn't show you this explicitly, but we saw how to use in, so you should know how it works. Is 1 in that set of 5, 3? No. So this side's false. But that doesn't nullify the whole thing. That doesn't falsify it. Because what's on the right side? Is 9 between 8 and 10? Yes, it is. So this is true, making the whole thing true. Let's try it. There we go. We get 1. So false, true, true. Next, select all the books written before 1980. So I didn't specify what part of the book. That's totally up to you. Let's just do title and released year so we can see that released year from books. And then the key thing is we want to do where released year is less than 1980 and not less than or equal to because it says non-inclusive. So less than where released year is less than 1980. Let's make sure it works. And there we go. All books written before 1980. Apparently we only have one. Let's just actually verify that. It's kind of catching me off guard there. And it looks like that's the case. All we have is Cannery Row. Well, I apologize that we don't have more exciting data. Next up, select all books written by Eggers or Shavon, which I now know how to pronounce. So there's a couple ways of doing this. Let's start with the most straightforward maybe, which would be, and also let's do title and author last name. So again, I didn't specify what parts you had to select, so it's up to you, but this makes the most sense so we can see the author last names. So what we can do is select them where, and we can use an or. So we can do a double equality, where author last name is equal to Eggers or author last name is equal to Shavon. Where author L name is equal to Eggers or author L name is equal to Shavon, just like that. That's one way of doing it. And you can see we get those 4 books. However, we can also use in, because all that we're doing is trying to see if author L name is in the set of Eggers and Shavon. So we can combine them, basically say where author L name in that set. Copy that, and there we go, same results. So whichever you prefer. This one is a little bit easier to see, I guess. It's shorter, easier to edit. And if we wanted to add another author in, it's pretty simple. But this is also perfectly valid. Next, select all the books written by Lahiri published after 2000. So the first thing, we'll do title, and this time we'll do author, L name, and released year from books. And we'll start by all books written by Lahiri. So where author L name equals Lahiri. So we can start there. We know that this should work, but we get 2 books. And now we want only the ones published after 2000. So what we need is a logical and. So where author L name is equal to Lahiri and released year is greater than 2000. And I didn't specify if it was inclusive or not, so based off of the language, published after 2000, we'll keep it as a greater than. If you put an equal sign there, it's not, you got it right, essentially. I didn't do a great job of clarifying that before, so either one works. Now we only get the namesake. Also, really great read. Next up, select all books with page counts between 100 and 200. So just like the problem we did back here, there's a couple of solutions. The first one is to use logical and. So we could do select title and page count, or just pages from books, where pages is greater than 100 and less than 200. So where pages, and we'll do greater than or equal to. Pages is greater than or equal to 100 and pages is less than or equal to 200. That's one way of selecting based off of a range. There we get these shorter books, but we could also use between, which maybe you gathered because of the language here. It screams out between, and that might simplify it a bit. So all we have to do is change it to where pages between 100 and 200. Nice, easy to read version. We get the same results. Okay. One thing, remember that this is inclusive. So if we didn't want to include 100 and 200, we could either do this, or we would have to change this to be 101 and 199 or something. Okay, so I'll leave it as 200. Moving on. Select all books where the author last name starts with a C or an S. So there's also a couple ways of doing this one. We'll start with the simplest one. So we want to select, and this time we'll do title and author L name from books. And basically we want to, let's just type it out with pseudocode or our English code. So where author lname starts with C, or author lname starts with S. So those are not, that's not valid code. So how do we do this? There's a couple options. The first one is to just use like. If you're comfortable with that, instead of starts with C, we can just say where author lname like, and then we use the % to force the C to be at the beginning of the string. So remember that this says the string starts with C and then anything afterwards. So that's one way to say it starts with a C. And then we just do the same thing down here, like S with the % after that. And that should do it for us. So we get Shaban, Smith, Carver, Steinbeck, Saunders. Good collection of authors. However, there's another way, which is to use substring. So if you remember substring, or maybe you remember me complaining about how there's also an abbreviated substr version. So we could use that. So we could say we're author lname substr of author lname, and we want 1,1, which will give us the first character. We want to check where that's equal to C, or, and I'll just duplicate this whole thing, where it's equal to S. So we could do this, and we get the same thing, but there's yet another way to clean this up, which is to then, I'll just keep them all here so that you can see them all. We could go, and because we're checking these two values, we could also use in C, comma, S, just like that, and get rid of the or. So now we're saying select title and author lname from books where the first character of author lname is in the set of C or S. And we get the same result. So 3 different ways. Next up, moving on to case statements. So in this one, I tried to throw you for a little bit of a curveball because unlike the other case statements we saw where we were just using greater than and less than, there's a couple things you're doing here. So we're just working with title, but you're seeing if title is like stories, and then you're seeing if it exactly equals Just Kids or A Heartbreaking Work of Staggering Genius. So let's start off with the basics. Select title and author lname, and we'll just do from books, just like that. And then we need our case statement syntax. So we're going to have case, and I like to just put my end right in there, as well as my as, and I called it type, which I don't actually think is a great name. Genre would be better. But inside of here, we're going to have our statements. So the first thing we're going to do is figure out, okay, if title contains the word stories anywhere, type is short stories. So when title, like, and how do we write or express the fact that it can contain stories anywhere, not just at the beginning, but anywhere in there? Well, we use %. So this means that it contains a string stories with anything afterwards, which technically we could have histories or something, which maybe is not what we want, but we can leave it at that. You could put a space here or something to make sure that it's just stories, but I'll keep it simple with stories like this. Then that's going to be short stories as our type. Okay, then we have another statement when title, and when title is exactly Just Kids or A Heartbreaking Work of Staggering Genius, we should print out memoir. So let's leave that part blank and just add in then memoir. So then how do we fill this part in? It's pretty straightforward. It's going to be a bit annoying. So how do we check if it's equal to Just Kids? When title equals Just Kids, or when title equals, and this is going to be very long, so I'm going to copy it. Where are you? Just like that. And I might shorten that, or I definitely would shorten it. So maybe it would be better to use like or something and search for a particular part rather than the entire name. But that was a problem here. Followed by our else, which is otherwise everything is a novel. So that's where this comes in. Else, novel, just like that. Now let's double check we don't have any extra commas, which I said I sometimes do. Looks good. Let's try it out. And we get all novels except for Just Kids and A Heartbreaking Work of Staggering Genius. And then those are memoirs. And then we have 2 Raymond Carver collections of short stories and a David Foster Wallace collection. Okay, so that's it. And of course, you could clean this up. So you could have used in here, title equals, so you could say where title in Just Kids, comma, A Heartbreaking Work of Staggering Genius. You could use like, something like this, or a title like Heartbreaking, although maybe we have multiple books with Heartbreaking in the title. So I'm going to leave that and move on to our final one. How do we make this happen? So again, what's happening, we're grouping things by author, and we're counting how many books each author has written, but we're not just printing that out, we're printing it along with a space and then the correctly pluralized version of books. So we'll start by just printing out, we can ignore title, just do author last name and count without the books part. So that should be a review of group by and count. So we'll select author, L-name, comma, count, star, from, books, group by, and we need to group by author L-name. So if we do this, whoops, you'll see we end up with Carver has 2 books, Eggers has 3 books, and so on. We do have that problem with Harris having 2 books, so we need to make this more specific, where we also group by author first name. And now we have 2 different Harrises. Perfect. So now, how do we, instead of just printing count like this, how do we add in that variable, the changeable suffix, book or books? That uses the case statement. So I'm going to make some space here. And rather than just printing the count, we're going to add in our case. Case, end. And if you look at how I printed it, I just called it count. So end as count. Then what is the logic we're actually trying to do? Well, we're trying to figure out when the number of books, count star, is equal to 1, let's say, then we want to do something. Let's just say singular book. This isn't the right answer. Otherwise, we'll do books. Okay, so the logic is not going down the right page. We're grouping things by author. Then we're having a case statement that says when the total count of the number of books that author has written is equal to 1, then count is book. And before, I forget, we are missing our thens. So when count equals 1, then book. That's very important. Now if we paste it. Okay, so we get Carver has books, Eggers has books, but each Harris has book. So we're close. But how do we get the number in there? And we need to use concat. Hopefully you guessed that. So we're going to concat. Basically, we want to take the number, which is going to be count, and we want to concatenate it with space book. Now, if we wanted to shorten this, we could just hard code this as 1 book, right? Because when count is equal to 1, then it's always going to be 1 book. This is the one where we have multiple books. We need to add in the number because it could be 2 books, it could be 10 books. So we'll concat the 2 pieces, which are going to be count, star, comma, and I know this looks like a lot here, so let's step through it. Concatenate the count with space books. So 2 books, 3 books. And that should do it. Let's double check. Here we go. Carver has 2 books. Shaban has 1 book. Harris has 1 book. Lahiri has 2 books. The only other improvement, I guess, to suggest would be to also put author first name just to make it a little clearer. In the case of Harris, we now can see Dan Harris has 1 book and Frida Harris has 1 book. Jhumpa Lahiri has 2 books. All right, quite a bit there. Hopefully you made it through. Time to move on. We can burn that part of us that's attached to the books. We are done. We're moving on to bigger, more exciting things. I highly recommend that you, if you're at your computer, get up and take a break because joins are a big section. Very important stuff coming up next, but a bit dense. So go for a walk if you'd like, or do whatever you need to do to get prepared to focus on joins. Hey, welcome back. So this section is a big one, really exciting stuff. I mean, exciting is relative. We are, talking about databases, but I do have a party hat here to celebrate. Yeah, so let's see, what are we talking about here? This course has been so far all about data in basically one table at a time. Kind of self-contained, basic data, nothing all that exciting, and nothing very complex. No data that is related. But of course, in the real world, all of our data, or almost all of it, is related. We don't have books on a website without also having things like reviews and customers and, shopping carts. We don't have cars on their own. We might have cars in our database, but then we might have salesmen and dealerships and all the other things that go along with it. Or like on Instagram, you don't have just photos. We have users, photos, comments, tags, likes, followings, relationships, all this stuff that's related. So this is a turning point where one of the turning points where we start to work with multiple tables that are connected. So we're going to talk about how data is related and then how to implement those relations using multiple tables. And some of the buzzwords, some of the big things we're talking about here are joins, foreign keys and primary keys, which we've kind of seen before, one-to-one, one-to-many, many-to-many relationships, lots of stuff. But like I said, this is the first of a couple sections focusing on related data. And the other thing that you may want to celebrate is that we are done with our books. Done with the books data. You can totally go burn the books if you'd like, throw them off a cliff. We're done with that. We're moving on to bigger and better things, inching closer to our Instagram data at the end of the course. Okay, have fun, and don't forget your party hat, because I didn't. Yeah. Okay, welcome back. So we're finally here. This is a bit of a turning point in the course. Really important section, not to scare you too much, but really fundamental to how SQL and MySQL are used in the real world. So this is a section all about relationships and also something called joins, which we'll get to in the second part of this section. So let's focus on the relationships part first. So far in this course, we've been working with very simple data, things like books or users, where we only have a couple of columns per table. And that's been by design. We need that simplicity in order to focus on what's important, to isolate the different features that we're talking about, whether it's functions or logical operators. It's much easier to teach those when we don't have 20 different tables to worry about, and we can just basically drill down into one table and focus on that. But that's typically not how the real world works, where, we might have a users table, but there's no site that really can just get by on having users unless it's featureless. There's plenty of other things that need to go along with users, whether it's comments or likes or tweets or posts or photos or any sort of, order, transaction. There are all these different things that we could have alongside users. So we've been working with simple data.
But that's about to change.
Real world data, unlike what we've been working with, is really messy typically and interrelated. There's a lot of connections between data. So some of those things I talked about with, let's say, users, if we're working with just a simple blog site, so nothing like a Facebook or a complex social network, just a simple blog, we still need to have user data. We need to have information about posts, blog posts. We also need to somehow keep track of comments and then tags. And that can get pretty complicated already, not to mention things like advertising and tracking not only ads on their own, but how ads are related to users and what users are clicking on and not clicking on. There's so much data that just from a simple blog site, something that may not seem that complex, there's so much stuff that we could store. So we're going to focus on how we work with interconnected data in the next couple of sections. So we're no longer focusing on one table. We're going to see how do we work with two tables or three or four that are related. So not just tables that exist independently, but tables that reference one another and are interconnected. So let's get going. And the first thing that I want to do is go back to our books data. So remember our books table. Don't worry, we're done with it. We're not going to be typing any books code. But on its own, it was really simple. We had a books table with author first name and last name, a book title, released year, a page count, in a stock inventory, I believe, a stock quantity. And I think that was it. So again, on its own, that just represents a single book. But you can't really do much with that. But if we were running a sort of book site where we sold books, at a minimum, we would need to keep track of things like versions. So we didn't even talk about this, but there's often multiple versions of a single book. If you go on Amazon and you look at a book, let's say Harry Potter, the second book, Chamber of Secrets, well, there's going to be the initial British release, the UK version as a hardcover, and then there's a paperback, and then there's the American version, and then there's a paperback. There is a full color illustrated version that came out relatively recently. It looks pretty cool. That has these giant illustrations. It's the same title. How do you keep track of that? Is that a different table? Or do you just make a separate book for every one of those? But if you do that, then how do you make sure that they're connected? Because when I go on Amazon and I look at the hardcover, it also will show me below, some people also buy paperback version. Or it's also available in, 25, 40 different languages. So there's all sorts of things to worry about just with versions. But then we have authors. Well, that might seem straightforward. We have an author, first name and last name, 2 columns on our books table, but that's not sufficient when we have multiple authors. So some books, a lot of books have multiple authors. What about if it's a research paper that we're selling or a journal that has dozens of authors potentially? So there's a lot of things to keep track of there that we can't really do right now. We only have room for one author in our columns. Then a whole big thing is customers. If we're doing a bookshop online, books on their own is great, but we also need ways to keep track of users, or customers is what I'm calling them in this case. So customers on their own also can't do that much, but we might keep track of their email, login information. Of course, we wouldn't just store their password directly, but for simplicity's sake, let's say we're keeping track of password and email so that they can log in. And then there's a whole bunch of other things. Orders. So if customers want to order books, how do we store that? We need to create a new order, and it needs to be associated with a customer who created it. It needs to have address information maybe. It needs to have the contents of the order. Are there books? One book? How do we support that? How do we handle that? What about if we're working with dates and times, and we need to keep track of when a return period expires? So we need to have an order date, and then keep track of 30 days or 60 days after that, or whatever it is. Then we also need to store or somehow keep track of the transaction information. Addresses for billing address, not only shipping address, the type of shipping, the billing information. There's so much to store. And then a whole other thing is reviews. So if we go on Amazon or pretty much any book site, any book that you look at will have dozens or hundreds, sometimes thousands of reviews. So we've got reviews there, ratings, the number of stars, but then also a title for the review, and then a caption, and then the actual content of the review, which may be 10 characters, I hate this book, however many characters that is, or it could be a giant paragraph, someone's love letter that they're writing to a book. So how do we account for all of that? And then the last thing that we'll talk about are genres. So you may think that we could just get away with storing this in a book, which we absolutely could. We could just have one genre, but many books don't cleanly fit into one genre. We might have a vampire novel that's also historical fiction because it's set in Victorian period England. Or we might have, a sci-fi book that has elements of fantasy, or who knows, you can have all sorts of, cross-pollinated genres. So only assigning one genre might not be that useful. We may want to have a bunch more. And in fact, on Amazon, you can see there are books that will have 2 or 3 different genres or different tags associated with them. So what I'm trying to show you here is that we were working with books on their own, but in a typical app or a typical website, that has to do with books and a bookstore in our case, there's a lot more that goes along with books to make anything functional, to store any important information. And this is, I don't know, maybe half of the tables that you would need to get away with, kind of the MVP or the bare minimum. There's still many other things. Something like orders, for instance, might actually need to be split into a couple of tables. We might need to have an address section or an address table. We might need to then have a separate billing table. We might need to have shipping. There could be all different tables that we could split it up into. So this isn't to say this is the end all be all. This is just that there's a couple of other tables that we need to consider at the bare minimum. Okay, so we'll stop here. In the next video, we're going to identify some of the different types of relationships between data. At a high level, what are the different types of associations? And I'm back. I totally forgot to show you this. Even though I wrote a note to myself, I totally skipped this. So I'm back after recording this, adding this to the end. I want to show the schema diagram that I really think highlights how messy data can be. So here's, I think I showed this early on in the course. This is just a potential schema for Facebook, and it's definitely incomplete. It's maybe a tenth of the number of tables that Facebook has. But you can see, just to store basic things like events and users, we have Facebook event, we have event membership, which is related to RSVP states, which is also related to venues, which is also related to groups and to workplaces and to Facebook profiles, and it just goes on and on and on. So what I'm trying to show you is that data can get messy, and in fact, here's another super intimidating schema. This one is a little bit crazy because it has to do with storing a protein database. I saw some article on IBM and I believe MIT. Unfortunately, it's a very low quality image, so you can't actually see the tables. But each one of these little rectangles is a separate table, and every line is a connection between the tables. Now, this is the worst I've ever seen, the craziest, and I think that was the point, is that they're trying to just show you, they're never going to actually look at this to try and understand anything, but they're trying to show you how complex protein information is. When you have all these different combinations and permutations for a given protein, without going into too much detail here, this isn't a bio course, but the way that a protein is folded, the same structure, basically the same amino acids, depending on how it's folded, can drastically change the features, if you will, basically what the protein does, how it behaves. And so this is a way of documenting, using SQL in some way, the structure of a protein using a database. Okay, so not to scare you there, I just think it's kind of a powerful image. Although grainy, it is powerful to see basically some really messy, ugly, gross data that can be supported using tables. It just doesn't look pretty. But that's the important part, and kind of the point of this video is I wanted to get you prepared mentally for working with some more complex data, although nothing that looks like this. Okay, so we've established that in real life, data can be crazy, complex. Outside of the classroom, things aren't as nice as we'd like them to be. So we've established that fact. But now where do we start to kind of wrap our heads around how we represent complex data using MySQL? And the answer is we're going to start by talking about the relationship basics. So I know it sounds like, marriage counseling 101 or something, but this is not, it's not that. This is about the different ways that data can be related. So if we have two tables or two entities, things like orders and customers, students and teachers, movies and reviews and users, how are they related? And there's a couple different ways. There's kind of these big, broad categories we can break relationships down into. And the terms that I'm going to use that you'll occasionally come across are three. There's the first one, which is a one-to-one relationship. And I'm just going to go through all of them first before we talk about what they mean and talk about examples. So a one-to-one relationship, a one-to-many relationship, and then a many-to-many relationship. So the reality is that one-to-one relationships aren't actually that common, but perhaps another example, or one that I've recently used, is I had a customers table that had the basic information for a customer. So things like their username and their password, although again, you don't actually store the password directly, but username and password and email, and like registration date. And then there was a separate table where we stored all these details about a customer. So rather than storing 10 or 20 extra columns on the basic customer table. We decided to split it up based off of what was most commonly needed in the app we were building. And most commonly, all we needed was the username and the password and the email. But there was a whole bunch of other information that we were storing, so we created a customer details table. And that's a one-to-one relationship. One customer has their own row, one row in the customer details table. And one customer details row is associated with one customer. So Colt Steel has a Colt Steel customer details, but there's no other user or customer that could be associated with it because it's a one-to-one relationship. Anyways, like I said, it's not the most common. What is the most common is actually a one-to-many relationship. And that's what we'll spend the most time on in this course because, like I said, it's really common. So here's an example. The relationship between books and reviews. One book can have thousands of reviews, right? Let's say Into Thin Air by John Krakauer could have probably tens of thousands of reviews by this point. It's been out for a while. It's pretty popular. But those reviews belong to that book exclusively, to one book. So the relationship is books have many reviews, but reviews belong to one book. So it's a one-to-many. So that's a really common classic example. Reviews or ratings and books or some entity. Okay, so then the next thing that we'll discuss here is a many-to-many relationship. And many-to-many is still relatively common. And the way that it works, it's what it sounds like. We have two entities, in this case, books and authors. And you could kind of speak through it. You could say, okay, books can have many authors. That's true. We could have two authors writing a book together. And those authors can have many books. There's no rule that says authors can only write one book. You know, J.K. Rowling, however you say it, has 10 plus books. So it's a two-way, a many-to-many relationship. So hopefully you can see the difference there. Reviews and books. Reviews belong to one book. They're associated only with one book, whatever the book title is for that review. It can't also be the same review associated for another book. So that part of the relationship is one, right? And then we have the books to reviews, which is a many relationship. Books have many reviews. This is different because books can have multiple authors and authors can belong to multiple books, or authors can have multiple books. And the way that we represent this is actually a little more complex. So we're going to come back to it. We're going to start off in this section by talking about the most common relationship and how we represent that, which is the one-to-many relationship. So that's coming up next. Okay, so we talked about the three kind of common relationship classifications. And as I mentioned, we're focusing on one-to-many first. And we're doing that for a couple of reasons. One is that compared to many-to-many, it's a little bit easier to get through. It's shorter, but also it's more common and it's more essential, in my opinion, to most of the development that I've done and that I see other people doing. Not to discount many-to-many, but we're going to get there. We're starting with one-to-many. So we're going to start with a classic example. Customers and orders, or this could be users and orders or users and carts, whatever the transaction is, but we're going to call it customers and orders. So two tables, and this is a one-to-many relationship as we talked about earlier. So let's say we have a customer, President Bill Clinton. That's our customer, and he can place as many orders as he'd like. He can have many orders, but each of those orders is associated with exactly one user, Bill Clinton. President Bill Clinton, excuse me. There is no way to have two people associated with one order. So it's a one-to-many. Customers have many orders. Orders have one customer associated with them. So let's talk about, for our case, what data we want to store. And it's going to be very simple. I don't want to clutter it with a whole bunch of other pieces of information. We're just going to focus on the basics. So a first and last name for customers and an email. Now, in a real web app, we'd want a lot more information probably. We want to create a registration date when a customer signs up, maybe a last active date that we're storing, or date time. Password, somehow we need to store that. There's so many other things. Phone number, if we're trying to do two-factor authentication, lots of things. So first and last name and email, so 3 things per customer. But then we also, for orders, we need to store the date that an order was made. So it doesn't matter for our example if it's date or date time, but we'll keep it simple with date. So 2017/11/12 or something. And then the price of the order, the total amount. Let's say 99.99 or 20.50. So that's going to be a decimal. So we're going to have first and last name and email, which should probably be varchars. The date of the purchase, which will be a date time, and the price of the order, which will be a decimal. That's the easy part. The next question is, how do we store that? How do we represent it? And we could do it this way, which I want to make clear. I'm not saying this is a good way of doing it, but you could technically get away with doing it in one giant table. But there's problems. But let's first just walk through how it works. So we have first name and last name and email for customers, and then order date and amount. So we have, boy George, whose email is george@gmail.com. He was a very early user of Gmail. And then we have the order date, 2016/2/10. And that order was $99.99. So this is capturing information for one order. But then boy George placed another order, and we have duplicated information because we're storing, it's boy George, which I know boy's not his first name, but just let's go with it. And then George@Gmail again, and then a different date. This one was later in 2017, and then a different price or a different amount. So this stores the information that we talked about. We needed first, last, email, and then date of the purchase and price of the order. And so that's working. Same thing with George Michael, who has gm@gmail.com, bought something in 2014 that was $800.67. And then George Michael, same email, bought something in 2015 that was $12.50. Okay, so already you should be noticing we have a lot of duplication, right? Even though we are storing the information that we're supposed to store, there's a lot of duplicated data. And then we run into these two, David Bowie and Blue Steel, my cat. There's problems because they haven't placed orders yet. So we have their customer information. We have David Bowie, david@gmail.com, also early adopter of Gmail. And we have Blue Steel, blue@gmail.com. And they haven't placed orders, but they still have order date and amount as columns, and they just have no value. It's null. So this technically represents that fact that Boy George and George Michael have 2 orders each, and David Bowie and Blue Steel have no orders. So that's really not a great way of doing it. Yes, it works, but we're not only duplicating a lot of things, right? Boy George, George Michael, and if somebody shopped a lot, we would have tons of duplicated information, which is just a waste. But then also we run into problems where we have users who maybe haven't ordered anything yet, and they just signed up for the site. There's no reason to have anything to do with orders until they actually place an order. So it's much better to keep our data separated, because if we ever need to work with just customers on their own, which happens, there are times on a site where you don't care about orders, you just care about customers. Let's say when a customer is signing in. All that you need is to take their email and check it, and take a password and check it against the password field. That has nothing to do with orders. So why would we need to go through a giant customer orders table? And that's just a really silly example. But what I'm trying to show is that it's not just about the duplication. It's also that sometimes it's better to keep your data separate, almost every time, unless you're always accessing your data together. Like if the only time we're ever talking about customers is when we're talking about orders, then maybe you could put them together. But then we still have this problem where we have people who haven't placed orders, or we have duplicated data. So this is a bad idea, not a good idea, aka bad idea. So what do we do? Well, here is the simplest approach. This is how we express a one-to-many relationship. And it looks like this. So we have 2 tables, customers and orders, and customers have an ID field, and then a first name, last name, and email. And then orders have an ID field, and then the date, the amount, and then this is the crux of everything. They have a field called, it doesn't matter necessarily what it's called, but ours is called customer ID. And it's a reference to the customer's table. So whatever customer ID is in a given order is going to correspond to an actual customer who placed it. So let's dive into it a bit more. Here's an example. So I took the exact same data, we had 4 orders and 4 customers from back here, and I split it up into separate tables. And you can see, let's just talk about customers first. We have a customers table with an ID, a first name, last name, and an email. So we have boy George, George at Gmail, ID 1. George Michael, GM at Gmail, ID 2. David Bowie, David at gmail.com, ID 3. And then Blue Steel, Blue at gmail.com, ID of 4. These are all unique, corresponding to exactly one user or one customer. And then we have our orders table. So there's an ID there, order ID, and then the date that an order was placed, and then the amount, and then the most important part, well, arguably the most important part, definitely the crux of the relationship, is customer ID. So in this case, it's 1, which is pointing to this customer with ID of 1, meaning boy George. So boy George placed an order in 2016 for $99.99. Here's another customer ID 1 telling us that this entire row here, this order, is related to boy George again. So he placed an order for $35.50 on 2017. And then we have George Michael, customer ID 2, matches this ID here. And he bought something for $800.67 in 2014 and something in 2015 for $12.50, which is the exact same data we had represented here. And then notice that we have users like David Bowie, or customers, David Bowie and Blue Steel, who haven't bought anything. And there's no extra data, there's no nulls. We have the minimum information that we need. We're not storing anything that we don't need. So we don't have extra orders that are created because they haven't created orders. We have separate tables. So this is the classic way of structuring a one-to-many relationship. And along with that, there are 2 terms we need to point out, which we have briefly discussed. And the first one is primary key. So remember this keyword we can type when we're defining a schema. We can say, and what we've been saying a lot is ID space int space auto increment and primary key. And the effect of that, what a primary key means, is that some particular column, in our case, this customer ID, is always unique. So we only have one customer with ID of 1. And only one customer with ID of 2 and 3 and 4. And that's really important because if we're referencing it somewhere else, like over here, if there are 2 different customers that have ID of 1, then this is useless because which one does it refer to? So it has to be unique. And then that's where the auto increment comes in, right? Where it will make it unique every time we insert a new customer. It will automatically increment this to 5 and to 6 and to 7. So there is no possible way we could have duplicate customer IDs. And then also here is order ID, which is also a primary key. It is the unique way of referencing an order. Now this is a bit extreme, but it's possible that we would have 2 duplicate rows here where basically an order was placed for the same amount at the same day by the same person. It's possible. And we would need to refer to them separately though. We don't want our database just to combine them. Maybe a user purposefully bought the same thing twice. They bought it once and then they realized, oh shoot, I really should have bought 2. So then they buy it again, same amount, same day, same customer ID. Well, the only thing that keeps those orders unique is our order ID. So again, these 2 are primary keys. They are the primary way of referring to rows in this table. It's what makes them, or it's not the only thing that makes them unique, but it is guaranteed to be unique. And then that brings us to foreign keys. And foreign keys are references to another table within a given table. So in this case, in our orders table, customer ID is a foreign key because it's referring to this ID of the customers. So primary key, foreign key. Customers does not have a foreign key in it. It's not referring to any external table, but orders has a foreign key. And that terminology is important. We'll come back to it a lot. Primary key and foreign key. And it'll also show you how you actually say in your schema definition that something is a foreign key. And the reason you would do that is to enforce that whatever customer ID is in here is an existing customer ID over here. Because what if we inserted something, an order and an amount with customer ID of 20, and we don't have a customer with ID of 20, we may not, most likely we don't want that to happen, right? We would want to bounce that back and say, hey, this is a problem. There's not a valid customer with that ID. And that's what foreign key, when we use that in our schema definition, it will enforce that. Otherwise, if we don't say that it's a foreign key explicitly, we could have customer IDs, all over the place that don't actually exist. Okay, so this is the schema that we've defined. Well, this isn't the actual schema, but this is the basics of what we want our schema to look like. Now we're going to implement it in the next video. All right, so we discussed our game plan for implementing the relationship, the one-to-many association between customers and orders. Now let's get to it. So we'll start off with customers, which is a little bit easier. So we're going to have an ID, a first name, a last name, and email. And these three, the last three, are all varchars. An ID is an int. So let's start off with that. And I'll let you know, I have basically our data already written so that we don't have to spend time typing it out. You'll be able to copy and paste it. But I do think it's good if you go through actually typing the schema itself and then just copy and paste the data in, because there's no reason you need to spend time, typing blue steel and all these email addresses over and over. Okay, so create table, customers. And let's just start by defining what we need. So we have an ID, we have first name, we have last name, and we have email. And as we said, these are all varchars, and we'll just do 100, and I'll copy that and paste it. Add my semicolon, and so we're almost there. We just need to figure out ID, and this should be review. We have int, and we could leave it at that, but it's best to add auto increment and primary key. And that's because, well, a couple things. One, it's a good habit to get into. At the very least, it can be useful for sorting things. But more importantly, we're going to reference this ID, customer's ID, in another table. And so we want to make sure that it's unique, like we discussed. We don't want to have, customer ID 2. We don't want any ambiguity as to who or which customer that's referring to. If we had two different customers with the same ID, that would be problematic. So we're going to make it unique with primary key and auto increment. Now, primary key on its own enforces the fact that it's unique, but we would have to manually enter it in. This should be review. But I would have to actually say something like insert into customers, and then what would I do here? Let's say ID, and I'll just do first name. I would have to manually go through and say, okay, this user has ID of 2 and a first name of Tom. And then the next one, I would have to make sure it was unique and do 3, or I could do 20 or 50 as long as it was unique. But I don't have to care about that ID if I put auto increment. So we'll do that. Okay, so that gives us customers. Let's make sure we add our comma there. And then next up, we have orders. And order has an ID as well, so that will also be a primary key. Then we have order date and amount. So let's start with those three. Create table, orders. And the first thing we have is ID. And then we had order date. And you might be inclined just to call it date, but that can be problematic because that is an actual data type. It would be like naming a column int or varchar. So we don't want to do that. So we'll call it order date, and then we have amount. Okay, so order date is just going to be a regular date. We won't worry with date time, even though I prefer date time. Just to make it simpler for us, we won't have to deal with the time component. So that's not what this exercise is focused on, so we're just going to eliminate that. So date, and then this will be a decimal. And for our purposes, let's say 8,2, so where 8 is the total number of digits and 2 is the number after the decimal. So we'll start with that. Decimal, 8,2. Order date is just a simple date. And then ID is an int. And we'll do the same auto increment primary key. But then that brings us to the last thing, which is different. We haven't seen this before. And all we're going to do is write customer ID. That is the name of the column. What data type is it? Well, it's just going to be a number. It's an integer. So we could just leave it at that if we wanted to. And I'll show you what that looks like to start. So I will go ahead and leave it at this. I'm not recommending that you actually run this just yet because we are going to change this, and I'll show you why in just a second. Okay, so let me add my semicolon in here, and then let's make sure we don't have any typos. The first thing I'll show you is that I'm in a new database. This is a bit of review, but it's been a while. How do I check the name of the database that I'm currently in? It's select database. So I made a new one. It doesn't matter. You could do it inside the bookshop. I just wanted to have a clean thing. We have no tables yet. So I'm going to make our customers table and see if it works. And then our orders table. Okay, perfect. So then I have all of this data down here that I'm not going to type by hand. But if we take a look, it's adding how many users? 5 users. I added one who wasn't in our database already, or who wasn't on the table here, which is Betty Davis. So we have Boy George, George Michael, David Bowie, Blue Steel, and Betty Davis. So that's just going to insert into customers. Make sure that works. Let's do a select star from customers. Perfect. And then this is a trickier part where I'm actually inserting the orders. And if you notice, all that I'm doing is the date of the order, the price, and then customer ID at the end. And right now, there is no explicit association between customer ID here and ID here. All that I've said is this is a number. So it's up to me to put whatever I want in there. So let me show you. I'm just going to do that now by copying this and pasting it in. And now if I do a select star from orders, you can see we have customer IDs 1, 1, 2, 2, and 5, which is fine. That looks good to us because we also have users who go up until 5. But there's nothing stopping me from doing something like this. Let me just copy this first part. There's nothing stopping me from inserting something with, let's say, price is 33.66 or 67, why not? And customer ID is 95 or 98. There's nothing stopping me from doing this. And that's not, well, I mean, we could get by with this, right? We could just know that we're never going to insert something with a customer ID that doesn't exist. But because there is no association between customer ID and this ID, we can do whatever we want, which is usually not a good thing. So if I hit enter, now we have an order with a customer ID that doesn't actually exist with a corresponding customer. So what we want to do is actually add in a constraint here. So just like there's a primary key, we also can explicitly say something is a foreign key. And the easiest way, it's a little longer. It looks like this on a separate line, foreign key, and then in parentheses, we say the name of the field or the column we're referring to, which is in the orders table, customer ID. And then we have to say what it's referencing. So it's referencing, think of drawing this line up to ID. Okay, so we have customer ID up there. So we're going to do references, and then the name of the table, which is customers, and then in parentheses, the name of the field, which is ID. Oops, I lost it. Here we are. Okay, so it seems like a lot, but all that we're saying is, hey, there's this column that we already defined, customer ID, it's an int, make that a foreign key. And it needs to reference, remember foreign key means that it's referencing something external, something outside the table. We want it to reference the customers table, and in particular, the ID field. One small note I'll add, your keys don't always have to be IDs, they're almost always IDs, but you can get away with other things. Like I think we discussed this earlier, sometimes you want emails to be unique and you could make that a primary key instead. But IDs are easiest because they're short, they're simple, you can auto increment them, and it's 99.9% of the time what you'll use. So here we go. Again, just to go over the steps. You define first customer ID, and then, and just to clarify, you can call this customer ID, you can call this whatever you want. I gave it just regular ID and gave this customer underscore ID, which is a convention when you have a foreign key to use the name of the table underscore the name of the column, just so that it's clear. And we already have an ID here. Okay, so we're taking this, making it a foreign key, referencing this field here. So to see the effect of that, we're actually going to need to drop our tables and start over. So it's just drop table, and we can do them both at once. So customers, orders. Okay, and now how do we see our tables? It's a quick review as well. Show tables. Nothing. Okay, so I'm just going to paste this in again. We got our first table. Make sure we didn't screw up our syntax at the second one. Great. Only difference is this line here. Now we're going to insert our customers again and insert our orders again. And if we do a select star from customers, you can see nothing changed. Do a select star from orders, nothing changed. Great. But then now let's try and insert something else like what we did earlier. So I'm just going to copy this line again down below, and we're going to insert an order. We can keep the same date. Let's do June 6th. And our price will be 33.67. But our ID is going to be 98, which doesn't exist. Our customer ID is 98, which doesn't exist as a corresponding user or customer ID. As you can see, we only go up till 5. So if we try that, now we have a problem, which we didn't have before. Cannot add or update a child row. A foreign key constraint fails. And so basically it's saying I can't do that because the constraint you had said this was a foreign key referencing customer ID or customers in the ID field, and there is no customer with ID 98. So it's now enforcing that, which is great. And if we select all of our orders again, you can see it's not in here. It didn't make it in here. So we now have this, think of it as a bouncer at the door that is checking if there's a corresponding customer, which is useful. Okay, so that's what foreign key does. And I'll go ahead and end this video there. But we haven't really explored our data yet. So in the next video, we're going to start seeing how we can work with our data. How do we basically connect these two tables? We have them associated, but now how do I do things with them? How do I figure out who ordered what? Like if I look at orders right now, I have a customer ID, but what if I want the name of the person, the first name, or both first and last name, or the email? So that's coming up in the next video, and we're going to dive into a really important topic, which is joins. So that's coming up. Okay, so we've got this data in our database. We have two separate tables that are distinct. They have a foreign key. The orders has a foreign key referencing customer ID. But so far, we haven't actually done any queries. We haven't worked with our data. So let's try it now. So back over in Cloud9, let's start with a simple question. Let's look at our customers. Well, actually, let's look at our orders. And I have 5 different orders here. Let's say I want to find the orders that have been placed by Boy George. So how do I do that? I want the orders placed by Boy George. Well, we could do it as a 2-step process. So I would first say, basically find the ID of the customer whose name is Boy George. So we could do select star from customers where, and then we would do something like where last name equals George. Okay, so we get Boy George, george@gmail.com, and his ID is 1. Okay, so then we take that and we go to our orders table and we try and find, okay, where is in the orders table is customer ID referencing 1. So we're just going to do a select star from customers select star from orders where customer ID equals 1. And there we go. These are the 2 orders placed by Boy George. So that was a 2-step process. And we could simplify that, or we could at least do it all at once, actually using something that we touched on. We could use a subquery. If you'd like to try and do that, you can take a moment to figure that out, but I'm just going to write it down here. We would do something like this. So the 2 things we just did, let's just copy this one. We did this right here. Select star from orders where customer ID is 1. And then we also had select star from customers. So to put them together, what we basically want to do is find the ID of the customer where last name is George. Then plug that into here. So rather than hard coding it as 1. So it would look, it's going to be a bit long. So it's going to be something like select star from orders where, and then where is going to be long. So it's going to be a subquery. And we want to do where select ID from customers where last name equals George. Okay, so let's take a look. We need to fix one thing actually. Select star from orders where customer ID equals the result of this. Okay, so let's step through it. Start with this middle part. This runs, it selects ID from customers where last name is George, which is what we did up here. So when we run that, we're only selecting ID. So actually we could change that because we're only selecting ID, and it gives us 1. So you could think of this whole thing is replaced with 1. Actually, it's more like this whole thing is replaced with 1, which leaves us with select star from orders where customer ID equals 1. So let's test it out. And you can see we get the same result. But this is still not ideal. It's a bit cumbersome. And this is only if we're working with one user anyways. What if I wanted to see a synthesis of my data? If I wanted to see next to every order, so something like this, if I go up, let's do select star from orders. Next to every order, I wanted it not just to say customer ID, I wanted it to say the name of who made the order. So Boy George, George Michael, Betty Davis. And I wanted that to be printed here. So how do we do that? And this leads us to our next topic, which is joins. So joins allow us to accomplish that. The whole point of joins, which is sort of this buzzwordy, maybe intimidating, mysterious thing to some of you, the whole point of it is that it takes two tables and we can conjoin them in a couple different configurations. So we'll talk about what those are. That's the next few videos. But we can conjoin them, basically take the data from one and take the data from another and stick them together in usually a meaningful way. But I'm going to show you one way that is not meaningful to start. And this will be our first, most basic join that you probably will never use. I never have used it, but it's good to know. And it just looks like this. Select star from orders. We can do customers first. It doesn't matter. Customers, comma, orders. And that's it. So if we just select from both of them, what do you think will happen? I'm going to hit enter here. And we get this monstrosity. It's very long. And what we're actually looking at is called a cross join. I think I've also heard it called a Cartesian join. Like I said, it's pretty useless, but it's interesting to see. What it does is it takes every customer. So we have Boy George, George Michael, David Bowie, Blue Steel, Betty Davis. But then notice that, let's ignore the right half, just the customers. It goes from 1 to 5, and then it repeats. Boy George, David Bowie, Blue Steel, Betty Davis, and then Boy George, George Michael, David Bowie, and it keeps going. And what it's doing is taking every customer and conjoining it with every order. Think of it as almost multiplying them. So it's taking the first order, which is $99 with an order ID of 1, and it's sticking that next to Boy George, order ID 1, George Michael, order ID 1, David Bowie, same order, Blue Steel, same order, Betty Davis, same order, and then it moves on to the next order. So then we go back, Boy George, stuck with the second order. Second order. It basically, hopefully you can see what's happening. It's a lot of text to look at, but it's taking these two tables and just jamming every row, every possible combination next to each other, which is meaningless. There's no reason to do it. But I just wanted to show you it because it's the first and most basic type of join. So don't make much of that, the fact that you can do it. It's just good to know that you can, but we're much more interested in basically whittling this down to the stuff that we care about. So maybe the most obvious and meaningful way would be to whittle it down so that we only see where there's actually overlap. So where the ID of the customer is the same as the customer ID. So this would be a match, right? This is an order placed by Boy George. but then none of these are actually placed by the customer they're next to. But then we get down here and we have, okay, here's George Michael with an ID of 2, and he placed this order. So how do we whittle it down to that? And that's what we'll see in the next video. Sorry for the cliffhanger. Okay, so in the last video, we saw our first join, our first example, which is actually something known as an implicit join, which you'll see for a moment why it's called implicit. And it's also, in particular, it is a cross join, useless, basically. So it just think of it as multiplying our data, cross multiplying. It takes every possible combination. So we have boy George. Well, I don't need to go over that again. I'll bore you to death. So now we want to focus on whittling it down to what's actually relevant. I want to see the name, first name, last name, and email of every user who actually placed an order next to that order, not just every arbitrary order. I want the ones that they placed. And so we're getting sort of close. If we have all of it next to each other, now we just want to only select the rows where what condition is true, where our user ID is equal to the order customer ID. So it's just like any other kind of select we've done, where we just can add in a where. So it will be a select star from customers, comma, orders, where what is true. Where ID from the customer is equal to customer ID. So we could do this where customer equals customer underscore ID, but there's a problem, and maybe you've identified it. We have two IDs. Remember, we're just taking the customers table and the orders table and putting them together. So we have ID from customers and ID from orders. So what does this refer to? That's a problem. Fortunately, there's a workaround. It's very, very simple. All we have to do is prepend the name of the tables. So this should be our customer's ID, right? It's coming from here. And just to make that clear what's happening, we're saying where the customer's table dot ID, so where this is equal to customer ID. Now customer underscore ID, and I realize there's a lot of saying customer and ID over and over, but these are different, right? This is the customer's table ID. It's referring to this, customers dot ID. That dot means in the customer's table. And this is customer underscore ID, which is referring to this right here. So we don't have to say orders dot customer ID, but it's a good convention to follow to do that. Just to, whenever you're working with two or more tables, to be explicit about which table, or which row, which column belongs to which table. Okay, so we have this line. Let's copy it over. So what this will do is select, or it's going to do this cross join, but only where the customer's ID, customer table ID, is equal to the customer ID of the order. So now if we do this, take a look at what we get. We have 5 orders, so we get these 5 different rows, and we have the corresponding customer who placed it. So Boy George placed this order for $99. Boy George placed another order for $35. George Michael placed these 2 orders, and Betty Davis placed this one order for $450. So you can see we have customer ID over here, and it's matching the customer's ID. And of course, we could condense this a bit, so maybe we don't want star. Maybe we want first name and last name, and then order date and amount, and that's it. Just like that. So let's try it. And now we get a more condensed table that has that information. Boy George, 2 orders. George Michael, 1 order. George Michael, another order. Betty Davis, another order. So what we've just done there, we have joined them together using what's known as an implicit inner join. So I'll write that here. Okay. And that's what we did up here as well. So this is just a more refined one because we're not selecting star. We're only selecting a couple of things. But we've joined them where they match, if that makes sense. So I have a simple diagram. It's very, very ugly, but a simple diagram to show you. And I'm sorry it's so ugly. It was very difficult. Filling in this shape here is not a circle, and the slides tool I use doesn't let you draw weird shapes. You have to do circles. So I'm sorry. I really am. But what's happening here is that we have two tables, right? Customers and orders. And what we did at first was select everything, combine them, and just take everything together. But all that we want to do with an inner join is take the inside where they overlap. And that's what we did. We went from this monstrosity and we whittled it down to where the customer's ID is equal to customer ID in the orders table. And we get this right here. Okay. Now I said this is implicit, and that's because there's an actual explicit syntax. There's a better way of doing this. And when I say better, it really means that it's more conventional. If you're not familiar with that, it means that think of it as like an unwritten rule that developers follow. They think it's cleaner, it's more easily understood to do it this way, which I'm about to show you. So I'm going to write, what did I do? Here we go. I'm going to write comment explicit inner join. And this will be the first time we see a new keyword called join. So we're going to do our same select star. We'll start with this one from customers. However, we're not just going to do comma orders. We're going to select star from customers, and then we're going to add join orders. So we have some new syntax. I'm just going to type it all first. And then we're going to tell it where. We're going to join on customers.id equals orders.customer ID. Okay. So if I copy this and I run this, it does the exact same thing. And if we want to, of course, we could refine this more, just like we did earlier. So instead of selecting star, let's do the same thing where we select first name, last name, order date, and amount. Okay. Copy this over. And now we get the same table, and just to prove to you that it's the same. There you go. Can't even see a difference when I just hit enter, and it looks like the same thing is here. Okay, so this is still an inner join, but this time it's explicit, and it's really only explicit because we're writing the word join. So when we say join order, so we say from customers, join orders on this join condition. So take the left and the right, so it's customers and orders, these two circles basically, and join them, create the union table where customers.id is equal to orders.customer.id. So where the ID from here matches the customer ID from here, take that overlap and make this table for us. So I know it's a lot that I'm talking about here. And the term inner join and explicit inner join, implicit inner join, and we're going to next talking about right joins and left joins. It can be overwhelming. So all I want you to focus on is the key idea here, that we are joining data together based off of a condition, right? And we could join it off of some meaningless condition too, just to show you. So if we go back to this really ugly cross join, where it takes everything and joins it together. So if I wanted to, there's no meaning to be garnered from this, but I could join it where the two IDs are the same. So not customer ID, but I could say where customers.id is the same as orders.id. So let me just show you that now. And I'll just comment this as arbitrary join. Don't do this. But we could do this. We could select star from customers, join orders on, and I'll just say where customers ID equals orders.id. There's nothing stopping me from doing this. And as you can see, I just end up with this new table that has matching IDs. So we get, let's take an example like George Michael. So George Michael is now matched. He has an ID of 2. He's matched with the order of ID 2. It doesn't matter that it was placed by customer with ID of 1, which is Boy George. So I'm saying that we can just join things on arbitrary conditions. However, what goes in here is you're filling in a foreign key matching a primary key in another table. So primary key is the customer's ID. The foreign key is the customer underscore ID in the orders table. And then the last thing that I'll wrap up with here is, does the order matter? So if we go back to our cross join, what if I reverse the order? So I started with customers, comma, orders. And so we get customers here, and then orders tacked on the right. So what if I switch it? Orders, comma, customers. And you can see, well, it looks very similar, except, well, it doesn't look similar. We have the same data, but it's been switched. So we start with every order first, and then one customer tacked on to the end, and then every order again, and then the same customer. So the order does matter in a sense as to how your data is presented to you, but it doesn't matter in the case of a cross join or in the case of an inner join. It won't actually affect the result. It just affects what is printed out, what it looks like. So let me show you. If we take this same, we've got a lot of them going on here. Let's take this same one here. This is kind of the most useful join we had, right? Where we had the name and the order date and the amount. If I switch, and I'm just going to duplicate it so that we have the original as well. If I say from orders, join customers on, and we can leave this either way, but let's say I do that. So I'm selecting from orders with joining customers onto it, and I hit enter. Nothing changes. And that's because we are picking our data, individually from up here. Now, if I just did a star, it would look a little different because you can see we're actually getting order first. So order ID, order date, amount, and then customer. And if I switch that, it would be the other way around. That doesn't really matter. It's just, orders. But you can see now we get customers and then orders. All right, so this has been long and a little difficult, I imagine, especially some of the syntax or keeping the jargon. What I do want to say is that basically when you're joining things, don't do implicit joins, which is what we have here. It's better to do it explicitly this way. So something like this or this, where we have select something from a table, join on another table on a condition. Okay, so that is kind of the bread and butter of joins, doing an inner join, but I'm going to show you a couple of other examples. That'll be up next. Okay, I hope you're still with us. I really hope it didn't put you to sleep with the last video. These are getting a little too long for my taste, significantly too long, so I apologize for that. But there's a lot to cover here, and there's no great place to break it up. However, we are done with kind of the long slog of explaining joins. Now I'm just going to show you another type. So inner join is what most people end up doing. That's a big generalization, but it's what I end up doing most of the time. But there are other types. And the next one that I'll show you is called the left join. There's left and right. They work very similarly, so once you understand how one works, it makes it easier to understand the other. So what we saw so far was the inner join, where we take one table, A, and another table, B, and then we select all the records from A and B where the join condition is met. But there's another type of join. Before I get there, I want to show one other thing. If we go back to any of our joins that we had, let's take this one here. So this gives us our nice little table with Boy George and his orders. We have George Michael and his orders and Betty Davis in her orders. I can do just any regular MySQL functions and things that you're used to with this data. So I didn't make that very clear in the last video. This isn't some special table. We can do whatever we want. So I could do something like group by, or let's start even simpler. I could do an order by. Let's do an order by, and let me actually move this so we have a record of everything we've done. So I'll scroll down, getting fancier. Here we go. So we can do an order by amount if we wanted to. And now we have from the lowest order up to the highest order. Or we could order it by order date. So that's one thing we can do. But we can also do things like group by. So maybe, let's say this is something we actually might want to do, is take all of our orders and group them by who ordered them. Okay, group them by who ordered them, and then take that and find the average amount they spent, or the total amount. How about we start there? Let's identify the biggest spender in our entire database, which is pretty easy to do if you just look here and add things up. But let's say we had, 10,000 records. How do we find the biggest spender? So we'll group by. And how do we group them? Well, we want to group by our customer, right, who placed the order. First name could work, but that assumes that we only have one Betty or one George, and we might have George Michael and George Foreman or something. So that's not going to work. We could do first name, comma, last name, but we still could have people with the same name. So it's better to just group by something we know is unique, like customer ID, just like that. And let's be explicit, orders.customer ID. So group by that. And if we hit enter, remember when we do group by and we don't actually do any math or any functions on it, it looks like it just cut data out, because that's just how it prints things to us. But now you can see that we have grouped by the customer ID. So I know it's hard to see because we're not displaying customer ID, but remember that customer ID is unique relative to every user. So we're basically grouping by customer. Hopefully that makes sense. You could make it a bit clearer if you did something like this. What we've done, and let me get rid of the group by briefly. What we've done is take these customer IDs here that we weren't showing and just grouping these two together, and this one on its own. But we're not actually displaying that. Okay, so we can group by that, like we did. And then all we want to do is total together the amounts. So rather than just amount, let's do sum amount. And I'm going to clean this up a little bit. And let's give it an alias as total spent. Just like that. Now let's try it. Cool. So we can see Boy George spent 135, George Michael 813, and Betty Davis 450. And then lastly, we could order by total spent. Move our semicolon. Now you can see, and actually let's do descending. Now you can see, okay, George Michael is definitely our biggest spender. 813.17 cents. Perfect. Now, order date doesn't really make sense to have in there, so because we have multiple orders, and it doesn't make sense just to show one, so maybe this makes more sense. There we go. Okay, so I just wanted to show that you can still do typical things that we're used to with the results of a join query. It's not some special alien type of a table. Now that brings us on to the left join. So another way of joining our data. Here's the ugly diagram I tried to make. It's a little better. The colors are still awful. I'm sorry. So what does it do? Well, it's going to take everything from the first table. So if customers is our table on the left, it will take every customer. And then on the right, it will try and match, or it will match any, or it will add any matching records from orders in our case. So these diagrams, just talking about it like this, I find isn't that helpful. But basically, think of it as it takes the union of where they match, just like inner, but then it also does everything from the left table, from customers in our case. So let's test it out. Over in Cloud9, I have a comment here for left join. And let's go take one of our joins that we did earlier. Like, let's do this first one. And this was an inner join. And one thing I didn't mention is you can explicitly write inner join, and I'll show you. It does the exact same thing. If you leave it off, it's implied that it's going to be an inner join. It's the most common type. What it does, as we know, it takes customers where their ID matches customer ID, and that's all we get. That's the inner part that matches. Now, if we change this to be left and select everything, you'll see we get a couple of differences. So we still have, it's kind of ugly to look at, I'm sorry. We have Boy George in the order he placed, and Boy George another order he placed. George Michael, 2 orders that match. But then we have 2 users who never placed orders. David Bowie and Blue Steel do not have orders. And so we end up with David Bowie, Blue Steel, null, 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 null for the orders portion, and then Betty Davis in the order that she placed. So we have customers on the left, orders on the right. We're taking everything from customers. So that's why we end up with David Bowie and Blue Steel. And then we take the intersection as well, where there is an applicable match. So for David Bowie and Blue Steel, there isn't one, and it fills in null. But for Boy George and George Michael and Betty Davis, there is a matching order. So I know it's kind of difficult to look at or understand, but think of it again. We have customers, and we go through at the beginning. Okay, Boy George, is there a matching order? Yes. This one here, right here, and this one. So put those together. George Michael, ID of 2. Is there any matching orders? Yes, there's 2. Put those 2 together next to George Michael. David Bowie, is there a matching order? No. So just put David Bowie because it's a left join. If it was an inner join, then David Bowie and Blue Steel don't show up. But it's a left join, which means we're taking everything from the left table. And it works perfectly. Well, depending on what you're trying to do. So that brings us to the question, why would you do this? And before we get there, I'm going to just clean this one up again so that we can see it a little bit easier. Let's only select first name, last name, order date, and amount, just like before. So that brings us again to the question, why would you do this? Why would you want to have excess information like David Bowie and Blue Steel? And it depends on what you're doing. And in this case, maybe previously I wanted to see, okay, all the orders that have been placed and names next to them. But now what if I want to tabulate the high spenders on our site, but I want to include people who haven't spent anything. So I just want to be able to see for every user, how much have they spent? And I'd be able to go through and say, maybe send an email to the people who have spent a lot. Okay, thanks for being a loyal customer. Versus people who haven't spent, I could go through and send an email like, here's a coupon for your first purchase, 10% off, something like that, right? Where I want to basically get some insight where it involves knowing everything about all users. And some of them have corresponding orders and some of them don't. Now that brings us to another topic, which is, okay, but we have nulls here. So is there a way to change that? Let's say I wanted to do the same thing that we had up here where we had our high spenders, right? So we selected and we summed all the orders based off of grouping them by customer ID. So it's a lot again, but let's do that here with a left join. And there's going to be a slight difference, right? Because we have nulls. So if we do this, select first name, last name, order date, and amount from customers, left join orders, and we do a group by customers.id this time. So that will group by customers so that we have these two grouped, on his own, on her own. And actually Blue is a girl. I'm sorry, Blue. Okay, so if we do this, we won't see much difference. Well, we will see a difference, but it's not very meaningful. What am I missing? Extra semicolon. Not that useful because it just condenses our data and hides stuff. But if we go through, and I'll format this again, let's sum together everything, right? So we'll sum, and inside of here, we want to sum amount. And we don't actually need to have amount there. And we can get rid of order date too. So let's just have the first, last name, and then sum. Okay, so this is accurate, that's accurate, that's accurate. We still have null here, which it can work. But it would be nice if instead it just said 0, because they've spent $0. So how do we do that? And this is not this is not a join specific thing in any way. This is just an interesting problem. How do we get, instead of null, how do I replace that with 0? And there's a couple ways. The first really lengthy, awful way is to use a case statement. So I could have a case statement where I checked, is some amount is null? Remember, I can't just say equals null. But if I said it's is null, then do 0. Otherwise, do some amount. But that's kind of long. So it's going to be much easier if I use what's known as if null. And I haven't shown this to you yet because we didn't really have many cases where we had null data. But here's one. So what if null does, it takes 2 arguments. The first one is the thing you want it to check if it is null or not. So we want to check, is sum of amount null? So here it's not, right? It's not null. It's not null. Here it is. So then the second argument is what we want to replace it with if it is null. And we'll just say 0. So it's very simple. It checks if the first argument is null. If it is, it replaces it with the second argument. If it's not, it leaves it as the first. So now if I try it, perfect, we get 0. We should definitely add an alias. Let's call it total spent again. Okay. One other thing that would be nice is to order by total spent. And this time, let's do it from least. So we'll just do order by total spent. And that should work. There we go. And now you can see we have 0. Okay. So we kind of talked about a lot. There's a couple topics that touch on each other. The first thing, just to recap, was that I wanted to show you when we do joins, any joins, they're not fancy special tables. They work just the same way as any other table. So we can do things like group by and order by. Then the next thing was that we saw inner joins. If I go back, we saw this. And then we also saw a left join. And the key difference, they both join data from 2 tables, but the key difference is what data they join. So we give them a condition, but even given the same condition, in our case, it was join on customer.id equals orders.customer.id, this middle part. And on inner join, that's all we get is the exact overlap. On a left join, we also get the left part in addition. So every customer in our case, which can be useful if we wanted to see things like which customers hadn't ordered things, which is what we got here. So hopefully that explanation made some sense. I totally understand if it didn't. This is a tough thing to really wrap your head around at first. Now, it's not terribly difficult once you get going with it, but understanding it can be super intimidating. So if you're in that situation, we will have exercises coming up in just one more video after this. And I recommend you try and go through those. And if that's not enough, then absolutely ask for help in the forums here. This is one of the crucial things that, in my experience, sometimes takes students a couple of maybe hours, a couple of days, not like 12, 20-hour days. I just mean sleeping on it once or twice to help kind of get some space in your brain. Anyways, hopefully you're able to kind of get where I'm going with this. Next up, we're going to see our last type of join, which is a right join. Very simple. Well, it's not simple, but very easy to grasp if you understand left joins. Okay, so we hopefully survived the last couple of videos on joins. We had cross join, the useless one. Then we have inner join and then left join. Now we have the sister or brother of left join, which is right join. So this should be a pretty short video. It's very similar to left join in that it takes everything from one column it takes everything from one table along with the intersection, along with wherever the join condition is met, but it just does it from the other table. So in this case, we've been doing customers and then orders. So if we did a right join, it will take every record from orders along with any matching records from table A, which is our customers. Now the thing is, and maybe you've thought about this already, we don't have any orders that don't have an existing customer. So we're actually not going to see a difference. But I'm going to come up with a way. I'll show you a way for us to see a difference. But to start, let me just show you the syntax. Okay, so let's hop over to Cloud9. And here's our simplest left join that we wrote. Remember, it does this here, where it includes everything from customers, David Bowie and Blue Steel included, even though they don't have any matching records. And then it also includes all matching records. But rather than that, I'm now going to go and retype it down here as a right join. So we'll do a select, and we'll just do star from customers, and then we'll do join orders on customers ID equals orders dot customer ID, just like that. However, if we leave it like this, remember, if we don't explicitly say what type of join, it's implied to be an inner join. So we can actually start with that because it will be good to see what that looks like and compare it to what we get when we do a right join. So when we did left, which was right here, we have these nulls, and we have, let's see, 1, 2, 3, 4, 5, 6, 7 entries, versus when we do an inner join, we have 5. And if we make it a right join, all we have to do is change that. If I can type right, there we go. Let's try this one. And we have 5 again. 1, 2, 3, 4, 5. And actually it's identical to what we got when we did the inner join. And the reason that's happening, I kind of already went over this briefly, but the reason it's happening is that we don't have any orders that don't have a match with a customer. So everything we have, if we go back here, everything we have in the orders table has a matching customer. So there is something to join it on. So for every order, we actually have 5. This table only has 4, but we have 5 in our database. Then there's only going to be 5 joins or there's going to be 5 records that are joined when we do a right join. When we did a left, we had we had a couple of users who didn't have any records, who didn't have any orders. So these customers like David Bowie and Blue Steel didn't have a match, but we still included them. So how can we actually see something different? How can we tweak our data so that a right join actually results in something distinct? Well, there's a simple thing we can do, which is to screw with our data, to mess with our data. So that's what I'm going to do here. I don't necessarily recommend that you follow along exactly because I'm going to be messing up some of the data. I'll fix it towards the end of the video, but I don't want you to have to go through that process if you don't want to. So it's not essential. What is essential is how the join will work, which we'll get to. So the way that we would have a difference, we'd have a unique result between right and inner, is if there's something that we have on the right table, which for us has been orders. In the orders table, if there's something in the orders table that doesn't have a match over on the left, that there's no join, so that would mean that there's no customer. And right now, it doesn't make sense, honestly, to have an order without a customer. But maybe, let's say, someone accidentally deleted stuff from our database. Or maybe there's a wrong ID, a wrong customer ID in our data. We would be able to spot that using a right join. So what I'm going to do is hop back to Cloud9, and before I do anything, I'm just going to rerun this early inner join we did. So as we can see, of course, on the left, we have customers. On the right, we have orders. And we have Boy George, who has 2. Let's say I were to delete Boy George, and then I ran an inner join. Well, these would be gone. And we would only have 3 customer orders, right? But if I did a right join, we would have order, and null over here. So it takes all orders, regardless as to whether they have a matching customer or not, and they'll fill in null if there isn't a customer, and then if there is, the appropriate information will be filled in, just like it was with left, except, the opposite direction. So let's try that. Let's try deleting a user or a customer. Let's delete Boy George. It's been a while, but that's going to be delete from customers. I keep calling it users. Where, and we could do it based off of ID. Let's do it based off of first name. First name equals boy. Just like that. Now, what do you think will happen? Oh no, an error. And you may have anticipated it being a syntax error based off of my typing proficiency, but it's not. It's a deeper error. It's an error that has to do with that foreign key constraint we set up. Because if we try and delete a customer that an order is referencing, we have 2 orders referencing it, that's a problem according to our foreign key constraint that we set up here. Remember that this doesn't let us create an order with a faulty or non-existent customer ID. So it also won't let us delete a customer up here if it's dependent on down here. And I kind of did this on purpose here to show you a solution to this. Not to let us delete things willy-nilly, but how could we, if we deleted a customer, how could we automatically have it delete all orders associated with it? Which is a pretty common thing. If you have data that's dependent on another piece of data, let's say we have books and reviews. Well, if that book is deleted for some reason, we don't want all these reviews that are just pointing to an empty or gone book. So we would want to link them. So if I delete the book, all associated reviews get deleted. And I'll show you how to do that. But the first thing I'm going to do is delete these two tables. I'm going to remake them. And this is the part I was saying you do not need to follow along. So let's do that now. Drop table. And we have another little surprise in store for us. If we try and drop table, and let's just do customers, what do you think will happen? Same issue. We can't delete customers because orders depends on it. So what we can do is delete orders first and then customers, or we can do it in one line like this, orders, comma, customers. Well, if I put an S there. And now, of course, I messed it up because orders is already gone. So if I had typed that correctly, it would have worked, but we'll just delete customers separately. Now, if I do show tables, there's nothing there. Okay, so the reason I did that is I want to remake our two tables very simply. So I'm going to copy this. And this is why I was saying you do not need to do this yourself necessarily. And I'm going to change one line. I'm going to get rid of the foreign key constraint, just like that. Everything else should work exactly the same. So I'm going to remake the customers table, remake the orders table. I'm going to insert our customers, and I'm going to insert our orders, just like this. Okay, so if we do a select star from customers, let's say, we have the same data, same thing from orders. But now what I'm going to do that I couldn't do before is I'm going to insert a new order. So insert into orders, and I'm going to insert, what do we have? Order date, amount, and customer ID. And I'll do two of them. And so the first one will be something ordered, let's say 2017/11/05. And the amount was $23.45. And the customer ID, this is the important part that I'm trying to highlight here. I'm going to put something in that doesn't exist in our table. So let's say 45. And I'll do one more. I'll do, rather than this, let's get a little practice. Remember using cur date, gives us the current date. Let's do that. So we'll do cur date here, comma, and this purchase was for 777.77. And that was made by someone with ID 109, which also doesn't exist. Perfect. So now let's insert those. Didn't seem to have any problems. Let's look at orders. Yeah, it's here, right? We have customer ID of 45 and 109. And the reason this works is we got rid of that foreign key constraint, which I'm not saying you should do, by the way. I'm doing this to illustrate and make a difference in our data. So let's suppose we're inheriting someone else's database and they decided not to use they didn't know about foreign key constraints, so they didn't use it. And then they had users, they used to have all the way up until 109 users or customers. And then a lot of people left. They just deleted their accounts. Let's say something bad happened. There was a hack, a data breach. Everyone got scared away. And then all we were left with are these customers. It's pretty sad. So it's a great bunch of customers to have, honestly, but still only 5 compared to 109. Keep in mind, this is all a dumb made up story. But what we could do is use a right join to basically identify all of our customer and orders and their associated orders, as well as any orders that don't have an associated customer. So we could fill in null. So if we do our join that we had done earlier, I'm just going to scroll up to save time. If we do this join here, which is an inner join, or that's actually a left join, let's do this one right here. Nothing changes, right? We still have Boy George and his associated 2 orders, George Michael, his 2 orders, Betty Davis, her 1 order. And then if I did a left join, which we could just do by simply changing that one inner to be left, or we can just do this here. And I'm only choosing this one because rather than star, this has a smaller subset of data that's easier to look at. Okay, so now we end up with this, which still is unchanged from when we did it in the last video, because there are orders that have no customers, but they're not here because we did a left join. And the left join takes everything from customers and any associated matching data from orders. But now, if we do the same thing down here, if you can hear my cat meowing, and we just change it to be right join. So we're still just doing first name, last name, order date, and amount from customers on the left, or from on the left is the wrong term, but from customers first, right join with orders, so that we take everything from orders like this, everything from orders and any overlap from customers. Let's try it. And you can see exactly what we expected happened. So we still have all of our orders that match, customers and orders. But then we have those 2 orphans that we added in where there is no matching customer. So we end up with null first name, null last name, null first name, null last name. So that's basically all I wanted to show you with right joins. But like I said, we will have actually relevant, useful examples later. But the last thing I wanted to do was hit you with a whole bunch of setup, brand new data, just so that we could see how a right join works. So there is, this is a hypothetical situation that could happen. We could have orphan data like this. So I'm going to show you 2 things now. The first one is that we can still just do anything that we want with this data like we did earlier. We can do more complex selections. And I'm also going to show you a new constraint you can add to your schema so that when something is deleted that has a foreign key depending on it, it will automatically delete the dependent record. But to start, I just wanted to show we can still do things like group by, or we can do things like order by. So we can add that in here. Let's do order by, and let's do first name, just like that. Okay. What about if we tried to group by? What if we did group by, and what if we tried to group by customer ID? What happens then? So it doesn't look like all that much, right? But we can still do our same, we have Boy George was condensed, George Michael condensed, but we can do a sum for amount, just like we've been doing. And we can see how much everyone has spent. Boy George, 135, George Michael, 813, Betty Davis, 450. We still have these 2 nulls. So this is where we can start to make decisions and do things like, okay, if first name is null, then let's replace it with something. So I'm going to format this a bit as we start to get more and more. And we'll replace first name and last name with if null first name. And remember how this works. If first name is null, then it will be replaced with whatever we pass in. So we'll just say missing. And then we can do the same thing for last name. If null last name, comma, we'll say user. So we'll end up with missing user if we do it that way. If we don't have an error, or extra comma here, now we do it. And let's use aliases as first, as last. All right, got a lot going on. Okay, so now we have missing user. And let's say we want to see what the total of our orders are where we don't have a user. So basically the orphans, we want to group those together as well. Right now we're grouping by customer ID, but what if I wanted to group these 2? what we could do is change customer ID to be first name, and we'd want to do comma last name rather than just first name because we may have multiple people with the same first name. So if we do this now, you'll see that we end up with missing user has 801 total spent, then Betty Davis 450 and so on, and we could order it. I think by now you understand what I'm trying to show, that these tables aren't special. You just have to be comfortable working with null, and if null is kind of your best friend when you're doing that. Okay, so then the very last thing I wanted to show, I keep doing that, go away. The last thing I wanted to show was how we do what's known as on delete cascade. So this is what I was talking about. When we delete, if we have a foreign key relationship, when we delete a parent, so if we delete customers table, not the whole table, but let's say we delete Betty Davis, we want her order to also be deleted. So it's not just totally on its own. We don't end up with this situation. So how do we do that? Well, I'll show you right now. If you're not interested, then go ahead and skip. This isn't about joins, but I figured it's a good place to put it. I'm going to actually drop our tables again. I'm going to redo, so grab our original schema from way up here. Just copy, how much do we want? Down to here. And we still have our foreign key there. I'm going to indent this a bit. And all we do is add on delete cascade. And all that does is it says when a customer is deleted that has a corresponding order, delete the order as well. So let's try it. I'm going to copy this in. Let's make sure we don't have any tables right now. Perfect. So let's copy it. Then let's copy orders in. And then let's insert our data. And insert our data again. Okay, so as we know, we have data that is joined. I'm not going to spend time going over the joined part. Let's just do select star from customers. Okay, and then we'll do a select star from orders. And let's say we want to delete Boy George. Boy George has 2 orders, these first 2. So if I delete Boy George, these 2 should now disappear. Versus before, a couple minutes ago when we tried it, we had a problem. It's not really a problem, but we ran into trouble that we put in there ourselves because the foreign key constraint didn't allow us to delete it. We weren't allowed to delete a customer unless we deleted the order first. So we're going to do that now. Just try deleting based off of ID, or we could do it based off of first name. Let's do email. Okay, so we're going to delete from customers where email equals george@gmail.com. And we don't get that scary error. Now if we look at all our customers, we're missing Boy George. And if we look at our orders, we're only down to 3. All right, now we're about to move on to our exercises. So you're going to get some practice on your own. Hopefully we have new data, so hopefully it's a little more interesting rather than having to work with the same old data over and over. And then we're going to keep moving on. All right, okay, I'm back with a very quick addition. This is a frequently asked question that I get pretty often, which is there really a big difference between right and left joins if we just change the order of what we're joining? And the answer is no, they're actually the same. So if we do a left join, where this is customers A, and then on the right we have orders, that's identical to doing a right join if instead we put customers over here and we put orders under A. So think of it as just flipping this. There's no difference. So let me show you an example. If we go grab our simple left join from way back here, this one right here, our simplest left join. And I will paste it down here just so you have it to see. And let's paste it in as well. Okay, first of all, there's a lot to look at, right? But what's most important is that we have on the left customers information first, and then on the right we have our order information, right? And then we have nulls where we don't have a matching order. Okay, so what happens if we try and do the same thing, but instead of doing customers first, we do orders, and we do a right join customers on customers.id equals orders.customerID. Okay, so if we do this, look at what we get here. So we have the exact same data, 1, 2, 3, 4, 5 rows, 1, 2, 3, 4, 5, but the order that they're printed is different, right? So we have on the left side now, we have our orders information, and then on the right, we have our customers information. But the actual data that's displayed is the same. Yes, the order changes, but that's trivial. That doesn't matter. So in effect, these are equivalent. And in fact, some environments that I've come across, some development environments, won't even support a right join, and they just want you to do a left join and switch the order. So to sum up one more time, let's say I did the same thing here with orders and customers, but I did a left join. What would happen now? What's a left join with orders first and then customers? And the answer is it's the same as doing a right join, except if we start with customers and then orders. And unfortunately, we don't really have anything to see, right? Because our data doesn't have any discrepancies on the orders side. This is what the entire last video is about, which I will not retread here. But my point is that they look the same, and they look just like an inner join as well. But when we have something different, like with our left join for customers and orders, you can see that the data is actually the same. All right, so we made it through, at least I made it through. Hopefully you're still hanging in there. Hopefully you're alive and you survived that section. I know it can be brutal. This is, for me and for most teachers, the hardest thing to teach. Not because it's technically that difficult, but it's a big thing. We have to have multiple tables, and to have multiple tables, we have to create the schema, we have to insert the data, then we have to show what the data looks like to understand it, and then we can get started with the joins, and you have to manipulate the data to change. It's just a lot of work, and it's tough. It's tough to keep it engaging, and frankly, I don't think that was terribly engaging. So I'm sorry. Hopefully you made it, and I'm doing my best to make the rest of these a little bit more exciting, because once we have these tools in our belt, it's a lot easier to start doing case studies, which we'll be doing, or making a full application. We're getting close to end products, to actually making things, rather than silly one-off little examples. Okay, so it's a long preamble. It's now your turn. And this is where you'll probably, if you're confused, if you're stuck with this join stuff, this is hopefully where you'll be able to make some big connections, to have some breakthroughs. So this is a little different than exercises we've done in the past. There's only one schema, one table you'll be working with, and there's not even that many questions. But the first thing is that we're going to be working with students and papers. So I'm a teacher, let's suppose, I guess I am a teacher, but let's say I'm working in a classroom with high school students in an English class or a literature class. It's going to be very, very simple data. I'm telling you what I'm looking for. Students and papers. And for students, we'll only worry about an ID and their first name. So don't even care about a last name. We'll just make sure first name is unique. And then we're going to have papers. And it's a one-to-many relationship. One student can have multiple papers, but a paper can only belong to one student. So these papers will have a title, a grade, a letter grade, a numeric grade, like 90 or 60 if they don't do particularly well. And then a foreign key student ID, which is referencing the student ID. Okay, so that's the basic schema, and I'd like for you to first go through and actually implement this. And don't worry about the data, because on the next slide, I'm giving you the data. You can copy and paste it in. So this data is what we'll be working with. So we have 1, 2, 3, 4, 5 users, students, I keep doing that. And then we have 5 different papers. But there's a couple important things. One is that a couple of students actually have multiple papers. So for instance, if we take Caleb, his ID is 1, although you can't see that here, but he's the first one inserted. So his ID is 1, and he has my first book report, which didn't get a great grade, 60%, and my second book report, which only did marginally better, 75%. Then we have Samantha, who wrote Russian Lit Through the Ages, and we also have another paper by her, De Montaigne and the Art of the Essay. And then Raj, it looks like we don't have anything from Raj, where his ID is 3. I don't see anyone or any paper with ID of 3. Then we have Carlos, who wrote Borges and Magical Realism. And then we have Lisa, who didn't submit anything either. So let's say, and the whole point of this is that it's the end of the year, and I'm trying to figure out who submitted what papers, what their average grades are. If I need to, talk to somebody about they didn't turn anything in, who's going to fail, and so on. So here's the data we're working with. But the first thing you need to do is write the schema. So just, again, to reiterate, primary key, foreign key. Varchar, integer, integer. Okay, moving on. Once you have that done and you have your data in, you can play around with it, but I'd like you to print this first table. So all that we have here is first the name of a student and their corresponding paper, the title and the grade. Samantha and her 2 papers, Carlos and his paper, Caleb and his 2 papers, and then the corresponding grades. So this is a join. What type of join is it? And you only need these 3 things. So I don't want to see ID, I don't want to see student ID, just first name, title, and grade. And then once you've done that, we have another join. I'll give you a hint. Everything in this section, in this exercise, involves a join. This one is different because we have the same basic stuff, Caleb and his 2 book reports, Samantha, her 2 papers. Raj, though, null title, null grade. Raj didn't have a paper. Carlos, Borges and Magical Realism, and then Lisa, null, null. Lisa doesn't have a paper either. So print this out. It's a different join. Then once you've done that, move on. Similar, but notice instead of having null and null, when a student didn't turn any papers in, we now have missing and 0 for their grade. Missing for title, 0 for their grade. So it's the same thing here. We're just subbing in. Okay. Then we get to this. This is going to be an average grade next to every student. So we have Samantha, and the average of her 2 papers is 96. Carlos, the average of his 1 paper is 89. Caleb's average for 2 papers is 67.5. Raj has an average of 0 because he didn't turn a paper in. And Lisa has an average of 0 as well. So I won't give away too much about this, but you can use the same join you used here. You just then need to condense it. We need less information. You'll need to, I'll leave it at that. And then finally, print this. An extension of what this one was, except there's a new column, which is passing status. And passing status just says if the student is passing our class or not. And the threshold, I should have written this out. The threshold is if they get a 75 average in the class or higher. So Samantha passes, Carlos passes, Caleb unfortunately is below 75, so he fails, as do Raj and Lisa. All right, so there's a bunch of joins you need to write. First things first, though, get the data in there. Create the schema, get the data in, play around with it, and then attempt these, 5 joins? And I'm back here with a solution, or multiple solutions, to go over these join problems. So again, this was a one-to-many relationship, students and papers. And the first thing we're going to do is go over to Cloud9, and I'm just going to work in the same database, but I'm going to make a new file just because it's getting crazy. And I'll call this one studentspapers.sql. Okay, so we know we need to create 2 tables. Create table students, and I'm just going to leave it empty for now. And then create table papers. Also leave it empty. Great. So next, what do we put in them? So we'll start with students. Simple. It's an ID, but we said it's a primary key, integer, which means it should also auto-increment, unless we want to do it manually, but we don't. And then first name is a varchar. So we have ID, int, auto increment, primary key. And then we have first name, which is just varchar, and we'll do 100. That's a good, even, nice number. So that's it for students. But then we have papers. So papers has a title, grade, and student ID. Let's start with just title, grade, student underscore ID. Perfect. And I'm noticing, I capitalize this. It doesn't really matter, but it's going to be annoying to remember that, so I'm just going to put it back as lowercase ID. So we've got title, grade, and student ID. Title is a varchar. We'll also do 100. Grade is an int. And then we have student ID. And student ID is a foreign key referencing students.id. So it's just an integer, and this sometimes trips people up that we just write student ID int, and then the next line is foreign key. The field that is foreign key is student ID, this right here, and we need to say what it references. So it's referencing students table, the ID field. Okay, and we could also indent it like this, because this has to do with this. And then if we wanted to, which you did not need to do, but this is where we could add on delete cascade, which you may, and we saw in the last video or 2 videos ago, it's not necessary here. We're not deleting anything, but you could put that there. Okay, so the next step is now just to create them. So before I go too far, I did catch this. I have an extra semicolon there. Get rid of that. But we'll create our students table, and we'll create our papers table. Everything looks good. And if we do show tables, I'm still working in our same database, so I have customers and orders. That's fine. But I have papers and students. Okay. And we haven't done this in a while. How about we describe students? Cool. So we now have auto increment in there, primary key, and that's for students. And what about papers? If we do describe papers, well, you can see we have title and grade, and then student ID. Okay, so next up is to get our data in there. And I said that you definitely didn't have to do this yourself. So I'm just going to put it in this file so you have a solution file. But it would be annoying to type this. I had to type it. I totally get it. So paste that in. Perfect. So now we can do a select star from students, and we should see our 5 students, and do a select star from papers, and we see our 5 papers with student IDs. Great. So the first thing to do was to print this join table where we have first name, title, and grade. Nothing else. First name, title, and grade. Where, and what's our join condition here? Well, basically where the student.id is equal to the student ID in the paper. And this we could accomplish through an inner join. That'd be the easiest way. We could also do it with a right join if you wanted to, which we'll take a look at, but an inner join is the simplest way. And I'm going to do an explicit inner join. So that means select, and let's start with star from, and let me put a number here, exercise 1. Select star from, I'll do it on a different line, from students, join papers on students.id equals papers.studentID. And let's be explicit with inner join, just like that. So if we take a look, you see we have the right data, right? We have Caleb and his 2 books, Samantha, or 2 reports, Samantha, her 2 essays, Carlos and his 1 essay, and we have the grades. Now we don't want ID and student ID. So we just need to get rid of that. And the simplest way is just to explicitly say what we want. So grade, title, and grade. Okay. Now we do it, and we're good to go. There's one thing, and this is my fault for not mentioning, in the instructions. I did order this, and totally fine if you didn't do it. If you did catch it, congratulations on looking at that. I didn't. I forgot. I did this late last night when I created these slides. I'm recording it the next morning. So this was ordered by grade. So that's simple too. Just going to be order by grade. And what order is it? Well, it's descending. Now we do it. Now we have the correct answer. The other one was correct too, I promise. The only thing that I'll address here is that I mentioned that you could also do a right join. And why is that? Well, let's just verify, see if I'm crazy. Nope, it still works. Phew, good to know. I'm just kidding. But the reason that it works is because if we go back to our slides way back, when we do an inner join here between students and papers, all of our papers have a student they belong to. So basically this section is the same as this entire section here, the same as this. If we pretend that left join doesn't exist, ignore that slide, this intersection is the same as this because every paper has a student ID in it. So you could also do a right join. Nothing wrong with that. But I think the inner join is easiest, although it's easiest because it's just this is how I think about joins most of the time, but it's not any easier because it's just a single line or a single word that we're changing. Okay, so I'll just write alt solution. Okay, moving on. Print this. So very similar, right? Caleb, Samantha, their respective books, but then we have Raj and Lisa who didn't write any reports or any papers, and we have null in place. So this is a left join. And the way that we're going to do that, if we go back to our slides again, we're going to grab everything from students and then any associated papers, but some of them don't have papers, and those will then be filled in with null. So let's do this now. We'll call this, let's call this problem 2. And we'll start with select star again, and then we'll alter that from students. And then we need to do a left join. Papers on students.id equals papers.studentID. And we'll leave it at that to start. And you can see it's working. We've got Caleb and his stuff, Samantha, her essays, her papers, Raj, null, 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 Lisa, null, null, null. So we're getting every single student, Caleb, Samantha, Raj, Carlos, Lisa, and if they have a matching join condition in the papers table, then we also get their paper data. But if they don't, we have null. The only thing left is to whittle it down to first name, title, and grade. Just like that. Let's verify. Okay, and is there any sorting here? No. Then we're done. Okay, so problem 3. It's very similar, but we're going to then substitute in for null under title, we want it to say missing, and under grade, we want it to say 0. So we can actually just use the same thing, so it's going to be select. I'll do this on separate lines. First name, comma, title, comma, grade. From students, left join papers on students.id equals papers.studentID. Quite a mouthful. However, when we're working, so first name will be the same, but title, we're going to, if it's null, we're going to make it the text or the string missing. And that's where our lovely if null function comes into hand, or it's handy, let's say. So, comma, and we'll just replace it with missing. So remember, I'm beating a dead horse, hopefully at this point. If null takes this, if title is null, then it replaces it with missing. Otherwise, it just keeps it as my first book report, my second book report, and so on. So we'll start with that. You can see we get missing, but we still have null for grade, and that's a simple fix, the same thing. If null, grade, comma, and we want 0. Not text, not a string 0. We want the number because this is an int over here. Perfect. And we're done. We get missing 0. missing 0. And then things that didn't have null are untouched. All right, moving on. This one is similar in that we want to have data for students who don't have papers, so Raj and Lisa. So this is not going to be an inner join. We know that because if we did an inner join, we would only get these 3. We wouldn't have anything on Raj and Lisa. Our students who maybe aren't doing so hot, they're not turning things in. But what we want is only the first name and their average for all their papers. And if they didn't turn anything in, their average is 0. So what this really means is we need to group. We need to group our students. And we're going to start by selecting all of this. And we'll get rid of our if nulls. So let's just do title again. And we don't even need title, do we? We just want grade. We'll start with that. So if we do a left join, okay, we get this. This is actually close, right? The only thing is we need to condense our data. We need to group these together. So what's the best way to group them? Well, we could use first name. That would absolutely work. They're unique. We could not use on the papers side of things. We could not do papers.studentID because Raj and Lisa don't have papers.studentID. So that's null for them, which is problematic. We can't really dependably group by null. And also, we don't want to group Raj and Lisa together. So we want to group from this side of the table. And we could do names, but there's also something else that we're not seeing. If we do star, we can just group by students.id, as you can see here. So what I was saying is that student ID doesn't work because these are null, and if we group, we don't want these together. We want them separate. So let's group by students. And we could get away with just saying ID because there is no ID on our papers table, right? We didn't have ID, which we probably should have just for good practice, but we don't have it. But if we did have it, then we definitely need to be explicit and say students.id, and it never hurts to do that. So we'll group by students.id. And if we copy it and we paste, okay, so we're getting close, sort of. We have things grouped, and remember that hides data from us because it's grouped behind this row. 2 of Caleb's papers, 2 of Samantha's, but we're at least getting data grouped. So then the next thing is rather than displaying grade here, we don't care about grade. What we want to display is the average of all the grades for those 2. So Caleb has 2 grades, 60 and something else. Samantha has 2. Raj has, we'll have to deal with that in a little bit. Carlos has 1. Lisa has null. We'll deal with that in a second as well. But let's see what we get now. Okay, so we get 2 averages, 67.5, 96, and 89. 3 averages, excuse me. And then for our people who don't have papers, we end up with null and null. Simple solution. If they don't have any papers, we just use if null. If null, average grade, then we just want to make it 0. Just like that, before I deleted it. And now, you can see we get Raj and Lisa have 0s. And if we check against what we had here, there's only one small change, which is we need to order them. Descending order. By order by average. And actually, rather than doing average grade, let's just give this an alias, which is what I did over here. I just called it average. Now we can do order by average. Perfect. And there we go. Well, nope, I lied. Order by average descending. And now there we go. Okay, perfect. Moving on. Our final problem. Same thing, although we're just now adding a passing status. So a new field that doesn't exist in either table. And that says passing if the average grade is greater than 75 or equal to 75, and failing if it's less. So this is a great use for a case statement. Okay, so let's give it a shot. This one is very similar to the previous problem, so I'm just going to copy it, paste it, and just rename it problem 5. So all we need to do is add in another field, but this field involves a case statement. So what I like to do is always do my case and end together. Case end, and we'll call this passing, was it passing status? There we go. Okay, so what do we fill in here? We're basically trying to say when average of grade, so we'll copy that, is greater or equal to 75, then what do we want? We want it to be passing. Perfect. Otherwise, we want it to be failing. And let's see what happens. Okay, so it seems to be working. Passing, passing, failing, failing, failing. One thing to note, though, is that when we're doing average grade here, for some of them it's null. Remember that. And so it's important to realize, if we work with null, is null greater than or equal to 75? And the answer is null, which is bizarre, right? Versus if we had done is 65 greater than or equal to 75, we get 0 or 1, true or false, but we're getting null when you work with null. Fortunately, that is working to our advantage, because when we get null here, it basically the case statement moves past it, ignores it, and does the else. But it is important to understand that. So you could do something like this if you wanted to be extra careful. When average grade is null, then failing. So that would catch null right away. Then we have, okay, when it's a number greater than 75, equal or greater than 75, then passing. Otherwise, that means it's a number that's less than 75, and that means failing. So we won't see a change in our results here, right? It looks exactly the same. Passing, passing, failing, failing, failing. Passing, passing, failing, failing, failing. The difference is that we're not relying on this weird comparison between null, because it is bizarre. Is null greater than or equal to 1? And it tells us null. It just is useless. Null is a weird special value that has things like is null. So let's take advantage of that just to be safe. All right, now we're done. Hopefully you enjoyed some of that. It's a little bit different than some of the exercises we've done in the past. Involves joins, but hopefully it's not too scary. And if it is, I'm sorry. I'm sorry. Hang in there. Hey, welcome to the next section. So I'd like to start off this section by asking you a question. It's not really a quiz or anything, but I just want to know why there's a chicken on my desk. And in the meantime, Blue and I are here to talk to you about the next section. So we're continuing on our trend of working with multiple tables. We saw a one-to-many relationship in the last section. Now we're moving on to a many-to-many relationship. And I saved this one for second. It's a little more complex. Don't be afraid. It's still very doable and very important. I keep saying that. Very useful to be able to have multiple tables with a many-to-many relationship. So we're going to focus on this section on implementing a schema for TV shows with reviewers and the reviews that they write. So think of Breaking Bad and American Horror Story, or two different shows. We'll have a bunch of them. I'll give you data. And then 10 different human reviewers, maybe a cat or two as well. And these reviewers can go and assign ratings to every show. So I could say, this is a 10, that's a 9, that's a 4, whatever. So that's what we're going to implement, that sort of a schema, which is a many-to-many relationship. Hey, stop eating that. Eat the chicken. So, okay, where was I? Exercises, yes. This section is all exercise, basically. The way that I decided to do it is to go through not only building the schema, but also asking common questions about the data and performing common operations and the joins we want to perform basically as we go. So the whole thing acts as a bit of a code-along / exercise. So hopefully you like television. If you don't, then this will be a great insight, great window into the world of television for you. But more importantly, we're talking about joins again, working with multiple tables. All right, welcome to the next section. So we're continuing on the similar path, talking about relationships, talking about joins, more complex data, multiple tables, and connecting those tables, drawing lines between them. However, we're now moving on to our next relationship, which is the many-to-many relationship. So we saw how to do a one-to-many which is a pretty standard relationship and it's pretty common. Many-to-many is common as well, maybe not as common, but still very, very common. So we're going to see how to do it, and the reason that I saved it for last is that it's a little bit trickier. It's not hard, I don't want to scare you away, but you'll see there's a little more setup involved. And then once we've discussed on a high level how many-to-many relationships typically work, we're going to implement one using some relatively complex data that I spent way too long creating, and then we'll do some problems together. So this section will actually serve more as a code along. So I would encourage you, if you don't typically, I encourage you to follow along. We're going to use some relatively complex data, like I said, and we'll just go through it, do a couple exercises together, and I'm going to use it as a way to illustrate how joins work on a many-to-many relationship. So let's start in this video just by talking about the many-to-many relationship. So we kind of discussed it briefly in the last section, but here are a couple examples. So books and authors, harkening back to that last section where we saw books. A book can have multiple authors, right? There are lots of books that are written by co-authors or teams of, if it's a collection, if it's an anthology, there might be 20 authors. And each of those authors can then have multiple books. So it's a many-to-many relationship. Books can have many authors. Authors can have many books. Or another common example is blog post or some sort of content, whether it's an Instagram photo, a Tumblr, whatever you call it, a Tumblr post, or just a traditional blog, some sort of content, and then tags. Tags, by that I mean things like, sunset picture, or there's some really silly, like van life, if you're familiar with that hashtag. Or I do a lot of photography, so I see a lot of tags that are things like masterpiece landscape photography, and then Insta good if you use Instagram. There's all these different tags that are out there, and each post can have multiple tags. So there's a limit sometimes, but on Instagram you can have 30 hashtags, I think it is, on a photo, and then each of those tags can then have as many posts or photos as necessary. So that's another example. And the final example I have here is students in classes. So we're talking about like maybe college students or university students, where students have multiple classes. They pick their classes at the beginning of the semester. One student usually must have multiple classes, unless maybe it's your last semester, but you have multiple classes that you go to, that you're related to, and then each class is going to have multiple students in it. And that's a many-to-many relationship. And the one that we'll be working with in this section is actually not listed here. It's a little different. And to start off, I want you to imagine that we're building a TV show reviewing application. Like, yes, I know we don't need any more of those, but imagine something like Internet Movie Database. Very, very simple version though. But we're working with TV shows exclusively. And the key idea is that we can have someone who signs up as a reviewer. We can have TV shows that, let's say some of the ones I'm using, Fargo, the TV show, Archer, General Hospital, any series. And a reviewer can then rate any of those series. So I could sign up and rate Archer as a 8.5 out of 10. So to accomplish this relationship, a many-to-many relationship, where we're basically associating users, or reviewers we'll call them, with TV shows, we need to actually use 3 tables. We use what's known as a join table or a union table. So we have our series data up here. So these would be the TV shows. And then down here, we have our reviewers data. So these would be just names in our case. We'll keep it very simple. This will be Colt, or this will be Charlie, or whatever it is. But the way that they're connected is through a third table, through a reviews table. So this will make sense when I show you the schema in just a moment. But think about it this way. Series exist on their own. They're just TV shows. Reviewers exist on their own. They have nothing to do with a series out of the box. It's just someone's name. But they then are associated through this reviews table. So this reviews table will have information on the TV show that's being reviewed, and then the reviewer who is doing it, as well as a third piece of information, which is the rating. What's the number, the numeric representation of that review? So without further ado, let's take a look at our schema. We have 3 tables: reviewers over here with an ID, primary key, first name and last name. And of course, in a real application, we would have more data here, right? We would have email. We'd be storing our password in a safe, protected way. We would have things like registration date, maybe last active, all that kind of stuff. But to keep it simple here so we can focus on the relationship, focus on the joins, I'm only doing first name and last name. Then we also have series. And, this is something I actually debated. The plural of series in English, modern, traditional, spoken English, is just series. However, a lot of people would argue that we should name this table series with an ES on the end, just to make it clear that that's the table name. I'm not exactly a fan of that. It's really determined by the project or the team you're working with, or by you if you're working on your own thing. I've worked on projects where we had to abide by that, where the plural was always with an S afterward, even if that meant mouses instead of mice. But I'm going to leave it as series just because I think it's simplest. So series has a primary key ID, a title, so that would be Fargo, which is a TV show as well, really good TV show actually, not just a movie. So Fargo, or Halt and Catch Fire, Seinfeld, and then the release year, so 2014 or 2002 or whatever it is, and then a genre, which we're going to keep very simple. We're only going to have animation, comedy, and drama. So just a couple of examples of genres. But again, these on their own are just separate entities. Where they're joined is through this third reviews table, which is what's known as a join or union table. It's connecting these two. And the way it's doing that, well, first of all, it has an ID. Nothing special there. Every review has an ID. There's a rating. So this would be, 5.0 for a mediocre show, or 9.9 for a fantastic show. And then the series ID. So that's going to be a foreign key pointing to the series table. So what series? Is this Fargo? Is this Seinfeld? And then the same, well, not the exact same, but the same idea for reviewer ID. It's going to be a foreign key pointing to the reviewers table, the ID field. So then a single review will have an ID, it will have a rating, 9.0, a series ID, like 1, and then a reviewer ID, which could also be 1. They're pointing to different tables. So this is a centralized repository or centralized place for our information to be stored. It's connecting these two tables through this table. So hopefully you can see how this is going to work. Basically, reviews on its own is going to be a pretty ugly table to look at. It's just going to be numbers. It will have an ID, which is a number. Rating is a number. Series ID is a number, and reviewer ID is a number. So looking at it on its own is actually going to be very confusing. It's not going to make sense. So we'll have to use joins to be able to understand things, so that we could use a join to replace series ID with the name of the series, so that it says Fargo instead of 1. Or it will say Blue Steel instead of reviewer ID 3, and so on. So that's our basic idea here. Here's an example with some simple data. Very, very simple, 2 reviewers. So we've got Blue Steel and Wyatt Earp, ID of 1 and 2. Then we've got 2 series, Archer and Fargo. If you're not familiar with these shows, don't worry. That's not necessarily relevant. Archer is animation, released first in 2009. Fargo is a drama with a little comedy, released in 2014. Archer has ID of 1, Fargo has ID of 2. So they're independent. But then our reviews table, well, somebody reviewed something with a rating of 8.9. The person who did that has a reviewer ID of 1, so that is Blue Steel. So Blue Steel reviewed something and gave it an 8.9. Well, what did she review? Whatever has series ID 2, so Fargo. So Blue gave Fargo an 8.9. Then we have a 9.5 down here, and the reviewer ID is 2, so that's Wyatt Earp, this field or this row here in reviewers. Wyatt Earp also reviewed Fargo because it's ID 2. As we can see, corresponds to Fargo. So essentially what we're storing here, Fargo has been rated twice. Once by Blue as an 8.9 and once by Wyatt as a 9.5. So as you can see, the data is not that pretty in this table, and this is only with 2 reviews. We'll be working with somewhere around 100 reviews, which is a lot of data to look at on its own. And so we'll really be focusing on making that data understandable, readable, which is really the point of this entire exercise. So we're pretty much done here in this first video. We didn't actually do anything except discuss our schema. But in the next video, we'll actually go about implementing the tables and inserting some data on our own. All right, so let's hop over to Cloud9 and we'll start simple. Let's work with the reviewers table. It's the simplest one. So we're going to implement that first. So we'll go over here. And just to be totally transparent, I created a new database just so we have a fresh place to work. You don't have to do that as long as you don't already have tables named series, reviewers, and reviews. If you do, you may want to make a new database. So I'm working in one called something ridiculous and stupid that I probably will regret. TV review app. Yeah, not too bad. So we're going to start off by creating a table which we're going to call reviewers. I swear to God, Blue. Stop. Calm down. Calm. So we'll start off by creating our table, which we'll call reviewers. And reviewers only has 3 things: ID, first name, and last name. So we'll start off with ID, then first name, and last name. And we know ID needs to be an int. This should be familiar by now. Auto increment, primary key. First name will just be varchar 100, and same thing for last name. So pretty straightforward table to start with for reviewers. The next thing that we'll move on to, before we insert things, let's actually get our tables going. So all tables first, and then we'll insert our data. So next up, we'll do series, ID, title, release year, and genre. So create table series. And inside here, we'll have an ID, which will be exactly the same. Auto increment, primary key. And these primary keys are especially important because we're going to use them as foreign keys in the reviews table, and we need to have valid rows that we're pointing back to. So we need to make sure whatever the series ID is here, that it's actually a series in our database. It's not pointing to some non-existent show or non-existent reviewer in the case of reviewer ID. Okay, so the next thing is the title of the series, which we'll just make a varchar. And then once we do that, we'll move on to release date, or released year in our case. And we have a couple of options for the data type here. So we could make it a date, but all we want is the year. And a date has this kind of format where we have the year, and then the months, and then, and so on, which we don't care about. So we could make it an int, and that would work, but then potentially someone could accidentally insert something with a release year of like 10,000 or 9999999, which is not a valid year. So there's actually another data type that we can work with, which I haven't shown you. It's just called year. And if we do year 4, it will be a 4-digit year, like 1999 or 2004. There used to be a year 2 type, but I believe it's been deprecated now. So we'll work with year 4. That's not the point of this lecture, so don't let that hang you up. I just wanted to show you that it exists. So we have that. And then the next thing that we have is genre. And genre will just be a varchar as well. Okay, so we have those 2 tables. Now let's actually start with those, and let's make sure that they work. So there's our first one, and here's our second series. Great. Now what I'm going to do is actually insert some data. We'll come back to reviews in a moment. So I have a bunch of series data here. You can, of course, copy and paste it from the included code, which is what I recommend you doing because this took forever to type. Although it's not as bad. I'll give you a preview of what our reviews data looks like. That was a pain to type. So this isn't as bad. But we've got shows, most of them are shows that I picked because I like, but I also picked some because I didn't like them, so that we have some variation and in the ratings in particular. I wanted to make sure that our data was realistic and not everything was a 9.0. So I'm just going to copy this over, put it in this file so we have a record of it, and I'm going to insert it and make sure it works. Okay, so that was 14 series we just inserted, and I'll do the same thing for reviewers. We only have 7 here, but that's plenty. And we'll paste it in. Now let's make sure it works. Let's do a select star from series to start. You can see, if I make this a bit bigger, here's all of our series. Archer, Arrested Development, Bob's Burgers, all the way down. We've got animation, comedy, and dramas. And then let's do a select star from reviewers. And we've got 7 of them, totally random names, except I did put myself in there purely so that I could review my own shows that I like. Everyone else has fictional, just totally made up reviews, but the ones that I put in there are relatively accurate to my personal TV tastes. Okay, so then that leaves us with having to now implement the reviews table, which we left for last because, for one thing, it depends on these 2 tables, and it's also a little bit more complicated. So let's get started. Scroll back up. I like to do all of our kind of schema code up top. So we'll create table, and this is reviews. And the first part's easy, or easy enough. We'll have an ID, which is an int, auto increment primary key. And then the next part's pretty simple too, which is rating. Now, what data type do we want rating to be? If we look at the examples I've given you, we have 8.9, 9.5. So we could have just done an integer, and that would work. But that's not the way that we're going to go here because we want decimals after it. So we could have just only allowed whole numbers from 1 to 10. But instead, we're going to do sort of like IMDb does, where they have a decimal system. And our maximum rating will be 9.9, so 0 to 9.9. So that's going to be a decimal. And if you think back to the section on data types, there are 2 things we pass into the decimal. The first is the total number of digits we want allowed, which is just 2. Because we only want things like 4.4. We don't want 43.4. We don't want 99.9. And then the second is how many things or how many numbers after the decimal place. We just want 1. So that will give us 2 total numbers, like 9.9 or 5.6, something like that. So that's all we need there. Now we get to, if we go back, series ID and reviewer ID. So both of those will just be integers. So we'll just start with that. Series ID is an int, and reviewer ID is an int as well. But of course we're not done, because now we need to explicitly say that they are foreign keys. Remember from the last section, you don't have to do that. But it's a really smart thing to do to enforce that when you insert a review, it actually corresponds to a valid series and valid review. So the syntax for this, it's been a little bit, but it's foreign key, and then we tell it, we'll work with a series ID first. So we're saying, okay, this field series ID is a foreign key, references, and what is it referencing? The series table, and what field? The ID field. So just like that. And then we'll do the same thing, but this time we're saying this reviewer ID field right here is a foreign key, references the reviewer table up here, the ID field there. Whoops, there we go. Let's make sure we have commas in the right places. Add in our semicolon at the end, and let's see if it works. So there is a mistake in this code. I've already gone back and edited this, but I kept this in here because it's a mistake that I think is pretty common. And it's a little tough to spot. If you look at, maybe you already spotted it, but if you look at the result or the error I get, it says can't create table. It's really not very useful. But what's happening here, typically if we get an error like that, it has something to do with foreign keys here. And the main thing, remember that these are referencing external tables. So we have a series table, but we don't have a reviewer singular table. It's reviewers. So I end up doing that quite often. I see some of my students do that often as well, because sometimes you just talk about things in singular. We have reviewer ID versus reviewers ID here. It's very easy to mess that up. So now, hopefully, it should work just fine. And it appears to. Okay, so we still don't have any data in there. The last thing that we'll do is copy and paste this monster, all these reviews. This was like an hour to try and get this with some realistic data. So I wanted numbers that relatively accurately reflected the quality of shows. Now, you may disagree with it, but copy this in. Definitely don't waste time typing this yourself. Copy it from the code that I've provided and paste it. Okay. So now we should be good to go. I'm just going to add this in here so we have a record of it. And just to double check that everything worked, we're just going to select star from reviews, and we'll leave it at that. So as long as we see our data in here, notice how difficult it is to understand. What does any of this really mean? At the moment, nothing, unless you happen to know, you have memorized the different IDs for series and for reviewers. So that was preparing our data, creating our schema, and inserting our sample data. Next up, we're going to start working with it. All right, so we inserted all of our data, we have our schema ready, and all of our tables created. Now, let's get down to business. Let's do some stuff with it. So I'm going to break every problem that I'm going to give you, and there's quite a few here, into its own video. Hopefully it'll make them a bit more manageable, and you won't want to go to sleep or drown yourself after watching it. So the first thing that you'll see here, the format of these is that I'm going to give you the results. It's much easier just to give you a picture of them rather than trying to describe in a bunch of text what it actually means. It's much easier just to show you. So first thing I should say is that these results are truncated. These are only for the first 15 or so. I used a limit, but I want results for everything. It's just too hard to fit them onto the screen. They would be very, very tiny. But the key thing is that we have title for a movie, for a series, and a corresponding rating. So we're going to need to join those tables together. We need to join the series table with the reviews table, because right now they're not in the same table. We're storing the titles separately from the ratings. So let's do this now. We'll go over to Cloud9, and the first thing we'll do is just start simple. We'll select star, and we'll just start from series, which we've already done. Just like this. One thing I should highlight before we go too far, I did deliberately add some series that don't have any reviews so that nobody has rated them yet. And that was deliberate so that we can work with that later. However, in this example, I only want to see movies, I keep saying that, I only want to see titles of series that have been rated. So we don't have any nulls in here, which is a bit of a hint. So select star from series, and on its own we get this. Now what we want to do is join. So if we do a separate select star from reviews, we want to join basically where this ID of the series is the same as the series ID. So these first, 5 here, 1, 2, 3, 4, 5, correspond to Archer, which is what we see here. So to do that, we don't need two separate selects. We want to do select star from series. We'll do join with reviews on, and where do we want? We want to join on series dot ID equal to reviews dot series underscore ID. Just to reiterate, where this ID of the series, actually it's going to be easier if I do it here, where this series ID is equal to this ID of the series table. Okay. And all we want are title and rating, but we'll start with just getting everything. And let's see if we're in business yet. Well, It's a little hard to tell because we have this formatting issue where we have so much data, things are being cascaded over. But if we look closely, we can see, okay, we have Archer 8.0, Archer 7.5, Archer 8.5, and so on. And if we scroll down, you can see that not every single TV show is here. Like you'll notice the IDs jump. 7, 8, 9, General Hospital, 10, Halt and Catch Fire, and then goes up to 13. So whatever 11 and 12 are, we don't have any reviews. So that's good. Not that we don't have reviews, that's not good, but they're not showing up, which is what we want. So now we'll just whittle this down to title and rating, and that's all we want. And I'll format it a little bit nicer. Here we go. Hit enter. And now we get all of our data. On the left side, we have title. On the right side, we have corresponding ratings. So hopefully what we just did there seemed relatively similar to what we did in the last section where we were writing these joins. What we'll build up to in this section is doing a double join where we have another join statement because we want to connect all three of our tables. But for now, we're working with one table or two tables at a time. Okay, so we're done with that one. Let me just put a comment up here. First, let me just do challenge 1. And now we'll move on. Next video, we'll pick up with challenge 2. Okay, moving on to our next little challenge here. So here's what the end result should look like. We have 2 fields, just like we did in the previous one, but there's quite a bit of difference. If you notice, we have title still, so that's the same, but we only have 1 entry per series. So we don't have, Archer, 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 Archer. We just have Archer once somewhere. Where are you? Over here. But we also have average rating. So this is for all of the reviews, all the ratings for a given title. Put them all together and find the average. And then the other thing is that the results are then ordered from lowest, average to highest. So basically, we're going to work with very similar data, take the same approach, join the same 2 tables. We're joining series with reviews. But then we're going to group them together, and then we're going to average the rating, and then we're going to order by average rating. And just like the previous problem, there are certain series that don't have reviews. They are not showing up here. So we don't need to worry about that. If we're worrying about nulls or non-existent data, that's not a problem for this particular challenge. So we're going to call this challenge 2. Average rating. So if we just actually type a very similar thing, so select title and rating from series, join reviews on series.id equals reviews.seriesID. This is going to get us really close. We have all the data we need right here. This is it. We don't need IDs or we don't need to worry about release years or genres or anything. This is all we need. However, we need to group things together so that all Archer reviews are together, all Arrested Development reviews are together, and so on. So then that begs the question, how do we group them? What's the best way? And there's a couple of approaches that really we could do it based off of the name, the title. But that assumes that there's only one show named Archer, one show named Bob's Burgers, which is probably true 99.9% of the time, but it's possible that we have shows with the same name, or maybe there's a remake of a show. I'm trying to think of, I know there's been examples of this, where there is an older show that's been remade more recently, but basically it's best to not have to worry about that because we're not enforcing that the name of the show is unique. If we go to series, the only thing that has to be unique is ID. So it's much better to group based off of that ID. And of course it's here. Well, we're not seeing it printed out, but we can easily see it if we just add in series.id. So now if we run this, you can see we have that ID there. So even if we had another show named Archer down at the bottom with ID of 15, if we group by the series ID, then they'll be unique and they won't, muddy the averages. They won't muddy the group by. So that should work fine. And we don't actually need that series ID anymore, but we're going to do a group by and we need to do series.id. That's important. If we just do ID, that is confusing because it could also be reviews.id. Just to showcase that, if we just select star, and I'll get rid of the group by. If we just select star, you can see, even though it's still messy, we've got one ID here and we've got another ID here. So this is the series ID and this here is the reviews ID. So we need to be explicit. Okay, so let's undo our changes. Go back to what we had. We're going to group by series.id. And if we just do that, it doesn't get us that far. It gets us closer, but rating is just going to be basically the first one. Luck of the draw, essentially, it's not an average. It's just showing us one rating. Even though they're grouped by this ID here, we're still not getting the average. And that's a very simple thing to change. We just need to do average here, which we should be comfortable with by now. And let's give it an alias, average rating, just like that. Okay, let's take a look. Looking good. We've got title and average rating. A couple things. One, we need to get rid of ID, and two, we need to change the order. So let's start with a simple one, get rid of the ID. Then let's go ahead and at the end add an order by. So how do we want to order them? Well, what about just using average rating? So order by average rating, and then what order do we want? We can work with the default ascending order because that's what I have here, from 5.38 up to 9.9. And there we go, 5.38 up to 9.9. Now, that's basically the end, but I do want to highlight that these reviews are a little bit accurate, in my opinion at least. General Hospital, not my favorite show. It only gets 5.3 on average, probably well-deserved. I'm sorry if that's a show close to your heart. But I want to highlight amazing show that nobody watches called Halt and Catch Fire. I mean, look at this, has a 9.9. How did that even happen? I mean, who decided that? That's real data coming from real people, millions of ratings, and the average is 9.9. Fantastic. Okay, but really, this is a great show. Nobody watches it. I highly encourage you to watch it, especially if you have any interest in computers, the history of computers, history of the internet. Although I will say season 1 is a little slow, but hang in there if you do want to watch it. All right, so we're moving on to our next problem in the next video. Watch Halt and Catch Fire. All right, moving on from the title and average rating challenge, we now have something new. For the first time, we're working with reviewers. So what we have here is the first name of a reviewer, the last name, and then their rating. So for every single rating that's been given, we want to have the rating, or for every review that's been given, we want the rating and then the first and last name of the reviewer who gave that rating. So it's pretty similar to what we did up here with movies and ratings or series and ratings, except now we're working with the other table. So if we have these three tables, right, we've worked with, let's go back here. We've worked with series and reviews together. Now we're working with reviewers and reviews. So the outer two. So let's get started on this one. We will pop over here and just write challenge 3. Obviously the most important part of this entire video. So we know we want to work with, let's start with reviewers. That's the first thing we want to work with. Let's take a look at those 7 reviewers. Okay, so for every review that these reviewers have written, we want to see the corresponding rating. And another side note, I deliberately put in a reviewer who hasn't written any reviews. We'll get to him or her in a little bit, but we don't care about that one in this case. So for this problem, we don't need to worry about that. Okay, so we've got select star from reviewers, and then let's just do a select star from reviews. And all we want to do is take these reviewer IDs, let's take 3 for Kimbra, and find all the matches where reviewer ID is 3. So here's one, here's one, here's one. As you can see, Cloud9 is actually highlighting them for me, which is really nice. So we want to join on this right here. So we want to join between reviewers and reviews where reviewer.id is equal to reviews.reviewer.id. It's a lot of review. Saying that over and over is a bit of a tongue twister. So select star from reviewers, and we'll do a join reviews on, and we want to do reviewer.id equals reviews.reviewer.id. It's a mouthful, but hopefully it makes some sense. You're starting to identify the patterns behind these joins. We've been doing these a couple of times now between the last section and this section. So we're joining the two tables where reviewer ID is the same as, or reviewer.id is the same as reviews.reviewer ID. And what do you know? Did the same thing without the S that I just warned you about. Okay, so now once we fix that, we have a giant list for every review that's been made. Over here, we have the corresponding first, last name, and ID of the reviewer. Now, this is more information than we needed to get because all we asked for was first name, last name, and rating. So let's now whittle that down. So rather than star, we'll select first name, last name, and rating, just like that. And now we get the right result. So I have a quick question, which is, what type of join is this? When we leave off the inner, it's still implied. So it's an inner join, the intersection of those two circles, the two tables. And so because it's an inner join, the order doesn't actually matter. So just to prove that to you, first, here's what we had before, what you expect. Now let's do the same thing, but let's select from reviews and inner join reviewers. Okay, so if we leave this at star, which is what we had before, you can see that the order that our data is actually kind of printed in the basic sense when we use star is different, right? We have on the left the reviews and then the reviewers on the right. But when we're hand picking things that we want, like first name, last name, and rating, it doesn't matter because we're dictating the order. I'm saying I want first name, then last name, then rating. So as long as the data is in the right place, which both of these do, they're combining them, whether we're doing reviews, inner join reviewers, or reviewers, inner join reviews, the same data is there. And then all we're doing is cherry picking what we want. So both of these work just fine. Okay, moving on to our next challenge with the same data, something a little new and frankly refreshing to see such a short table. So what we're doing here is identifying the unreviewed series in our database. So there are a couple that nobody has written reviews for whatever reason. I haven't seen either of these shows really. I've seen Malcolm in the Middle maybe once or twice as a kid, but I don't feel like I can review it, and apparently nobody else in our app felt that way. So we have 2 unreviewed shows. And the point is not to cheat and to just, use this information to find it, but to actually find it based off of the data we have in our database dynamically. So how do we write? It's going to be a join. What type of join do we need to write where we can see what series have not been reviewed? Okay, well, let's give it a shot. We'll hop over to Cloud9, and we'll start with our handy dandy comments. We are on challenge 5, and this one is unreviewed series. Okay, so what tables are we going to need to join here? So we've got, if we go all the way back here, we've got reviewers, we've got series, and reviews. And we don't need to care about reviewers. We don't care about names of who is reviewing things. What we care about is the overlap or lack of overlap between series, TV shows, and reviews. So let's start with a simple join. Select, and we'll do star from series. And we can just start with that, nice and simple. It doesn't tell us anything. We have no idea which ones have been reviewed or not. So we need to join it with the reviews. So that's going to be join reviews on, and this is going to be our typical join. So series dot ID equals reviews dot series ID. And let's make this explicitly inner, just so we're clear there. And when we do this, we get a lot, right? We see Archer with an ID of 1 has been reviewed with 8.0, 7.5, 8.5, 7.7. But there's a problem here, which is it's not doing what we want. We're not really close to what we want. In fact, we're ignoring the data we want because this is an inner join. So this is only finding the exact intersection between reviews and series. So wherever they overlap is what we're seeing. But we also want to identify where they don't overlap because that tells us that there's not a review for a series. So what we want to use is a left join. So hopefully that makes sense why. Because on the left, if we have our series, right, we have all the series, some of which have matches, some of which don't, and we do a left join, it's going to take everything from the left, including the ones that have no reviews, and it's still going to stick them in the join table, but it's just going to fill their values with null. So we'll be able to identify that. So if we change it to left join, and we scroll through some of this, you'll see somewhere, so we've got Archer with all these reviews over here. If we keep going down, here we go. Malcolm in the middle has null, 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 because there are no reviews to match it with. But because we did a left join, we still get Malcolm in the middle and pushing datas, which is also, pushing daisies, which is null, 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 null as well. So we can use that to our advantage because wherever we see null means that there are no reviews. So what we want to do first, let's whittle it down a little bit. What we're looking for at the end is just title, but let's start by just doing title and rating. Let's do that. So it's a little easier to see. Okay. So now what we want to do is only work with the data where there is no rating. So that's actually quite simple. All we need to do is use a where, and then we can pick rating, for example, equals, and we can't say equals null because that's problematic. Remember, what we need to do is do is null, just like that. So let's try this now, and you'll see we only end up with these two, title and rating. And we don't have to do rating, by the way, because there are other fields that are null. If we go back to star, there are quite a few things that are null. We could have done ID, although this is reviews.id. We could have done rating, series ID, or review ID, or reviewer ID, but it doesn't matter which one we pick in this case. So let's go back, and all we actually want to do is select the title. That's all we need here. Paste that in. Okay. Only thing that's missing is the alias. So we'll do select title as unreviewed series. Copy that in, and it works. Okay, so the key thing here was that we used a left join. We wanted to highlight those discrepancies. This is a use case for a left join where you want to see where there is an overlap. So hopefully that helps illustrate a bit more the difference between inner and left joins. Because if we had only done an inner join here, we wouldn't get the result we want. We wouldn't have any nulls. So this wouldn't select anything at all. Okay, so next up we have another nice clean table, just 3 results. And as you can see, what we're doing here is grabbing things based off of genre. So we only have 3, fortunately: animation, comedy, and drama. And then what we're doing is computing the average review or the average rating for each of those genres. So this will be a little similar to what we've already done earlier in this problem set. The main difference is that we're working with genre now, rather than just the title of a given series. Okay, one thing I need to correct the record here. I called this challenge 5. I was wrong. After 3 comes 4. Now we're on challenge 5. Okay, and we'll just call this genre average ratings. Okay, so to get this information from our 3 tables, the 2 that we need to identify that we're working with are the series table, because that's where our genre information is stored, and then the reviews table, that's where our ratings information is stored. So we don't care about the reviewers, the people who reviewed them. That doesn't matter. All we need is the genres and then the ratings. So we can start with either one. Let's start with star from series, just like that. Okay. So all we're going to want to work with is the genre portion, but we're going to need to join with the reviews table. So we'll just do that now. Select star from series, join reviews. Hopefully this seems familiar now. On series dot id equals reviews dot series id. And if we leave the star in there, we're going to get a lot of stuff. So we don't need all of that. Let's just pick out a few things like title, genre, and rating. Okay, so now we can see we've got, all the ratings for Archer, all animation, of course, because they're the same exact row here with a relevant rating appended. So we've joined them together. It's an inner join, and that's what we want. We don't want to be working with, non-existent ratings. We don't want to take, let's say, Pushing Daisies, which didn't have any reviews. Well, that's a comedy, I believe. Maybe it's a drama, I don't remember. But whatever it is, we don't want to try and average null into the average rating for dramas or the average rating for comedy. So we don't want to do a left join. We want inner. Okay, so we've got this on series ID, blah, 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 blah. Now all we need to do is group things by genre. That's what we're trying to do here. Rather than by title, group by genre. And if we do that, we should see this is immediately reduced down to 3 rows, although remember that it's just kind of hiding all the data that lies beneath. So we have animation here, but it doesn't mean that there's only one. It's just that group by, when you use a group by, it's displayed in a very weird, awkward way that I think is kind of confusing. But what we want to do is we can get rid of the title too, rather than just genre and rating, we just want average rating. And that should do it for us. And we get the average ratings. And there's an alias, so you can add that in like that. And that's it. So now we get animation is the lowest rated, still quite high. Comedy is the highest rated, 8.1, and drama is right in the middle, 8.0. And I suppose this is as good a time as any to introduce the round function. We haven't used it yet, but we're getting a lot of decimals here, and we don't care about them. Let's just round it to, let's do 2 decimal places. So it looks like this, round, and I'll do it on separate lines here. So we have round average rating, but we don't just say round average rating, we have to supply what we want to round it to, 2 digits for us. And then we'll use adds average rating. So I could have done it all in one line, a gigantic, gross line in my opinion. So it's a little better to break it up like this. Takes up more space, but it's the price we pay. Okay, so round the average 2 digits and call it average rating. Now let's double check that works. And there we go. Much easier. You didn't have to do that, of course, but I figured it was a good thing to show. Okay, so next up, we have a return to these long, annoying tables with quite a few fields on this one. This is sort of like analytics for our reviewers. And what we're doing here is compiling statistics on them. So Thomas Stoneman, how many reviews has he written? 5. Okay. What's the minimum he's assigned? 7.0. The maximum review is a 9.5. His average is 8.02. And then a status, which is saying that he is active. And that's determined based off if the user has any reviews. So Marlon Crawford has 0. So he is inactive, but everyone else is active. So we've got a lot of pieces here. And probably the most crucial thing to point out is that we have Marlon Crawford, who has 0 reviews, which we need to pay attention to. We have to pay special attention to that because there's not going to be a natural join if we do an inner join. So we'll need to do a left join which will highlight the fact that he has no reviews. And then the rest is not too difficult. Count, min, max, average, should be pretty comfortable with that. Status, we need to do some logic there. So let's start by adding in challenge 6. We'll just call this reviewer stats. Okay, so the tables we're working with, we've got the reviewer table, which is where we're pulling things like the name. And then we've got the reviews table, which is where we're pulling count, min, it's where we're pulling the actual ratings themselves. And then we're basically getting this data from there. So we don't need to worry about the series table. We're not working with that. We will be in the next, the final challenge here. We're going to put all 3 together, but in this case, we're not. So we'll start with a select star. Or let's just do, we'll do star to start. Select star from reviewers. We get all of our reviewers here. Perfect. We want all of them. So that will be the left part of our join. If we remember the 2 circles, A and B, this will be circle A right here. We want all of this to show up, even though Marlon doesn't have any reviews. Then we're going to do a join. Join reviews on reviewers.id. So where the reviewer ID, like this, 1, 2, 3, 4, 5, 6, is equal to the reviews.reviewer ID. And then in the case of Marlon, there is no reviewer ID equal to 7 in the reviews table. So we'll get null, 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 and so on. Okay, let's try it. And if we take a look at the results here, we don't get those nulls, and that's because we didn't specify that it's a left join. We left that off. And now, at the end, we have Marlon, Crawford, null, 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 which we'll need to make use of to do things like this, where we have 0, min, max, average are all 0, and then inactive. So we'll have to kind of make special exceptions for Marlon, or for anybody with null. Okay, so now let's start whittling down what we need. We want first name. We want last name. So what we have here, right? Then we want things like count, min, max, and average, which require us to group by. But let's start by just putting rating here without grouping and just verify what we need exactly. Okay, so here's all the reviews. And we want to group them together. And we could group based off of first name and last name, but that's not guaranteed to be unique, of course. So it's better to group based off of the reviewer's ID. So we can do that now. Group by reviewers.id, just like that. And if we do that, whoops, didn't mean to expand that. Again, our group by is working its weird magic. It's working behind the scenes. So now we can do things like average, for instance. Let's start there. Well, actually, even easier is counts. And we'll just count the ratings. So behind the scenes, it's grouped them. Remember, it went from this here. So if we take a look at like these, they were all grouped together. So under Thomas Stoneman, there's 1, 2, 3, 4, 5. But we only see Thomas Stoneman. We don't get 5 results, but they're there behind the scenes. So we'll do count rating. And you can see it looks good. We get 5, 9. You can see Domingo and Colt have written a ton of reviews, and poor Marlon just hasn't written any. So that's a start. Then we've got min and max. So those are quite simple too. Let's start with min, the min rating that they've written. And that works for everybody except for good old Marlon, causing us problems. And we should be relatively comfortable with fixing this at this point. Notice that I just sent it to be 0. You could have set it to be anything. You could leave it as null, but let's make it 0 to match the chart. So we can use our if null min rating. Then we'll set it to be 0. And if I leave it like this, our table is going to be kind of ugly because we have this if null up here. We don't need all this space. So let's call this one as count and this one as min. That should cut down on the space. Looking better. And then the same thing for max, which we can just copy and just change min to max. Okay. So we got min and max. Let's just triple check. There we go. Count, min, max. Then we've got average, which by now you should be comfortable with doing as well. It's the same thing as average, but we'll run into that same problem with null. We don't want null there. We just want 0. So if null, once again, just like that. We'll copy it. Okay. And we've got the first, almost everything, except now we need to work with status. And status is a little different because there's some logic here. And what's it based off of? Well, it's based off of count. So if count is more than 1, or greater than or equal to 1, then we'll call that user active, or the reviewer active. Otherwise, it's inactive. Or we could switch it around. We could say if count is equal to exactly 0, then status is inactive. Otherwise, they're active. And to do it, we could use a case statement. We can start with that. What we're working with, again, is count. So let's do this at the bottom, our case. And I like to do end as, and we'll call this status. Okay. And our first thing we'll check for in case is when count rating, and we can do when it's greater than or equal to 1. Then we'll say active. Status will be active. Else, and we need then here. Otherwise, inactive. Active, inactive. Okay, let's try that. Okay, it works just fine. But I did say there's another thing that we can do, which I also haven't shown you until now. I didn't want to overload you with a bunch of different ways of doing logic, but for simpler case statements, we can use another function, or another logical function, which is called if. So I'm just going to replace this with if. I'll show you what it looks like. We just say if, and then the condition that we're looking for. So if count rating is greater than or equal to 1, then the second argument is what we want to spit out. And then the third one is the else condition, or the else argument. So these are equivalent right here, as long as I put status. So let me make that a little bit easier to see. This right here is saying, okay, if count rating, so if the count of all the ratings per each user or each reviewer is greater than or equal to 1, then status is active. If that's not true, status is inactive. So this works great when we only have these two things that we're working with, right? Active and inactive. But if we wanted to add another thing in, it's a little more complex. Like if we wanted to say, okay, if it's greater than 1, then they're active. And if it's greater than 10 or greater than or equal to 10, they're a power user or something. Otherwise, they're inactive. It's much easier to use a case statement for that. So I can show you that, but I'm going to get rid of this first and just make sure that our new addition works the same way. Looks good to me. We could go through and round. Average is kind of gross. But if we do that, that's going to get quite gross too. And we'll want to break that onto separate lines. We'd want to format that to make it a lot more legible. But otherwise, it looks good. So the last thing I'll do is optional. It's just to show you if we wanted to add in a third status from active, inactive, and crazy active or something like that, we can replace this if. Go back to our case. So we'll do case end as status, and we'll just do case when count rating is greater than or equal to 1. And actually, let's start with if it's greater than or equal to 10. In that case, we'll say power user. And then the next thing is when count is greater than or equal to 0, we'll just say active, else, and I need my thens, I always forget those, else inactive. So the way I formatted that is basically to say So the way that I formatted that is to say first, okay, is it greater than or equal to 10? Then it's a power user and we're done. But if it's not, that means that it's less than 10. So if it's less than 10, but still greater than or equal to 0, then they're active, and that should actually be greater than 0, not equal. And then if it's not greater than 0 and not greater than or equal to 10, that means they're inactive. So now copy that, paste it over, and you can see we have two power users, Domingo and Colt, who have count of 10. And now we're done. So we made it through that quite a bit there. I will leave this example, but I will also duplicate it and go back to having that simple if statement so we don't have to have the case. Okay, so I'll do that. You don't have to watch that, but it's in the solution text or the solution file if you want to take a look. Okay, we're at the final video here, the final challenge, and this is the one that puts everything together. Or really, more what it's doing is putting together all three tables that we have. So what we're actually getting out of it is not that impressive, right? We're not doing any crazy analytics or anything like the previous one. Not that that was too crazy, but nothing like that. All that we're doing is putting the title of a movie or of a series, and then every rating that it got along with the reviewer who wrote that rating. So we've done the first part up until here, right? Where we've done title and rating together, or where we've done reviewer and rating together. But now we're going to put them all together so that this is the information for one review, right? It's the movie that was, or the series that was reviewed. It was the person who reviewed it. Notice that we can cat them into one reviewer instead of first name and last name, but that's secondary at the end. So we have the series title, the reviewer's name, and then the rating they gave it. So we're basically just trying to take, let's do it here, take this and fill in the blanks. So instead of series ID, we're going to get the name of the series. Instead of the reviewer ID, we're going to get the name of the reviewer. Okay, so let's go ahead and start over here with our handy dandy comment. And we are on, what is this, 7? 6? Yes, 7. 3 tables. Okay, so we can start off with any of the tables. We're going to join them all together, but I'll start with reviewers. So we'll select star from reviewers, just like that, except I need from. Boring, we've done this before, blah, 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 blah. So the first step is to join it with the reviews table. So we'll have reviewers along with their reviews, along with the series associated with that review. And we're not going to worry about, people who haven't written reviews. That's fine. We're ignoring that. Okay. So to do this, let's start off, first of all, by joining it with join reviews on reviewers.id equals reviews dot, and then we need reviewer ID. So fun to write. And we do that, and we see things like, okay, Thomas Stoneman gave an 8.0 to some movie or some series with ID of 1. He also gave an 8.1 to whatever has ID 2, and so on. So we're getting close-ish. Now what we need to do is also throw on the series data over here. And the first thing I'll do is just make this explicit. It's an inner join. So we're going to do another join. And it's really easy. At least syntactically, it's easy. We just write inner join again. So what are we joining on this time? Well, we're now going to join on the only thing that's left, which is series. So we took reviewers and reviews, sandwiched them together where they intersect. Now what we're going to do is join a series where the series ID is equal to series ID here inside of the reviews. So let's do inner join series on series.id equals reviews.series underscore ID. Such a nightmare trying to speak all this out loud. But let's step through this. Okay, so we have sort of this middle table, let's say, which is right here. We have ID, rating, and series ID and reviewer ID for our review. That every review has that. And what we started off was joining it with the relevant reviewers. Now we're going to also take the series ID and find all matching series and stick them over here. And it's going to be a messy table. It's going to get all collapsed and screwed up. So let's filter out some things. So let's only work with the title, the rating, first name, and last name. Okay, so we're getting close now. So we're pretty much there. We have all of the data together. So we have Archer has an 8.0 rating from Thomas Stoneman. Thomas Stoneman also gave Arrested Development an 8.1. And he gave Bob's Burgers a 7.0. And then we can see, okay, we have Archer again down here from Wyatt Skaggs, who gave it a 7.5. So we have all of our data synthesized in one table. Now what we need to do is concatenate things together over here. So that's just simple. All we need to do is, instead of doing first name and last name, we'll do a concat first name, comma, space last name as reviewer, I think is what we called it. Yep. Okay, and then there's only one thing that we need to change other than that, which is right now, things are ordered by reviewer. Let's order them by title, which is what we did over here. So that's just a simple order by title. Now we should be done if I get rid of that extra semicolon. And here we go. So we have Archer, all of the ratings for Archer and the people who wrote them. Arrested Development, all the ratings and people who wrote them. And all the way down through all of our series that have reviews. So that's important. So only where we have reviews. So to summarize, let's go all the way back here. What we just did was basically take the reviewers table, smash it with the reviews table where they match. It's an inner join where's the overlap, right? So we take the overlap between them based off of ID here and reviewer ID. Then we have that second table that we then joined with series, where the series ID matched the ID of a series. So it's a three-way, 2 join statements, but 3 tables together. And that's why I decided to do many-to-many relationships after the simpler one-to-many. But hopefully it's not too intimidating. We did a bunch of exercises with them. You're probably a bit burnt out. I know I am from recording all of them. So I definitely recommend that you take a break before we move on. We're going to continue, of course, with joins and relationships, but we're only building from here on out. So congrats on making it through this part. Hey, welcome. I'd like to show a couple things. Here's a nice trick Blue can do. Look at that. She's like a T-Rex or something. Great job. That's the first thing. But the second important news that I have here is that this section is the one where we finally do our Instagram data, where we're finally cloning Instagram. And that's actually an exaggeration. We're only cloning the database. And even then, we're only doing like 7 or 8 tables, not 20 or 50 Instagram tables. But still, we're doing the basics, the important stuff, photos and comments and users and likes and following relationships, hashtags, all that fun stuff, all the relationships between them, and then all those joins. There's a lot of opportunities there. So this is sort of acting as a bit of a end cap on this course. It's not the end, but this is the last kind of data set that we're working with. And then I'm going to show you after this how to build a web app with MySQL. So that's also coming up, which hopefully is exciting. But this section, like I said, is all about Instagram data, really exciting stuff. Gonna basically build the schema. And then the next section is going to be a bunch of challenges and problems with it. Okay, let's get started. Hello, welcome back. So this section is going to be a bit of a capstone. Maybe that's an exaggeration. It's going to be a summary of what we've been focusing on in the last couple of sections. So there's sort of this subsection of the course, the last 3 or 4 sections that we're all focused on working with multiple tables, relationships between data, tables where we have foreign keys referencing other tables, talking about relationships or associations like a one-to-many relationship or a many-to-many relationship, and so on. And then also joins, which is what we were focusing on as of late. So this is going to kind of wrap that all together into something bigger, because so far we've really been working with 2, maybe 3 tables, modeling a single relationship like customers and orders. But now we're going to take something on a little bit bigger. We're going to focus on a bit of a case study. We're going to work with a site that you're probably familiar with, Instagram, and we're going to try and clone the database for some of the basic functionality. So we're not going to be diving into like advertising and keeping track of our users' data and all of that. We're really focusing on the main big entities to a site like Instagram, things like photos and comments and users and so on. So again, we're not really scratching the surface as to how Instagram actually stores everything. We'll talk about what things work best for scaling. We'll run into some fun issues when we talk about how hashtags work and how you should store hashtags. So we will talk a little bit about performance, but this is really more about how do you design a schema for something that has, in our example, at least 7 or 8 tables. In Instagram, the real app, there's probably dozens of tables. But either way, it's a big step up from 2 tables or 3 tables max. And then the other thing I wanted to mention is that in this section, we're going to focus on designing the schema. It's going to be a bit of an exercise, but I'm also going to go through and do it myself. But then in the next section, I'm actually going to give you a bunch of data, like a ton of data. I spent a long time making this here. So this is what we'll be working with. You'll actually be inserting this so that for once we'll be able to work with big amounts of data, thousands of rows, and you'll see the impact that it has. And also, hopefully, it will feel a bit more realistic rather than 2 or 3 things at a time. So that's where we're going. But in this section, we got to create the schema first. We got to understand what we need. So let's start by taking a look at a typical Instagram page. And yeah, some of you may know this. I'm in my spare time, I like to do photography, especially landscape photography, stuff around San Francisco. So I am using my own Instagram here, but that's not really why. I'm not trying to get more exposure or anything. It's just that I don't want to run into any issues with, permission or having rights to use somebody's images in my course. Okay, so with that said, the reason this is here, like I said, is not just to show you my photo, but mainly it's to help us understand and identify the key entities. So on this basic Instagram, this is from the web app, though most people use the iOS or Android app, it's the same entities, the same data. And the first thing, probably the most obvious, is users. So we're going to need some sort of users table or a way to store users. And then moving on, we've got a really obvious one, which are the photos. We need a way of storing images or photos. Now, we're not going to worry about how we actually upload photos and how, what data type we use to store them or anything like that. We'll just say that it's an image URL. So when we actually get to the exercise portion, I'll come back to that. So we need to store stuff about photos. And then we've got things like likes. So we need to store likes for a given photo, but also remember there are some complications because, I can't just click on this heart button, 10 times and add 10 likes. I can only like it once. So we need to have something there as well. Maybe there's something we can do with our database. Hint. And then we've got hashtags. And hashtags are a fun one. We're going to save that for last in this section because there's a lot of ways of doing them. We'll talk about at least 3. And there's a couple of advantages and disadvantages to each. So hashtags, though, are an important part of Instagram and of a lot of tagging in general is a lot of web apps, whether it's blogging or Twitter or something like Instagram. And then we also have other components that I couldn't fit onto one page, like comments here. That's really the big thing that we also need to be able to store comment information. And then there's one other big thing, which is followers and following. So the relationships between users, how do we store that? There's a couple ways of doing that as well. But on Instagram, the way that it works and the way that our database should work is that it's a one-way relationship. It's not like Facebook where, I send a request to someone and we only become friends if they accept or vice versa. But both of us have to be kind of consenting friends. On Instagram, I can follow somebody and they don't have to follow me back. Or people can follow me and I don't have to follow them back. So how do we store that in a database? Okay, so that's really what we're focusing on. There are obviously other things, like we're not going to store profile information. We're not going to store stuff about advertising, like I said. And that's just scratching the surface of what we're not storing. There's a bunch more. But we are going to store information, and I'm not saying these are the tables we need. We may need more tables. We may be able to get away with fewer tables. But these are the entities, the information we need to store. So users, photos, comments on photos, likes for photos as well, hashtags, which will apply to photos. We're not going to worry about hashtags inside of comments, which you can do on the real Instagram. We're not going to do that. We can talk about how, but it just makes it a lot messier. And then also followers/followees. It's kind of difficult to talk about the different roles there, but just relationships or friendships or whatever you want to call it. I just call it followers and followees or followings. So these are the main things we need to store. And the way that I'd like to structure this is I would like you to try and give this a shot. So you don't have to actually, insert data and do a bunch of exercises on your own, but I'd like for you to at least brainstorm how you would do this. What are the tables you need? I'm going to, in the ensuing 6 or 7 videos, go through each table we need and talk about my solution. But it would be great if you would take the time to just kind of think about it, jot it down, either draw diagrams out, create a schema file, and just write the create table statements, whatever you feel most comfortable with. If you want to get a whiteboard or post-it notes, whatever works. But think about how you would do this. If you were creating, it doesn't matter if you're a developer, if you know how to code in other languages or not, but if you were creating an application like Instagram with the functionality we described, what would you sit down and start with for your database, and how would you brainstorm it? So that's really what I'd like you to do. And then in the next couple of videos, I'll step through in bite-sized chunks. I want to make sure that these are short videos, which I know I have said before and maybe have not held up my end of the bargain all the time, but these will be shorter and they'll go through my thought process and how I created it. Oh, and before I forget, if you're going to attempt this, when you're creating the tables that you need to store this type of information, just focus on the core essentials. So for something like users, you don't have to be, have a username and an email and a password and I don't know what else Instagram asks for, like a birthday maybe and a profile and all of that. You don't need that, just the basics, maybe like username and whatever else you need to have it work or have it relate or associate with all the other entities. It's easy to add the individual things to a table. Like for users, adding an email column is not hard. But then figuring out how you have users connected to likes, for instance, that's what I'd like you to focus on. Okay, so again, you don't need all the information you can possibly think of, just the key parts. All right, so this is the first video of basically talking about the tables we need and implementing the tables we need for our Instagram clone. And the first thing we'll start with is users. Users is a pretty obvious place to start. I guess another one might be photos, but users is at the core of everything if you think about it, because users are connected to, photos, they're connected to comments, they're connected to likes. They're not connected to hashtags, but pretty much everything else relates to users. So what I'm going to do here is something super simple. Like I said in the last video, there's a lot more we could store here. Email, password, like 20 different things, location, city, IP address, all that stuff. We're just going to focus on the basics. So an ID, a username, and a created at. And created at will just be, the day the user or the timestamp when the user signs up. It will have a default value of now or current timestamp. Username is just going to be a varchar, and ID will be a primary key. And we'll be referencing this ID in other places. For example, when we talk about photos will have a foreign key referencing the user ID. So we'll go ahead, and the first thing I have is just an empty directory I made just to store this, and I'm just going to make a new file, and I'll just call it Instagram_clone.sql. I'll open that up, and this is where I'll work. So this is where I'll do a create table, users, and like we said, we're going to have an ID, we'll have a username, and a created at. So ID is going to be integer or just int. I'll do integer. just because I've been doing int, but it's an alias for integer. It's good to see both. And we'll have it auto increment. And it's a primary key. Great. Comma. Come back to username in just a second. Created at, I'll do timestamp with a default of now. And you could also do current timestamp. And remember, you could do date time as well. Timestamp is just smaller. It's easier to store. Okay, so then we've got username. And we know it's just going to be a varchar 255. There's another constraint that we could add though, which is we want username to be unique. We don't want anyone to be able to sign up with the same username essentially. So we can add unique. And you might be wondering, well, then why would we have, ID be the primary key? Why not make username primary key? You absolutely could do that. But if you're going to have a foreign key somewhere referencing username, and you're working with a long string, if someone's username is, something massive like that, because we could do 255 characters, that's going to be slower and more annoying to search. Not potentially, definitely slower if you have thousands and thousands of entries compared to a smaller integer. So it's good to have a primary key be an integer, but we can still have this unique constraint. And we can also add not null. We don't want anyone to be able to sign up without a username. Okay, I'm going to go ahead and make a new database to put this in, but I'm going to do it in this file. So I'll do a create database, and I'll also just call it Instagram or IG clone. And then I'll use IG clone just like that. So now every time I run this file, it's going to make this database, use Instagram clone, the new database, and create the table. And the reason I'm doing that is just one, to show you that you can. We haven't really seen using these commands in a file. But also, as we go, we may want to rerun this and recreate the users table or another table if we realize we messed something up or we need to change something. We're not going to have any data in there yet, so it's super easy just to create the database again, drop it, then create it, and then use it, and then create the table of users. Okay, so with that said, let's try this. I'm going to do source, and I need to reference this directory / instagramclone.sql. Okay, and just to double check, describe users. That looks good. Okay, so if you are good with that, go ahead and move on. Next up, we're going to talk about photos, but I will spend a minute or two just adding 1 or 2 users so that we can work with them in this section. Remember, in the next section, we're going to have a massive data set that I'm going to give you. But if we want, we can just play around with some data. So I'll do an insert into users, and we'll just insert username. And let's just do 2 or 3. So we'll have Blue, the cat, and we could also have, Charlie Brown. And then I'll just put myself in there, just like that. Okay. So what we could do now, if I resource this whole thing, I'll get an error because it tells me I can't create this database Instagram clone, it already exists. So I could either drop the database first, and I'm going to do that for now. You typically don't want to do that. You don't want to drop a database ever if you can avoid it. But if there's no data in there yet, or if the only data that will be in there is in the same file, like we're doing here, just testing it out, this makes it easy because I can just run this one command. It will erase the database, recreate it, and get all the new tables that I need in there, as well as the new data. So now I can do a select star from users, and there we go. We've got created at in there automatically, ID is automatic, and our 3 usernames. Okay, next up, photos. All right, moving right along here. We're working with photos this time. And the easiest way to store photos is just a single table, photos, but of course they need to be related to a particular user who created the photos. So we'll have an ID, and all we'll store about an image itself is the image URL, which will just be a string. We could have added a caption as a varchar, not a string. We could have added a caption. We could have added location data. On Instagram, you can say where it was taken. There's all sorts of things that we could do, but we're just focusing on image URL in our case. And then a user ID, very important, foreign key, pointing to users.id. And then we also have created at, just like we had with users, just a nice way to be able to, sort photos by most recent to least recent, or figure out the first photo somebody posted, or if one photo is posted before another, if one looks like this has actually happened to me, or people take a photo of mine and repost it claiming that it's their own. It doesn't happen often, but 2 times actually by the same person. And the person actually flipped the image, mirrored it, posted it, claimed that it was their own. But of course, I could just show that mine was posted first, thankfully, because there's a date. I mean, it didn't really matter anyways, right? It's just photos on a social network, but still, having that created at in there helped me there. So let's implement it now. It's pretty straightforward. We'll just create table photos. We're going to have an ID. We'll also have our photo or image URL, whatever we want to call that. We'll have user ID and then created at. So ID is an integer or int auto increment primary key. We'll be referencing photos.id from other tables, because things like comments are associated with a particular photo, or likes are, and tags as well. So we need that primary key there. Image URL will just be a varchar 255, but we should add not null. We don't want that to be empty or to be null. That's a big problem because there'd be no photo to display. And then user ID, that will be an integer. And let's also make that not null. A photo needs to be associated with the user. We can't have an orphan photo that has no user. And then created at will just be another timestamp with the default value of now, the time it's created. But we still need one more piece, which is our foreign key constraint, which is going to pertain to user underscore ID, which is referencing or references the user's table, the ID field. Did I spell that right? Reference, there we go. Okay. And that will create our photos table. So if I just resource this whole thing, now if I do show tables, we have both tables in there. If I do a describe photos, we've got photos there, everything looks good. And just like before, if you want to stick around, I'm going to insert 1 or 2 photos in here associated with our 3 users, but I'm done with creating the schema, so you feel free to move on to the next one, which is comments. But if you want, you can stick around as I do an insert into photos, and we'll just do an image URL and a user ID. Those are the 2 things we have to supply ourselves. Values, and our first one, let's say Blue submits it, and we'll come back to the URL, but Blue's ID is going to be 1, and if we weren't sure, we could do select star from users. You can see Blue is 1, Charlie Brown is 2, and Colt is 3. So we'll just do something silly. Let's just say the URL is just random like that. I'll duplicate that a couple times. In Cloud9, it's Command-Shift-D or Control-Shift-D on a PC. And then let's, here's another random thing. This time it's submitted by Charlie Brown. Let's say Charlie Brown has another one as well, like that. Okay, and I haven't submitted any photos. That should work. If we run our source again, this time, so it dropped the database, recreated it, switched to it with the use command, created our 2 tables, inserted all of this data. Now if we can do select star from photos, and we should have 3 simple photos there with a user ID. We're now at the point where we could do a simple join if we wanted to figure out who posted these photos. So again, definitely if you feel good about this, move on. And don't waste time watching this, but if you want the practice, we could just do a select. Let's say I wanted to have the image URL created at and the name, the username of the person instead of the user ID. So we'll just do a select star to start from photos, join, and we'll just do a default inner join, users on, and we're going to do it where photos.userid equals users.id. So if we start with that, there's a lot there, so let's thin it out to just be photos.image URL, comma, users.username. Is that what it is, username? Yes, just like that. Copy it. Okay, and now we can see Blue the cat created that and Charlie Brown created those two. All right, and what I'm going to do just to set a pattern for the next few videos is move these joins and things that I'm just playing around with down to the bottom and comment them out. We don't want those to run, but I'll leave the insert statements here as well as to create tables. All right, moving on. All right, so we're moving on now to comments. And we did users first and photos for a reason. One is that they're simpler and essential to Instagram, but also comments is going to rely on them. Because if you think about how comments work, if we go way back here, these comments over here, this handy green box to draw your attention, are written by somebody, right? So it's not just a comment like awesome or banger, but there's also somebody who wrote the comment. So there's some association there. So a comment needs to be related to a user. But then these comments are related to a particular photo. These comments here are for this photo, not this one, right? So they're not just floating in thin air, but they're also related to a photo, which means we're actually going to have two foreign keys. So it looks like this. We have a comments table. Comments will have an ID, primary key. Our comment text, which is just, the text of the comment. I didn't want to call it text because that's a reserved word in MySQL. Even though it might work for you, it's just not a good idea to mess with that. In reserved word, meaning that text is a particular data type. It's something that's used in MySQL in the language. So naming a column in a table is not a great idea. It's like naming a column, integer. Okay, then we've got user ID, which is a foreign key related to the users.id. So that's how we know who wrote it. Then we've got photo ID, which is also a foreign key, this time to photos.id, which is how we know which photo the comment is on. And then we've got our good old friend created at. So let's hop over to Cloud9. I'll do it down here after photos. So we'll do a create table comments. And our main things, we've got ID, we've got comment text, then we've got user ID, photo ID, and created at. So we'll start with ID. We'll do integer, auto increment, primary key, pretty standard. Comment text will just be varchar 255, as well as we want to make sure it's not null. We don't want anyone leaving empty comments. If you try that on Instagram, it just won't post it. Then we've got user ID, which is just an integer, but we also want that to be not null. We don't want to have a comment that's an orphan that's not related to a user. Same thing for photo ID. It's going to be an integer. And we also don't want it to be not null, or we don't want it to be null. We want to make sure it's not null, because then we'd have another type of an orphan, a comment without a parent photo. So we have these two relationships here. User and photo are related to comments. Okay? And we don't want either one to be null. And then created at, good old timestamp default now. But we're missing our foreign key constraints. So foreign key, and we'll start with user underscore ID, references, users, ID, comma. Then we've got another foreign key. This time we're working with photo ID, which references, photos ID. There we go. Okay, so just to make sure I don't have any typos here, add my semicolon, and I'm just gonna resource that. If I can find it, here we go. Looks good so far. If I do show tables, I've got comments, and I can do describe comments, and we're good. All right, so just like the last few videos, stop here if you feel good with this. If you want to see me insert some data and see how we relate things when we actually insert the data, I'm going to do that. But of course, move on if you feel comfortable. So if you're still here, what I'll do is insert a couple comments between or related to these three users and these three photos. And this is where it gets kind of difficult to keep everything straight, keep all the IDs and everything straight in your head. So we'll do an insert into comments, and we'll have comment text. Then we'll start with the user ID, who's posting it, and then the photo ID. Values. So let's say our first comment is going to be Blue commenting on this photo here, saying this is, or how about her comment is just meow. Okay, so that's the comment text. And the user ID is who's saying it. Blue the cat has an ID of 1. And I just, you can tell because we inserted her first, but of course if we went back to our select way back here, you can see, well, no, you can't see there. You can see here, her ID is 1. Okay. And then the photo ID, we'll just say she's commenting on this one here with photo ID of 2. And I'll duplicate that. So let's say somebody else commented. Let's say someone says, amazing shot on the same photo here. And let's say I commented on that. So that would be my user ID 3. And we'll do one more this time. Let's say Charlie Brown is commenting. I heart this. And Charlie Brown is user ID 2. And let's say he's commenting on the first photo that was submitted by Blue with user ID 1. So you can see how it gets a little bit crazy, but we can do that now. And make sure I have my semicolon instead of a comma there. This time, if we source it, everything looks good. We can do a select star from comments. There we go. We've got 3 comments. We could put a user ID in and a photo ID. I won't do that now. We'll do it as an exercise later with some more complex data. But of course, you can do that if you want a little bit of practice. All right, moving on to likes. So we've seen now users, photos, and comments. And likes are a little bit similar. They are like the comment schema because when we think about how likes work, on Instagram at least, you like something, you like the particular photo, let's say, it's corresponding to that photo. We need to have an association there. But then there's also the association between me, the person liking it, and the like itself. And that might not matter if we allowed for infinite likes. If anybody could like something as many times as they wanted, it was a button that clicked and it just kept going every time I clicked it, we could get away with not storing, user information with a like. But even then, it might be nice to see how many times somebody had liked something or how many likes, in general, how often do I click the like button compared to somebody else? It might help us figure out who's a bot. Like on Instagram, that's a big problem actually, are these bots that people write that go and just like photos, like things all the time, create comments that are just cookie cutter. It's kind of frustrating actually if you're a photographer because, you'll post something and then you get excited that you have, 100 people who liked it. And then it turns out a lot of them are bots. If you actually go try and look at them, they don't have any photos posted really. They always comment the same thing. Long story short, in this giant data set here, I actually coded in some bots that we'll be working with. Basically, people who aren't creating much stuff. They're not posting many photos, but they are liking a lot of things and commenting a lot of the same thing a lot of the time. Anyway, back to likes. It's going to look like this. We'll have a user ID and a photo ID and a created app. So our user ID is going to refer to a user's ID, and a photo ID refers to a photo ID. And there's really nothing else, right? There's no information being stored there, maybe, aside from the date or the time it was created, when the like happened. But what else is there to store? Maybe Instagram is doing stuff like whether it was liked from the web version versus the iOS version. Maybe they're storing, other information here, possibly. But for us, this is the basics. We just need a user ID and a photo ID. And every time, a photo is liked by a different user, we get a new like, just like this with the user ID and photo ID. So we'll start by coding this. You might have noticed that I didn't add an ID to likes. I'll explain why in just a second. But let's start by creating our table. So we have create table likes. And don't forget the semicolon. We've got a user ID and a photo ID and our created at. Let's start with created at. We often neglect it. Timestamp, default, now. Okay, nice and easy. User ID is just an integer. We don't want it to be empty. Same thing for photo ID. But then we need to set up our foreign key constraints. Foreign key, user ID, references, users, ID, comma, another foreign key, this time photo ID, references, photos, ID. Okay, so now let's address why we don't have an ID here. And the main reason is that we don't need an ID. We're not going to be referring to likes anywhere else. If we were, it would be good to add an ID there maybe, but we're not having any table store information about likes. The other thing you might be wondering about is how do we ensure that, there's only one like per user? Is there a way to do that in the database? Because right now, if I did this, I could just insert, let's say my user ID is 1 and a photo ID is 1. I could insert a like with user ID 1, photo ID 1, and then insert it again and again and again. And there's nothing stopping that. So what we really want to say is we want a unique combination of the two. There can only be one instance of every combination. And there's actually a way of saying that. We haven't seen it, but you can do this, primary key, and then we can just say user ID, comma, photo ID. So what this will do is basically not allow you to insert two, likes that are exactly the same user ID and the same photo ID. And I'll demonstrate that. If you feel confident, if you trust me there, you can skip, move on. We're done with the schema here. Let's just make sure that it runs. I don't have any syntax errors, of course. Okay, it does. But if you'd like to see me try it out, like the last couple videos, I'll do that now. So if you're still with me, all I'm going to do is take these photos and these users, and I'm going to have some of them like them. So let's take blue, user ID 1, and that first photo, she created it. That doesn't matter. You can like your own photo on Instagram. So we'll insert into likes. And we have user ID, comma, photo ID. So the first one will be 1, comma, 1. So I'm inserting, or blue is liking this photo. And then let's have Charlie Brown also like it. So that would be a, 2, comma, 1. And then we've got the next photo here, which has a photo ID of 2. Not this, remember this is the user ID who created it, but this has an ID of 2. So let's say blue also likes that one. So blue ID of 1 likes photo ID of 2, and she likes photo ID of 3. And then let's say I have user ID 3. I like photo with ID of 3. Okay, so let's start there. We run it, it works. There shouldn't be any problems at this point. But now if I try and do this, insert into likes, user ID, comma, photo ID, values, and I do 1, comma, 1. Well, that's not that. There we go. 1, comma, 1, which already is in there. Blue, user ID 1, and then this photo, add blah, 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 76 with ID of 1. We already have that like. But if I try it, you can see I get duplicate entry 1-1 for key primary. So the way it does it is basically combines the two, keeps track of the combination like that with the dash between it. So that's pretty much it. I will copy what we just did and add a note here. if you're looking at these notes later, just saying won't work because of primary key constraint. And I'll comment it out as well. We don't want to run that every time. Great. And next up, we're moving on to a fun one, which is relationships, following, followers, all that stuff. Welcome back. So we're moving on to capturing the relationships, the friendships between users. So we're talking about followers or followings or however we want to term this. I just refer to it as follows, but it's not really a great term either. But basically, how do we capture the data when I follow another user and they may or may not follow me back? It doesn't matter. I'm still able to follow them. And that's all we need to capture is this one-way relationship. And the easiest way to do it is with a single table that we'll call follows. And all that it is two user IDs. So both of these are both of them are foreign keys referring to a user ID. A different user ID that's important. We can't have a user follow him or herself. So they're different IDs. And I called them follower ID and followee ID. You could do, user 1 ID and user 2 ID, but the idea here is that you can tell who is following who. That the follower is the person following the followee. It's a nightmare to try and discuss here. So let me give you an example. Here's our table of users. So we have 3 users, Tommy, Blue Cat, and Cold Steel. And they have an ID of 1, 2, and 3 respectively. Okay, so here's our follows table. And the first thing, let's say that Colt, me, decides to follow Blue. So that means, follower ID is 3, follower being me, the follower. Who am I following? 2, Blue, the followee. But she doesn't have to follow me back. And she doesn't follow me back, at least not yet. If you look next, I'm following user ID of 1, which is Tommy. Speaking of Blue. Yes. Okay. Let's see, where was I? So I, with user ID 3, follow Tommy. Okay. And then you can see now, Blue, whose user ID is 2, finally follows me back. She decides I'm a good owner, and she wants to follow me on Instagram. But the key thing here is that it's a one-way relationship. Here we have, I'm following Tommy, but Tommy does not follow me. And this is all we need, the structure to encode that information. A couple points we should make, that these are both foreign keys. Created at, it's just good to know if you want to keep track of, when people are being followed. Again, not essential, but it's something that Instagram definitely is tracking, friendship date or something. And then also, we don't want to have duplicated, follows. So I don't want to be able to follow Blue again. So we need to enforce that these are unique. The combination of these two in an order. So as you can see, 3 and 2 is here, and we can have 2 and 3, but we can't have another 3 and 2. Okay, so let's get to it. We've got follower ID, followee ID, and created at. And we won't be needing a primary key ID or an ID integer that is a primary key because we won't be referencing these friendships or follows anywhere. So create table follows. If you have a better name, feel free to use that. And the first thing we have is our follower ID and our followee ID, and then created at. Okay, oh my gosh. Okay, so let's start with created at, timestamp, default now, perfect. Then we've got follower ID and followee ID are both integers. We don't want them to be null. Just copy that on over, put our commas there. And now we also need to officially declare these as foreign keys. So that would be foreign key follower ID references users ID. And we can just duplicate that line and just change followee ID. It also references users ID. And then the last thing, as I mentioned, is we want to enforce that you can only have one of a given relationship. So if user ID 1 is following user ID 2, that can only be in the database once, but user ID 2 can follow user ID 1. Anyway, so to do that, it's just a matter of primary key. And the order that we actually put them in here won't really matter. I mean, it makes a difference to MySQL, but for us, it won't matter. Follow EID. Okay, and so that creates the table for us. Let's just check that everything works. Looks good. Let's do a describe follows. Good. All right. So just like the last couple videos, we're done. If you want, stick around and I'll play around with some data and show you that this primary key constraint is working. Okay. So if you're still here, let's try doing an insert into follows, and we'll have our follower ID first, and then our followee ID. Gosh, it starts to just sound like gibberish after saying it enough times. So let's say that we start off, we've got these 3 users, right? So blue follows Charlie Brown. So that's going to be 1, 2. And we'll also have blue follow me. So that's 1, 3. And then let's say I also follow blue back. So that is 3, 1. And then let's say that, who do we have? Charlie Brown follows blue. Let's say Charlie Brown follows me. So that's 2, 3. Okay. Let's try inserting them. Looks like it works. You can do, select star from users, from follows. Great. We got follower ID, followee ID, and created at. And then the true test is if I try and reinsert a relationship, like insert into follows. Getting sick of this follower ID, followee stuff, but we're almost done. So let's say I try and insert this friendship, 1, 2. So that is blue following, or let's do 1, 3. It's blue following me. She loves me so much, she wants to follow me again. If we try and do that, it's a duplicate entry. But as we saw, you can see here, we already have 3, 1. So if I did do, if I do 1, 2 this time, which we also already have, that's blue following Charlie Brown, it's a duplicate entry. But if I switch the order and do 2, 1, that's permitted because we don't have that in here yet. But now, of course, it's a duplicate entry. So the order does matter, right? Who's following who? Okay, so hopefully that makes sense. We're moving on now to our final piece, which is tags, hashtags. And finally, we've arrived at our last entity to store, which is hashtags or tags. And we saved this one for last because, as I mentioned in the intro video, it's the hardest, I guess. Well, it doesn't have to be, but there's a couple different solutions we could go about, and I wanted to have a discussion about which is best, if there is one answer. So let's step through 3 potential structures that we could use. And remember, the way that this works is that one photo can have, 10, 20, 50 hashtags. I do think there is a limit on Instagram. I mean, you can keep adding them as many as you want, but only 30, I believe, actually will show up. Or it's not that they won't show up, but it's that when you search for a hashtag, your photo will only show up if you use less than 30. Anyways, we're getting off track here. But the idea is you can add hashtags to a photo, but then you can also, go click on a hashtag and see all the associated photos with it. So here's one way we could structure it, which might seem maybe the least obvious to you, which would be to do it like this, where we actually just have our photos table, but we add a column called tags, and it's a string, just a varchar that just has our tags, and we could separate them by the hash sign, the octothorpe, or by spaces or dashes or something, but we're just storing them together. And this could work, and places do use this. I've seen it suggested, at least. I haven't seen it in practice, but you can imagine how it would work. To add a new tag into something, you'd basically just take all the other tags and then concatenate in at the end a new tag, or at the beginning. And then you could have an order to, figure out which ones were posted first, I guess, based off of that order that they're in. And it's pretty simple. If you wanted to find all photos that are tagged with cute, you just basically have to use like, where tags like cute. But then, as you can see down here, there are a couple problems. Let's start with an advantage, which is that it's very easy to implement. You don't need any other tables. But there are a couple disadvantages. One is that there's a limit to how many tags you can have in there, which is the length of, whatever the column is. If a bar chart, whatever the maximum length is, you can only put so many in there. The other problem, or another problem actually, is that you can't store additional information like, if we wanted to store the first time a hashtag was used, if I wanted to be able to see the first person to use the hashtag, whatever, cat or something, I'm not storing the time that something was tagged because, on Instagram, you can add hashtags after the fact. I'm sure they're storing that when they're tagged so that they can track trends as hashtags come and go. So it doesn't allow us to store additional information like that. And then the other thing that's kind of important is that you have to be careful when you're searching for stuff. So if I was trying to find the hashtag food and I wanted to see nice food, beautiful food, so the hashtag is just food, well, it will return this, which has sad food, if I'm just doing like food. So I'd have to be careful, and I need to add spaces maybe to make it easier to separate things out. Basically, you just have to be careful. There's ways around it. We've seen them before, how you use search with like. But the point is, this is an easy solution, but it's not going to be the best, and it's not the best for us right now. So another solution is to use two tables. So we have our photos as our photos table currently is now, but then we have a tags table where we have our tag name, in this case cute, and then a corresponding photo ID. So, if this photo with ID of 1 is tags cute, we put it there. And then a photo with ID 3, which is the selfie here, is also tags cute. And then photo ID 2 is tagged with microwave, and 3 with ego, 3 with smile, 2 with gross. So as you can see, we can have a single photo with multiple tags, like here, where we have this selfie. ID 3 is tagged with smile, ego, and cute. And we can also have tags that are applied to multiple photos, like cute. It's applied to the first photo and the third photo. So this works. There's unlimited number of tags. That's an advantage. We don't have to worry about how many can fit into the string. But a disadvantage is that, for one thing, we are storing, these tag names over and over and over, and these are strings, and that it's maybe not ideal to store all these different strings and have duplicated data. But it's not a big deal. The duplication isn't the problem. Really what it comes down to is that this is actually slower than the previous solution when it comes to things like inserting or updating or deleting. But then another problem is that it's actually slower than the previous solution. So in just a moment, I can show you a comparison that I didn't do, but there's a great article that I found where somebody does a speed test between these, the three solutions, to figure out when they perform best. So this is not one we're going to use either, but solution 3 is, which maybe you got, it involves 3 tables. So we have our photos table, unchanged. We have a different tags table. So this tags table is just a tag name and an ID. And then we have a middle table, a join table called photo tags or tag photos or taggings or something, whatever you want to call it, which is an instance of a hashtag being applied to a photo. And all that it is a photo ID and a tag ID. And that's it. So in this case, photo ID 1 is my cat is being tagged with cute. And then the same photo, my cat is being tagged with pets. And then we have, we can keep going. My meal is being tagged with microwave. And my meal is being tagged with gross, and so on. So we have these, 2 columns, and that's pretty much it. The advantage, again, just like the previous one, there's an unlimited number of tags, and we can also add additional information. So if I wanted to, when a tag is created the first time over here, I could store the first time it was created. And then over here, every time it's subsequently used, I could store, the time it was used or something. And so I'm sure there's some interesting data you could garner from that, or the location of where, where in the world it was used or something like that. The time of the day, I don't know, day of the week, whatever. And we also have less duplication of the tags over here. But then there are a couple problems, and they really come down to just more work. So when we're inserting something, if it's the first time a hashtag's been used and it's not in the database yet, we have to create it, and then we have to associate it with a photo using photo tags. And the same thing when we're updating. we have to, what? She just vomited. Anyway. And then we also have to worry about orphans. We should always all be worried about orphans, but in particular, when we're talking about these tables, when we're deleting something, right? If we delete a tag for some reason, which Instagram does, if there's a problem, if something is being misused or somehow being, controversial, they can be removed. And so then we just have to make sure when we're removing it from here, we also need to remove it from all associated photo tags. So it can be a bit more complicated, but basically it comes down to the cost of having this nicer structure is that it's just a little more work. And just as an end note here, I did mention earlier that there is this great article online, this guy who does speed tests of different ways of doing tagging. And it's written up. I'll include the link along with this video if you want to read it. I'll just spend 10 seconds talking about it. But basically, he does some tests here to show that depending on, one, the size of your data set, this example with a smaller data set, the second and third approaches I showed you with multiple tables are actually faster. But then as we get a larger data set with thousands of tags, it actually changes. So it's just interesting to note that and to read. But also it talks about how much time it takes to insert compared across the 3 different versions. And it's just an interesting article. But if you actually look at his conclusion section, which is probably what most of you care about, where is that? Is that he actually thinks that it would be best to have, if you're working on a huge app, to have 2 versions. The first version I showed you and the third version I showed you. And basically they are performed best in different situations. And this is getting into the woods a little bit, but basically the version that we're going to go with, the third one with 3 different tables, is faster if you're working with common tags, things that are used often. But if you're searching or you're trying to do joins with like rare is the wrong word, but uncommon tags that just aren't used very often, then it's actually slower, and it would be faster to do the first version I showed you where you store them as text. So this guy is suggesting to use a combination of the 2, which we're not going to get into, but it's just interesting to note that there isn't one best way, and that it really comes down to your needs, what your app needs, the product needs dictate. And in all likelihood, as an app like Instagram grows, or especially when it started out to where it is now, its schema, its database has undergone multiple big overhauls and changes. Probably not just the schema itself, but the database, whether it's going from something like MySQL to another type database, or a bigger change going from a relational database like MySQL to a non-relational database. So it's really hard to say what's best, but it's interesting to take a look at somebody who's actually crunched the numbers, and even after doing that can't necessarily give a definitive answer, because the answer is it depends. All right, so this will be a quick video where we just implement the 2 tables we need. They're both very simple. So tags is just an ID and a tag name. Photo tags is a photo ID and a tag ID. Okay, so here I am in Cloud9, and we'll start with our tags table. Create table tags, and all we need is an ID, which is an integer, auto increment, primary key, and then we'll also have our tag name, which is just a varchar 255, and we want to make it unique. We don't want to have, oh my gosh, if I can spell unique, we don't want to have any duplicates in there. And then after that, it would be nice to add a created at, like I said, so we could store the first time a tag was used or created. And that's it. So that's our tags table, this table here. Now we've got to worry about photo tags. So we'll do our create table photo tags, or taggings, which is also nice, I guess. Well, neither's nice, but also works. We don't need an ID. All that we need is a photo ID and then the tag ID. And those are both going to be integer, not null. There we go. And then on top of that, we need to add our foreign key constraints. Foreign key, photo ID is referencing the photos table ID field, duplicate that. Tag ID is referencing tags table ID field. We also want to make sure that a user can't tag the same photo with the same hashtag multiple times. And that's an easy fix. We just do our same primary key with 2 items, photo ID and tag ID. And that just ensures that we can't have multiple instances of the same photo tags. All right, don't forget our semicolon. It looks like I'm missing this comma here. There we go. Now if we try that, and we look at our tables, there we go. We've got comments, follows, likes, photo tags, photos, tags, and users. And that's it for our schema. We're done. So in the next section, if you'd like to tap out now, move on to the next section, I'm going to give you a massive file with a bunch of data that I created. It took way too long to do, that we'll be able to do some exercises with and get some practice working with a bunch of tables. But if you do want to see me just insert a couple tags and photo tags, I'm going to do that now. So if you're still here, I'm going to do that. I'll start with inserting a couple tags, and all we have is tag name. And just to verify that, if we go back up to our tags, it's just a tag name that we're inserting. So let's say I'm inserting the string, adorable, and we could have 2 more, let's say cute, and 1 more would be, I don't know, sunrise. Okay, so that will insert our tags. Can make sure that that works. Select star from tags. There we go. We've got our 3 tags. Now we associate them with photos. And so we've got 3 photos. I'm not, it doesn't matter what they are, but they have an ID of 1, 2, and 3. So if we want to do an insert into, if I spell insert correctly, photo tags, we'll start by taking the photo ID and then the tag ID. Okay, values. And let's say the first photo is tagged with adorable. And the first photo is also tagged with cute, because that has an ID of 2. And then we'll say the second photo is tagged with, I don't know, sunrise. And then the third photo is also tagged with cute, like that. Okay, so we can rerun this. Let's do select star from photo tags. There we go, looks good. And now the true test is, can we still insert something that shouldn't work, like a duplicate? We already have, 1, 1. So insert into photo tags, photo ID, comma, tag ID, values 1, 1. And we get duplicate entry. So that's good, works perfectly. But as you can see, the other order works fine. 2, 3 or 3, 2 are not the same thing at all. This is saying the second tag, or this is saying the second photo should have the third tag. This is saying the third photo should have the second tag. Quite a mouthful. All right, so we're done here. Next up, we're actually going to play around with data. Like I said, I'm going to give you a giant file. Hopefully it's fun. And if it's not, well, we're basically at the end of the course. So just hang in there. Hey, welcome to the next section here. This one, we're continuing with our Instagram data. Let's see if Blue will do her trick again. Blue, can you get it? Oh, who's my adorable little kitty? You can stand up like a human. She's come so far. Just like you have come so far. Yeah, so we're working with Instagram data. We set up the schema. Now all we have left is to do stuff with it. So the way this section works is, rather than me giving you a bunch of tables, showing you, here's the result I want, we're going to do it a bit differently. I'm going to ask you more of a real world question, like, hey, we're doing a sweepstakes, or how about we're doing a campaign, an email campaign to email all of our inactive users and send them a reminder that they should post. So we need you to get all the inactive users' email addresses. So something like that, where it's kind of in real world terms, not in the terms of a database, like select all users where blah, 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 but you'll have to translate it. So we'll do things like that, or we'll do things like, hey, we have a brand who's really pressuring us to figure out what hashtags are the most useful or what are generating the most likes. And they want to know what 3 hashtags they should use. So then you'll have to go write the query to find that answer. What are the best hashtags? How do you know? So hopefully that's exciting. Trying to make it kind of a nice ramp off to the real world just for the data section. And then after this, like I said, we have the web app portion of the course. Okay, so lots of exercises, all exercises and solutions in this section. Goodbye. All right, welcome to the next section. So what we're going to do here is basically take the schema design we came up with in the last section for a roughly Instagram-ish application with photos and users and comments and tags and follows and all of that. We're going to take that schema and implement it, and I'm going to give you a bunch of data to put in your database, like a couple thousand of things to enter. I wrote a giant file, and what we'll do is put that in there so we all have the same starting place, and then we're going to pretend that we're the company and we're trying to figure out certain things, like do we have too many bots on our application? Are there user accounts that are inactive? Are there user accounts that have never posted a photo? Maybe we could send them an email campaign, encouraging them to post a photo. Or what hashtags tend to be most successful, that kind of stuff. So all of this section, every video will be asking a question, which is basically a nice way of saying it will be an exercise. But we're now posing it, rather than me just giving you a table, which is what we've been doing, where it's a table and I just ask you to recreate this. I'm now going to pose the question as if we work at a fictional company and we're trying to find something out. For example, it might be something like, we're running a new ad campaign and we need to figure out which 5 hashtags get the most likes, something like that. So that's how this will work. Every video in this section will be a question, and rather than having all of the solutions at the end, making a giant video that takes like half an hour to go through, I'm just going to break them up. So every video will have the question at the beginning and then a following solution. But the first thing we need to do is insert all of our data. So included in this section is this file here, starterdata.sql, and there's 2 components. The first one is setting up our schema, and there's nothing new here. We talked about all of this in the last section, but if you were following along and doing it yourself, you may have named something slightly differently. Like instead of photo tags, you may have called it taggings, or instead of, instead of followee and follower and follows, maybe you called it following or relationship or something. So in order to give you this data here to insert, I needed to make sure that we all have the same schema. Even if just one thing is named differently, it's a problem. So the first part of this is just a bunch of create tables, all the tables we discussed, as well as dropping the existing Instagram clone database, creating a new database, and then using it. If you want to keep your current Instagram clone database, if you've been working with that, just give this a different name, whatever you want. But you need to do it to all 3 of these. Okay, so we set up the schema, but then the fun part, which is all these insert statements. And it doesn't look that impressive when you look at it in Cloud9 because it doesn't wrap them onto new lines. And if I start scrolling, you'll see I'm scrolling really fast, but look down here at the progress bar, I've barely made a dent. And this is not a great way to visualize the data. So instead, here I am in Sublime Text, and here's the file that I generated. It's the same exact file, it's just displayed all here. Rather than having to scroll across, I have to scroll down. So, we won't do any sort of grand tour of the data, but I will say this, I spent a lot of time trying to figure out how I wanted this to work. Obviously, I didn't type this myself. I would have taken like days probably. Instead, I wrote some code, which still took probably a entire day and a half to get this how I wanted, because I didn't want just randomized data. If I just wanted to insert a bunch of random users and posts and comments that have no meaning to it, I could have done that pretty quickly. But instead, I tried to design this so that there is certain personas to our users. So some users post a lot, so they have a lot of comments, a lot of posts. Some users are lurkers, meaning that they don't really do anything except look at people, maybe like certain things at best, but they don't comment and they don't post. Then we have things like bots, which on Instagram are a real problem, where bots are accounts that exist basically to go out and like a bunch of things, comment on things, usually the same exact comment, but they don't post things. And then we also have like celebrity accounts who have very few people that they actually follow, but they have tons of followers. And they're not very active with commenting or liking, but they're very active with posting. So then we've got things like hashtags, and I didn't want to just do a bunch of random hashtags. I tried to actually come up with combinations of hashtags that would be common. So, things like smile and style and fashion might be together often, but then we might also have smile and party or concert. Those might go together. Or we might have, landscape and sunrise and sunset and beach could be a combination for a beach photo at sunset. But then we could also have beach with party or beach with beauty or something like that. So that's just kind of scratching the surface, but I tried to design a lot of that in there so that we had somewhat realistic data. With that said, things like comments, the text of a comment is just random lorem ipsum text. So there's nothing there, that's going to be meaningful about the comment itself. What's more meaningful is the relationship between the comment and who posted it, and if they have a lot of comments or they don't have many comments, and that sort of thing. Okay, so that's enough of that. So even with all the effort that I've put in here, there's still only 100 or so, or exactly 100 users, about 250 something photos. But then when we start talking about likes, there's thousands, and comments, there's tons, and following or follows, whatever we called it, there's tons, and tags, there's only maybe 20 hashtags, but then when you apply them to all of those photos, 200 photos, we get thousands too, thousands of instances. So all you have to do is get that into a file and then execute that file. Let me scroll back over, it'll take too long. Oh boy, almost there, here we go. So execute this file, and I'll just do that now with source Instagram / starter data, and that should just be the path that corresponds to wherever that file is and whatever you named it. Okay. So it takes a little bit compared to what we've seen so far. So if you take a look, we've got, a bunch of tables being created, 7, I think, and then a bunch of things being inserted, 100, 257, 7,000, 623, 7,488, 8,782, 21, and then 501. So this is still a very small data set compared to, tiny, minuscule compared to Instagram. This is maybe like a minute of Instagram activity, or probably less than that, a couple of seconds, as far as the number of photos and stuff. But it's still an order of magnitude greater than what we've been working with. One other thing that I'll show you is that we haven't really seen giant amounts of data like this. And if you try and let's do a select star from likes, which I think we have a lot of, you actually, if you start to scroll through it, you'll see that we're not going to be able to see all of them. There is a number that the terminal or that the CLI will print out for us, and then it just gives up or it decides not to display all of them. That doesn't mean they're not there. So if you did a count, for example, count star from likes, we get 8,000. And if you join them with another table, it will join all of them. It just won't display everything. So for some reason you needed to display every single like, it would be better not to do it using the CLI, but to do it from another file or some code somewhere. Anyways, so that's it. We've got the data set up. If you'd like, play around with it, explore it a bit, and then we'll start with our fun challenges in the next video. All right, so we have this data in our Instagram clone database. Now we're going to ask some questions. And the reason I'm phrasing it that way, asking some questions, is because that's usually what you're actually doing. If you work with SQL or SQL, some SQL database or any database really, even if it's like a MongoDB or CouchDB, Postgres, MySQL, any database out there, and you have a bunch of data in there, a lot of the time you're just sticking stuff in there. But when you're actually working with the data and writing queries, a lot of what you're doing is asking questions where you have a motivation. You're trying to figure something out, whether it's for an ad campaign or a post-mortem after a campaign. I know I'm coming back to ads a lot. It might just be sales. Like you could be a woodworker, you make furniture, and you want to figure out how much you sold last year because you're compiling your tax returns or something, and you need to figure out the total volume you sold. Those are the questions you're asking. So you think in terms of English or whatever language you speak, you think in terms of questions in a non-SQL language, like how many X did I sell last year? And then you have to translate that to a sum or a select something from something else, and you have to use sum most likely. Anyways, so that's how we're going to work here. And we'll start out nice and simple in this first video. Suppose that we want to reward the users who have been around the longest. So you may have seen something like this on not Instagram, but other applications. You'll sometimes get, a coupon or just a thank you email. Thanks for being loyal over our 5 years or however long we've been around. So all we want to do is reward our users who've been around the longest. And to do that, we need to find the 5 oldest users, the users who have been around the longest. So this one should be simple, not crazy. We don't need to work with many tables. Short video. Try this on your own. Pause the video, of course, and in like 3 seconds, I'll be right back. And I'm back. So to do this, it's just a matter of basically selecting star from users, and then we just want to order them based off of the date that they were created, the date they joined, and then we'll limit it to 5. So if we hop over, what I'll do is make a new file. New file, where are you? And I'll just call it solutions.sql. And in here, the first one is just finding, let me put the numbers here so it's easier for you when you're looking at this, finding 5 oldest users. And we know it's going to be a select something from users. And if we start there, you can see we've got 100 users, which is one thing I wanted to point out. 100 users is not very much, but I capped it at 100 because basically the formula that I imprecisely came up with for how often users are commenting and posting and liking and tagging, it grows exponentially depending on how many users you have. So having 100 users, we still have almost 20,000 records for everything else. And if I upped it to 200, or I tried 1,000 users at one point, it really started going crazy and our queries take a lot longer. So I decided not to do that. But if you want to try, it could be fun to, if you feel comfortable writing code to insert a bunch of users, do that in JavaScript or Python or whatever language you like. But for now, 100 users. It's just interesting to note how much data we get even with just 100 users. If the average person is posting, X number of times, and then we get certain celebrities who post all the time, not to mention people who are liking all the time, and we get bots who like every single photo, things quickly grow. Okay, so select star from users, but we want to order by, and our field is called created at, right there. So just order by created at, and if we just do it this way, you'll notice that at the bottom we have today's date, basically, well, roughly today's date. And then if we scroll up, we've got the oldest one. So we've only been around for a little bit, about a year, according to the data that I created. So what we'll do is just limit 5. And there we go. That's all we need. So nice and simple for this one. I wanted to start off with some review, but don't worry. If this felt way too easy, that's good. We're going to move on and get into some more exciting / potentially nastier territory. All right. So the next problem here, the next question, is that we're trying to schedule an ad campaign, our own internal campaign that we're going to, well, not internal, but our own campaign where we're trying to get people to sign up, new users on our application. Let's say we're advertising on, Facebook. We're also considering maybe for a single day, we're going to go and put an ad out like on a billboard. We can't afford a billboard for an entire week, so we're just going to do one day. Yeah, it's kind of hypothetical, but still, let's say that's what we're working with. And you could expand that obviously to whatever the budget is and whatever your constraints are. But for us, low budget, and we're just going to run an ad for a day. we want to figure out what day we should do that on, what day of the week is going to work the best. This is something that is definitely relevant, even though it's simplistic here. We're figuring out, days of the week or time of the day. Just as a photographer, that's something that is useful, that people are always trying to figure out is what's the best time to post something on Instagram? What's the worst time? What day of the week is the best? Do you wait, for what time zone do you try and post according to? Do you post something so that people in Europe will be able to see it when they're waking up? There's this whole science, and that's just for photographers on Instagram who are not even really making any money from it. So if you start thinking about advertisers, then that's where it really matters. So we're just doing this simple thing to figure out when users register, but there's all sorts of insights to be garnered about when people are posting photos and how many likes photos get depending on what time of day they're posted and all that kind of stuff. But we're working with this. So what day of the week do most users register on? So we only need to work with users still. So I'm going to just add a comment, most popular registration date. So we can recycle part of this query, select star from users, and we don't really need to order by anything at this point, so I can get rid of that. So what we'll want to do is use a group by to collapse these into similar categories, but we can't do a group by created at, because unless somebody registered at exactly the same time down to the second on the same day, group by won't work, and it will just have 100 unique users. So what we can do is basically extract the day of the week, which we've seen how to do that. So let's start with that. Let's just do select username, comma, and I'll do this on separate lines. Username, comma, and then we want day name. This is one way of doing it. You could also use format date, but day name, I happen to remember that one. Although there are all those other methods I don't remember, or functions I don't remember that I've talked about, like the name of a month, I always forget. So sometimes I do end up just pulling open the docs and trying to find the right function. But day name, and then we just pass in created at. Okay, let's try that. Oh, semicolon, before I forget that. So now we're seeing the day of the week. So now all we want to do is group them by those days of the week and then count how many people or how many instances we have for that day of the week. And then from there, we'll just order them to figure out what day is most popular. Okay, so rather than just doing this, we'll add our group by at the end. And we don't want to just do group by like a group by created at, like I said. We want to do a group by day name created at. And what we could do is just assign an alias here. So we'll just call this day. And then we can just say group by day. Now if I do this, I only get 7 results. Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. And of course, that's not all the data that's there. That's all that's printed out because these groups have been created and we can work with them behind the scenes or underneath the surface. So what we'll do, we can get rid of username at this point. We don't care about that. We're going to just group them by day, and then we're going to add our count star, just like that. And let's see what we get. Okay, so you can see it's a pretty even distribution. Let's go ahead and sort. So we'll do an order by day. Whoops, we don't mean day. That's ordering alphabetically over here. What we want to do is order by count star. So I'll give that an alias as well. I'll call it total. We want to order by total. All right. And of course, if we wanted to, can change the order. Technically, the question we're asking is what's the most popular day? And well, we actually have 2 days that are tied for that, Thursday and Sunday. Now this data is not relevant to the real world. I have no idea. Actually, I'm pretty sure those days are not the most popular. Last time I looked into it for my own purposes, I believe it was the middle of the week, like Tuesday and Wednesday, roughly late afternoon, early evening Pacific time, like 5 p.m. Pacific time was the best time. I'm not sure why. But again, I didn't create this data to be realistic. I just tried to come up with something that would be interesting, whether or not it actually applies to the real world's rules. Okay, so what we could do is, limit it at the end. If we just limited it to 1, It gives us Thursday because it comes first. We could do limit 2 as well. All right. And this is a good time to mention that for most of these things in this section, there isn't only one way of doing it. Sometimes there really is, but often there are a couple different ways of approaching things. And if you feel like you came up with something, whether it's just different and you're not sure if it's better, or you feel like you did come up with something that's more efficient or cleaner or that you prefer, absolutely don't hesitate to post that in the discussion for the course, and we'll do our best to get back to you with feedback on it. But at the very least, other students will be able to see it, and maybe somebody else came up with the same thing and they won't feel so alone in the world. Or maybe you did come up with something better that is actually going to benefit other people to see. But for now, this is how we're doing. Most popular registration date, and that answers our question. Apparently, we should be doing our registration campaign to get users to sign up on a Thursday or a Sunday. All right, welcome back. So we're moving on to our next question here, even though this one actually isn't framed as a question. There's no question mark, but that doesn't make it any less relevant or less real world. In fact, this is one that I think is a really common operation, a common question to ask, and it has to do with inactive users. So across any sort of startup or online app company, there's often, users who sign up, create an account, and then do nothing. Whether it means never posting or never buying something, never converting from a free account to a paid account, like in the case of Spotify, or never, in my case, this is a real example from my courses, students who sign up and then never start it, never make it past the first video. They're at 0%. And I'm actually able to send targeted, I think once a month, twice a month, I can send an email update, and I can target that to specific segments. So if I, updated an introduction section to a course and I only wanted to let students know who haven't started yet, I want to target them and say, hey, by the way, I noticed you haven't started yet. Well, this is a good time to start. I just revamped the whole intro. I could do that based off of what we're going to be doing here. Of course, our data and our database is set up differently, but it's the same idea. So this is a really common thing. And all we're going to try and do is, for our Instagram clone, our fake Instagram, we're trying to identify users who have never posted a photo. So they've signed up, they never posted anything. And we want our users to be more engaged for a bunch of reasons. We want higher engagement in our app, which means that we could, have higher valuation potentially, or sell ads for more, maybe get higher investments, all that kind of stuff. We want people posting if they're signed up. It looks bad to have dead accounts, people who sign up and then give up. So we're going to try and send an email. We're not worrying about doing that, but how are we going to target these people who have never posted a photo? First step, let's identify them. And essentially, we're going to need to work with the users table and the photos table. So I'll add my 3 here, which is identify inactive users, users with no photos. Okay, so you've probably gathered we need to do a join. We're going to be working with the users table, so we can start there. Select star from users, and we have 100-something users, but we can't see who's done what because we have the photos table. And if we do our select star from photos, just to jog your memory, well, I guess we haven't actually seen all of our data here yet. We've got exactly 257 photos. But a lot of them are done by the same user. So this here is user ID. If I scroll way up, here we go. We can see, these are all posted by the same user. So 3, these are all from the same user. These are all from the same user. But then we have some users who haven't posted anything. But there's no way of knowing that just by looking at the photos, because these are the posted photos. So what we need to do is join these two together. And hopefully you know what we need to do. If I just do a regular inner join photos, and where do we want to do it? We want to join on users.id equals photos.userid. And if we run this now, it's a mess. So let's focus on just the things we need. So rather than star, we can do username, maybe the image URL, and we can just start with those two. All right, so we can see, all these usernames and what they've submitted, but the problem here is that this doesn't account for the people who haven't submitted anything. So if there was a user who didn't submit something, they're not showing up here because we're doing an inner join, which remember is the intersection of both circles, the left and the right, where they overlap. But what we want is to identify where users on the left have no overlap on the right for photos. So we can change this to a left join. And that one change, if we rerun this, we'll have to scroll a bit. There we go. You can see we have certain users who have a null over here. And that's referring to the fact that they have no photos corresponding to them. So there's a couple of them as I go here. And that's what we want to be able to identify. So we're almost there actually. All that we need to do is only select the users that have photos of null essentially. And of course, if I go back to having star here, it's not just image URL that's null. It's everything in photos. It's hard to see. Here's an example. But we've got a couple of nulls here. We've got the image or the photo ID. We've got the image URL. We've got the user ID of the photo. And then we have the created at is null. So all four things are null. We just need to focus on one of them. It doesn't matter which one. So I'll go back to just adding username here. And we can do, it doesn't matter really. Let's do image URL again. And then all we want to do is add a where down here. But we can't just say where photos dot, we could just do ID equals null. That doesn't work. Remember, null is weird. So we need to do where photos.id is null. And this could be anything on the photos side. It could be photos.id, it could be photos.imageURL, photos.userID, any of them. So I'll just do it as ID. And if I do this now, you'll see, and we actually don't even need to display the image URL. But if I do that, this is our list of users who have never posted anything for whatever reasons. Some of them, programmatically, I created them as bots, which all they do is go comment and like other people's photos, but they don't post anything themselves. And then another persona of a user is a lurker, which is somebody who has an account and they don't use it all that much, but they just kind of look at people's photos, maybe like something, but they definitely don't post and they don't comment. They're kind of a silent member of the community. So we get a decent number of them. Sorry for that fire truck. And that's all we need to do. If we want to figure out how many, that's another thing. We could just add a count in, but we just want the username so that we can target them. These are people who have never posted anything. And just a note, if you did this the other way around, it would have worked just fine as well to do photos, users, and then a right join does the same thing. So either way works, but the key thing is that we're working with null, where we have an intersection where some users and some photos overlap. Most of them do. But then we also have that subset of users who have no photos, and we need to also join those with null, which is how we're able to tell if they have no photos. So here's my solution. If you came up with something different, post it and we can discuss it. Moving on. Alrighty, welcome back to our next riveting installment of asking random questions about our database data that we inserted. Yeah, that's what we're doing here. So our next question here is basically, I'll start the other way around for once. What we're trying to do is figure out what is the single most liked photo in our database. And I actually don't know if Instagram has done this before. I know third parties have. Like people have used the Instagram API to try and find the most popular Instagram of all time. That's essentially what we're trying to do. Let's say we're running a contest is the backstory I came up with, but this is something that just might be nice to know internally at a company like Instagram. Who is responsible for the most liked photo of all time, or the top 10 most liked? Is there anything in common? Or even the top 1,000? What ties them together? We're doing just one, and we're not just trying to find the photo itself, but we want to know who posted it, who is responsible for it, so we can send them whatever their prize is, or we can mention them in a blog post or something. So the first thing we need to do is just find the most popular photo to start, meaning the most number of likes, and then we can worry about the username and the user afterwards. So we'll do identify most popular photo and user who created it. Okay, so to do that, it's going to be a select. We'll do a select star to start from photos. And if we just start there, we have, 257, but no information about likes because that's a separate table, of course. If we do our select star from likes, we have 8,782 likes. And they're not all displayed here for us to see, but we've got two fields. We have the ID of the person who is liking, the liker, and then we have the ID of the photo that is being liked. So what we want to work with is the photo ID. We don't care about who is doing the liking. We care about, matching the photos with the likes that correspond to them. So that's going to be a join, and it will just be an inner join likes on, and we'll do where likes dot photo ID equals photos dot ID. So this is going to be, a big table here. Oh, what's my error here? Extra semicolon. Try that again. It'll take a moment. We've got, 8,782 rows, but just like we did with likes, but this time the rows are significantly larger. We have a bunch of data. We don't need most of that. So rather than just selecting star, which gives us too much information, let's whittle it down a bit, and we'll just do, photos.id and photos.image URL, comma, and then what do we have on the likes table? If you remember, if you go over to our schema here, likes is very simple. We just have our user ID and our photo ID. So we'll just do, we can do both. Let's just do likes.userid to start. And you can see, all right, so this is all, on our last photo with ID of 257, all of these are likes for that photo. And they are all, by this user, or they're by different users, user ID 3, 5, 10, 12, 14, 15. We don't need that bit of information. I just wanted to show you just so that you can tell we're getting something from the likes table. Now what we want to do is figure out how many each photo has. So we're going to need to do a group by. And before I do that, let's just space this out nicely. Okay, and we're going to group by. We could do the image URL, but it's much easier just to do it with the integer of the photo ID. So group by photos up here, .id. Now if we do this, we have 257 rows now because we only have 257 photos. And then over here, this is still just displaying the first ID of the user who liked that photo, so that's not relevant. What we actually want to do is display the total number of users who liked it. And that's just a matter of a simple count now that we've grouped them by photos.id. And now you can see over here, we've got photos that vary. Some of them have a bunch of likes, some of them not so many. Now all we want to do is find the number 1. We could use maximum or max. I'm just going to do a limit 1. For that to work, we need to do an order by. So let's actually start with the order by. And we want to order by count. So I'll give it an alias. I'll call it total. Order by total. And by default, that will be ascending, which is not what we want, right? We want the opposite. Getting there. Okay, closer. Then finally, what we want to do is limit it to 1 and move our semicolon. Okay, so that gives us the name, the ID and the image URL and the total number of likes for the photo, the single photo that has the most likes, which for us is 48. And this is the image or the photo. Now we want to figure out who it belongs to, who created it. So we could do a separate query. We could even do a subquery if you wanted to. But the easiest way is to do another join. So I'll go ahead and show that join. Basically, all we need to do is get the user information in there as well. And so we're just going to do another inner join, this time on users. And we're trying to connect it where not the likes.userid. That's the ID of the person who liked it. We don't care about that. We want the photos.userid equals users.id. And now you're not going to notice anything right away because we're not displaying it, but we are joining all the user information. And all that we really want is username. So now if we run this, you can see we get Zach Kemmer 93 with ID of 145 is a person who is responsible for our most popular photo of all time. This photo, Jarrett.name, is our URL with a total of 48 likes. All right, next up here, this one will be nice and short. All we're trying to figure out is how many times does the average user post? So we have a board, or our investors want to know basically what our engagement is like, just in general, for every user, any user, how many times can we assume they've posted? So this is just across the board, and really all we need to do is take the total number of posts, photos, and divide it by the total number of users. And you could do that separately in different lines. Or you could, do a big join statement between users and photos, and then use average and calculate average. But you could just do it using subqueries, which is what I'm going to do. So something a little different. So we'll just do calculate average number of photos per user. So what we're looking for is total number of photos divided by total number of users. And the first part, well, each of those parts individually, we know how to do. We can just do a select count star from photos, and that will give us the total number of photos. If I add a semicolon, 257. And then for users, I just need to change that to be users. Select count from users, and we get 100. Now, if you're good at mental math, even if you're not, it's easy to figure out our average in your head, but of course we're trying to do this dynamically so that if we have X, 10,000 more users tomorrow, this still applies. So using subqueries, basically what I can do is divide these two. So I can't just do this. I'll get a syntax error. What we need to do, like we've seen before with subqueries, is add parentheses around these two things. Okay, but even that won't be enough. What are we missing? Well, it's just like we can't just say 5 plus 5, or we can't just do 1 divided by 2. We have to say select 1 divided by 2 in order to get anything. So we need an extra select up here. Yeah, it's kind of a mess. We could do this on separate lines maybe. I'm not actually sure how to best format this because it's kind of a weird query. But maybe something like this. Well, we can leave it at that for now. And I'll comment that out. And now if we run this, we'll get this massive line here, but 2.57. So every user has 2.5, or on average, every user has 2.57 posts. That's thrown off significantly for a couple reasons we'll see later. There are bots and users who just don't post anything. And if we tried to get rid of these bots, our average would change. So we'll get there in a moment. What we could do is just add in simple alias. We'll just call it as average, AVG. Okay, and there we go. So that's the answer to that one. If you came up with another way, feel free to share it, and we'll talk about it in the comments. All right, moving on. Okay, so next up, suppose getting the brains of our Instagram clone application employees, and we make money by having sponsored content, by having advertisers post things on our app, and they want to know what hashtags they should use, which are most popular at any given point. So what we want to do is just find the 5 most commonly used hashtags so we can tell our advertisers these are the hashtags you should use on your own stuff because they're trending right now. It's what people are looking for. So to do it, it's pretty straightforward. We have a single join. We're basically going to connect hashtags or tags with photo tags. Remember, we have those 2 tables. The one table is just the name of the tag, and the other table is every time the tag is used and applied to a photo. So we want to count, basically, we want to group all of those photo tags together, count them, but then we want to find the associated name of the tag. So let's start that. We'll do 6 most popular hashtags, 5 most popular hashtags. So if we start with just selecting star from tags, as we've seen before, it's just a list of the hashtags themselves, and then an ID, a hashtag, name, and then created at. But we've also got photo underscore tags. And we've got a bunch of those, 500. And each one is just a hashtag or a tag ID and then a photo ID that it's being applied to. See if we can get to the top here. Here we go. So the photo ID 14 is being tagged with whatever has tag ID 1, which is sunset. So photo 14 has the tag sunset. So what we want to do is we can start, if we wanted, by just focusing on these and counting how many times each tag was used, but it makes it a little easier to follow if we join tags, so we have a name of the tag as well. So we'll do that. We'll do select star from photo tags, and then we'll do join tags, get rid of the other stuff here, on photo tags dot tag ID, which is this, where this tag ID equals tags.id. So now what we see, there's a lot of stuff, 500 rows. If we go up to the top, we can see they're already being grouped roughly, not exactly, but they're being grouped roughly by the tag name. So we've got, 14 was tagged with sunset, 21 was tagged with sunset, 45 was tagged with sunset, and so on. So then what we want to do is basically collapse them using group by. And we could use the tag name to collapse them, but we could also use the tag ID, which is easier because it's just a simple integer rather than having to work with strings and text. So we'll do the tag.id. So that's group by tags.id. Now we do this. We're getting closer. Now we only have 21. Because they've been grouped together. Then finally, rather than selecting star, let's select the tags.tag name, comma, do these on separate lines. We want the count star. Okay, so we can see things like sunset was used 19 times, photography 16 times, sunrise 17 times. Then we'll go and give this an alias as well. We'll just call it as, what's a good one? Total. Okay. Next up, we want to find the maximum. So you could use max, but what would be better, what I'm going to do is just use order by and then limit, because we want the 5 most popular. So actually you couldn't use max because we want 5. So we'll do order by. What are we ordering by? This count here, which we called total, order by total. And if we do that, it will be in ascending order. So we want to change that. And then we want to limit it to 5, and that should do the trick. And there we go. We see that the top 5 tags right now, number 1 by far is smile. Apparently it's very popular. And we've got beach at 42, party 39, fun, and LOL. And I know for smile and beach, I kind of engineered to be there because when I was making the data, I wanted some hashtags that could be used in multiple contexts, and things like beach could be used in a landscape photography shot alongside sunrise or sunset or landscape, but it could also be used like in a model photography shot alongside model or beautiful. It could be used in a party, alongside a party hashtag if it was a beach party. Smile can be used in a lot of ways, so can party. So anyways, I tried to come up with certain tags that could be used in different ways. And there we go. Those are our top 5 hashtags at the moment. Next up, you guessed it, something else. All right, next problem here. This is a little different. So as I mentioned earlier, a real problem on Instagram are bot accounts that basically exist to go around and like a bunch of stuff or to comment on people's things, but not create their own content. They're not real people. Oftentimes they're commenting the exact same thing. Or like if I post a photo, I'll notice I get like 10 likes immediately, like the next second. And usually there's not 10 people who are happening to like it immediately. There's some sort of program that's happening behind the scenes where it's looking for new posts and liking them immediately. So in our hypothetical Instagram clone, we have the same problem. So what we want to do is just find all the users who we think could be bots they're users who have they're users who have liked every single photo on the site. So if we have 257 photos, they've liked all of them. If we have 800 photos, they've liked all of them. And I'm going to show you a way of doing it that actually uses something we haven't seen yet, something new. So go ahead, give it your own shot, and then we'll have a solution. Okay, so the first thing we want to do, we know it's going to be a join between users and likes. So we can start with let's do select star from users, and we'll do an inner join likes. And the reason we know it's an inner join because we don't care about users who don't have any corresponding likes, or likes that don't have a corresponding user. Those shouldn't exist. So we want the inner join. We want the overlap only. So select star from users inner join likes on users.id equals likes.userID. And if we start with that, takes a moment. We've got, remember, 8,782 likes. And now what we want to do is group them based off of the user who did the liking. So we'll have a group by, and we have a bunch of choices of how we group them. We could do users.id, or we can do likes.userID. We'll save. Okay, so now we have 77 rows here, and we can see, there's a bunch of information. We've got the username. We don't need created at, so let's slim this down a bit. Let's do select username, user ID, and we'll just keep it at that. Okay, so these are all the users who have liked anything at all. We're grouping them, right? So they're grouped by user ID. I'm missing a comma. That's what's going on. Now what we want to do is figure out how many. So that's just a matter of using count star, which you should feel pretty good about now. We'll give it an alias right now. Okay, and we can get rid of user ID as well and just do username. Okay, so we can see that we have Andre Purdy85 has 94 likes. Let's give this actually num likes. But the question was not just to figure out who has the most, but to figure out the people who have liked every single photo. And if you don't remember how many, we have 257, but we're not talking about cheating. We could cheat if we wanted to check exactly for 257. It's not too bad, but you might think you could just do like a where num likes equals 257, but that won't actually work. And that's because where clauses actually go before the group by, telling it what the data you'd like to select to group versus what you'd like to select from the group's data. So where doesn't work. We need to use something different, which we haven't seen, which is called having. And having acts like where. It's just a different word. And what it will do is take our group's data, our end result, and allow us to filter based off of a clause. So we can say having, and we want to say total equals 257, just like that. So now if we do it, total, I changed the name to num likes, but now if I do it, you can see, okay, these are the people who have liked it 257 times, liked every single post. But the problem again is we hard-coded 257. So we could fix that very easily. We want this to be dynamic, however many photos we have, and we can just use a subquery to select count star from photos. So this will be where the number of things they've liked is equal to the total number of our photos. And there we go. We get the same exact thing, but this time if I add 1,000 photos or remove 10 photos, this will still always be the total number of photos. Okay, kind of an ugly query with a subquery here, but if you came up with something different, post it. We'll have a discussion. Hey there. So this section is all about Node.js, and the core of it is how do we take a programming language, any language, PHP, Ruby, Node, Python, any of the other ones out there, and how do we combine it with MySQL so that we can do things like build web applications. And in this section, we're not getting to the web app just yet. So for a lot of you, I know that building a web app has sort of been like the, whatever you call this thing, the catnip, I guess, or the toy that has been dragging you through this course, getting you through the more dull parts, knowing that you'll see how to make an app at the end. But remember, this is not a web application course. This is a course on MySQL. So it's just a small part. But if that's what it takes, it's the light at the end of the tunnel, well, we're basically through the tunnel now. And like I said, in this section, we're not building the web app just yet, but we are seeing how to connect MySQL to another language. In our case, it's Node.js. And so what we're going to do here, it's a tricky situation for me because I don't have the luxury of teaching everybody Node and teaching all the basics that you need. So we're kind of going to do a crash course at the beginning. Then we're going to work with a file of JavaScript and connect it to a MySQL database so that we could do things like randomly generate 500 users and insert all of them with one go. So we can insert 500 users manually, but how could we make 500 random users every time I run a file? That's what we're doing. And then in the next section, we'll build a web app to connect to our database. All right, we're almost there. Alrighty. So as I mentioned in the previous video, this section is a big turning point, and hopefully you're excited about it. I'm excited to teach it. We're going to go from what we've been doing for the last 12, 13-ish hours of content, basically working with MySQL on its own, querying a database, and getting a result printed back to us immediately, which is great. But we're going to go from that to creating applications with MySQL. We're not going to learn how to create complex video games or crazy iOS apps. We're focusing mainly on web applications, but the ideas are the same. I'm going to show you how you get an external language like JavaScript or PHP or Ruby to talk to MySQL, and we'll build a couple things with that. Now, let's quickly review what we've done, not the entire course, but the way we've been working, and talk about the merits of that. So we've been working with the CLI mainly, having a database of users or books or whatever it is, and asking questions, selecting sales data or orders data or customers, and trying to figure things out like, how much did we sell last week, or what day of the week was our best selling day across the last 2 years. Those are really important and valid and just common uses of MySQL. So there is this whole subset of creating applications that we're diving into now, but there are tons and tons of jobs, lots of people who, when they work with MySQL, all that they do, not to diminish it in any way, because they can write some pretty complex queries, but they're working with only MySQL, and they're opening up the CLI, or they're writing SQL files like we've seen, and they're just saving and running those files. So they want to see, okay, what was my commission that I made in the last year? Calculating tax, whatever information, summing a bunch of information in these tables, or doing a complex join to figure out which promotion worked the best. Those are really important and common uses that people do all the time. So it's not just about building applications, but we've seen that first part. We've seen how to do that. We've worked with tables. We've been writing lots of selects, inserts, updates, deletes, all of that. Now we're going to see how we work with other languages. So now it's time for MySQL plus any of these. Pick one. And the reason I'm even showing you this page is not to intimidate you, not to make you think you need to know all of these. You only need one. So depending on what you're doing, there are strengths and disadvantages to certain languages, but really all of these will work. They all have ways of communicating with MySQL. So if you're someone who is comfortable with a language, like if you grew up working with Java, or you took a Python class in college, or whatever it is, you can find ways, I'll talk about what they are, of connecting MySQL and whatever language you're comfortable with. The one we're going to work with is called Node.js. It's getting very, very popular. It's been pretty popular for the last couple of years. Very versatile language, lots and lots of users, great documentation out there. Now, we could have also gone with PHP. Some of you may be wondering about that. PHP and MySQL historically have been a bit of an item, a couple that were spotted together all the time. In the next video, I will talk a bit about PHP. It's totally optional, but I didn't want to bog you down in this video with it. But there are a lot of opinions out there. I'll give you a 10-second preview. A lot of people think PHP is dying. It's certainly in decline compared to where it used to be. It used to be the king of programming languages on the web. Now there are lots of competitors, and people are leaving PHP. That doesn't mean that it's a bad language. There are problems with it. This is my opinion as well. There are problems that other languages have been able to solve better. However, there's a big user base out there. Yes, it's not growing as fast every year, but there are still millions of people using it. So do not shy away from PHP if you're comfortable with it. If you want to use it, there's lots of examples out there. But I didn't want to make this course just another PHP and MySQL course. There are dozens. They're getting dated, but there are dozens of them, even on Udemy. Lots of MySQL and PHP. So I chose Node, and I'll talk more about why in this optional video coming up. Basically, JavaScript is the most popular programming language for the web right now, and Node uses JavaScript syntax. And just generally, Node is a great choice. And I could have gone with any of these, although I probably wouldn't have done any of the C languages, but Ruby or Python would have been equally good choices. However, I went with Node because, honestly, that's what people want to learn right now, and it's what a lot of the jobs out there are for. Okay, so that's all I'll say about that for now. Like I said, any of these will work. The next thing I want to talk about is how do they work? What do they do? So we pick a language. We're working with Node, but then what? What's the point of using a programming language? How does it talk to MySQL through external code, and what kinds of things would you do? So here's a little diagram. Imagine that there's a web application. My computer, when I go to, this is hypothetical, Amazon.com, I hit enter. A request is made, and I labeled this as Node.js. Amazon does have some Node in their stack, but this could be any language, so that doesn't matter. But I send a request. Hey, Amazon, can you give me your homepage? Or can you give me my personal profile page? I want to update my email address. How about that? And then the code, whatever it's written in, is going to talk to MySQL. It's going to say, hey, MySQL, this user with the email of colt@gmail.com is trying to get his profile page. I want to select all information related to select everything from users where email is colt@gmail.com. That query is run, so from Node or whatever this is here to MySQL, and a result comes back. And it could be, I'm sorry, there's no users table. I don't know what the heck you're talking about, Node. Or it could be, okay, here's the 5 items in that row about Colt. And then that comes back. So that's kind of this two-way street. And then whatever the programming language is here is then going to compile whatever's sent to me. So the Amazon homepage. So it's going to take all those results and it's going to build a web page for me and send it back. Now, this is not a course on web development. I have another video where we talk about what this course is and isn't and how I'm going to go about covering things like HTML and CSS. I'm going to cover them, but not in a ton of detail because could take hours. I have a 45-hour course on that content. So this is really more focused on the MySQL part of things, which makes sense. It's a MySQL course. Okay, so with that said, I missed the last arrow. Something is sent back to a computer. So it's this cycle where there's kind of 3 entities. There's a device over here, my computer. It could be an iPhone or Android phone. It could be, I don't know, it could be a smoke detector. It could be a Nest camera, if you have ever seen Nest cameras or any like web-based security camera. I'm not saying they work with Node and MySQL, but there's some database somewhere storing information, and there's some app somewhere running that is listening, that's getting videos sent back or updates from a smoke alarm. Or it could be a virtual reality headset. It could be anything really, any sort of device, another computer, a phone, something else. And then this here, like I said, doesn't have to be Node. That's what we're working with. But you could easily replace that with another language, PHP or Ruby. And then, yes, you could have a different database, but that's not what this course is about. But you could, have a virtual reality headset that's working with Ruby, although that's not a great game development environment. Maybe you're working with Unity and you're writing Java or something. But then you're working with another database. It could be anything, MongoDB, Postgres, or MySQL. The core idea is the same. Okay, so that was a lot of talking. Like I said, there's an optional video coming up about PHP versus Node and other languages. It's mainly my opinions, but there is some interesting data to take a look at. If you're curious about how I came to the conclusion I came to, I spent a lot of time thinking about how to teach this. And what I'd like to do is add kind of alternate versions of what we're going to build here and build a Ruby version so you can see it, and then build a PHP version and build a Java version so you can compare it. But that will come later. This is, I made a decision, and it's an informed decision, and I'll explain why if you're curious in the next video. And then after that, or you can skip right to the next video, which is going to be introducing the project we're going to build. All right, so I'll start this video off with a quick anecdote, stupid story. I have a course online right now. It's done relatively well, a lot of students, and it focuses on a bunch of technologies, including HTML, CSS, JavaScript. We talk about Node.js as well, talk about MongoDB, and a bunch of other tools that go along with them. And at least a couple times a day, I get comments or questions or people demanding that, it should cover PHP or it should cover Ruby, or why doesn't it cover C or Java? And those are valid questions, right? People have reasons for wanting to learn different things. So I'm not trying to diminish their concerns, or, I'm not trying to say they shouldn't want to learn those. But there's no way that any course can teach all of those. And there's no reason that it should, because like I said, you only need one, maybe two. So the reason I bring that up is that it's kind of a contentious thing. People, especially students, when people are learning to program, it's overwhelming. Everyone tells you to learn something else. It's very confusing. Do you learn something that's easy to learn because it's easy to learn? Or is it better to learn something that's popular and more people are using, even if it means that it's tougher? What's the best route? And I think the answer is there's a different way for everyone. It's kind of a lame cop-out answer. So when you're making an online course, you have to decide. And what I decided for this course is we're focusing primarily on Node, and the typical kind of conventional choice would be PHP. So I want to talk about why I made that decision. And the first reason is that I personally am not crazy about PHP. I've done some work with it, some work with WordPress. It, like I said, used to be very popular. There's still a lot of people using it, but it is no longer the reigning champion of programming languages on the web. Like 7 years ago, it was. That was the language that you used if you wanted to make a web app. But nowadays, there's so much more competition. People are writing things in Node, or they're writing them in Ruby, and tons of other languages, Scala, Clojure, all these different languages that you could use. And they all have benefits, right? They all have they came later. They were able to see what worked, what didn't work, where problems were with other languages. They all kind of try to address different things. So I won't go into a lot of the technical details. There's an interesting article online, is PHP the most hated programming language? Not that that is an excuse to not use it, but it's interesting. I'll link to it if you want to read about it. It basically talks about how PHP got so popular back in 1995 is when it started, and then where does the hate towards it come from? And largely, the consensus, at least, is that PHP was kind of cobbled together. It wasn't a consciously crafted, as this says here, programming language. Things were added over the years. And there's inconsistencies, there's some security issues, but you could actually say the same thing about JavaScript, which is a valid criticism, that it was created in, I think it's 9 or 10 days, kind of as an experiment. It wasn't some crazy planned out language, and things have been added over the years, and they're constantly kind of updating the specification for JavaScript. So that's not necessarily why I chose to not teach PHP and choose Node and JavaScript instead. It's really more about the data that's on this page. This is from 2016. It's a Stack Overflow survey they do with how many? 56,000 coders who answered the survey, and there was 45 questions. So if we scroll down, I'm going to click on Technology and go look at the Technologies tabs. We can quickly see, first of all, SQL, very popular. Good news. And you can see here we have PHP, which is in 2016 around 25%. If we go back to 2013, notice that it started at 35%, then went down to 28%, then up a little to 29, and then down to 25, so the lowest it's been. So you can see there are charts online that I couldn't find any that were copyright free, essentially, that had a license that I would be able to show you the image, but there are charts online. You can see the decline. It's not a very steep decline, but there's a decline. And at the same time, if we look at Node.js here, which was at 7.5%. Now it's going up to 9.9%, 13%, 17%. It's growing very quickly in comparison to other things around it. And then also, if you take a look, JavaScript is up here as number 1, which is great because Node.js uses JavaScript syntax. It is JavaScript. We'll talk about that if you're not familiar with it. So, if you notice the trends down here, more people use JavaScript than any other programming language. PHP appears to be falling out of favor as Node and Angular emerge. That's kind of the main takeaway trend. And if we scroll down a bit more, we can take a look at the top tech on Stack Overflow. You can see JavaScript up nice and high still. If we look at trending stuff, you'll basically see that it's all JavaScript, well, almost all JavaScript related. React is JavaScript. We've got Node. Nowhere on here is PHP. Now, I don't want to say that you only pick something based off of if it's trendy or not. That's not the point here. The point is more that I picked Node because it is something that will prepare you for the future. And if you want to learn PHP, there are so many options out there. And I didn't want to just make another version of a course that could have been made a couple years ago. I wanted to make the most up-to-date current course. So basically, it's a decision that I made. There is not one answer. You could still make a great PHP and MySQL course today. I'll probably end up adding a little PHP section, but it's not going to be the focus of the course. And minor thing, but it is interesting if you look at top paying jobs, or if we scroll down and look at what a Node developer on average is around $85,000. You look at PHP, $10,000 difference. So not that that's why I chose to do that, but it is interesting to see. And then finally, if we look at the correlated technologies, you can see PHP and SQL. There's a tight correlation there, right? But there's also JavaScript and SQL, which is what we're going to be focusing on, and that's becoming very, very popular, a great combination. So that's so that's sort of some of the data behind why I picked that, why I came to this decision, if you're curious about it. One other thing, there's a good Quora post about why PHP is losing popularity, why people are trying to do Node and stuff and Ruby, and why people are down on PHP, which hopefully the takeaway is that that's not my intention. Is that I am not trying to make PHP seem bad. I am just trying to show you another option. All right, so thankfully this was an optional video. You didn't have to sit through this, and not that you have to sit through any video, but well, we're done with it now. Thanks for sitting through that if you chose to. Next up, we're going to introduce our very exciting, fun project. All right, so we're back. If you watched that optional, kind of boring video, we're now moving on to an exciting and non-optional video, which is all about the project we're going to make. So we're going to build a simple web app to start using Node and MySQL together. So what is this app? Well, it's called Join Us, and it's a a startup mailing list application. So you've probably seen this before. When there's a new company that's launched, maybe you haven't, but if there's a new company that's launched, they're not quite ready yet, but they want to get their name out there. They want to start getting interested parties registered or collecting their information so they can send updates, or so they can invite them once the application is launched. So that's what we're going to build. Basically a way of collecting people's emails, and it looks like this. Now, I'm not, a great designer in any way. That's not the focus of this course. Hopefully you think it looks okay enough, but really what I just want to go over are the different features. Now, it's not very feature rich. The point is to make something simple, but to show you how we're connecting with MySQL through Node, and how this application kind of showcases both selecting information and inserting information. So the first thing you'll see, there's a photo here, and we don't have to worry about copyright or licensing issues. I actually took this photo. It's a bit of a brag, I guess. Sorry. But back to the content here. We've got join us in big letters, and then we've got enter your email to join, and then a number here. And this number changes. So 518 is basically the count of all the users currently in our database. So when I made kind of this, what will I call this? The alpha version that I made screenshots of that I made before, I have to make the app before I teach it. So when I made this version, I had 518 users in the waitlist, in the database. We are 100% not a cult. Then the other thing is this enter your email, join now button, which you enter an email, it's going to take that email address and insert it into our database. So there's kind of two things we're doing, right? Selecting, we're going to count how many users are in the database. We don't need all the information. We don't need 518 email addresses. We just want to know how many. And then we want to be able to insert something from a form. When you click this button, it's going to go send the data to our node server. Then the node server is going to send it over to the MySQL database, wait to see if it worked or not, and then it will do something, we'll decide what it does. Does it take you to a new page? Does it just refresh the page? Does it show you a message that says you're signed up? Whatever it does. But the key really is about adding information to our database and getting information out. Okay, so that's how it basically works. Let me show it to you. Here I am. I've got join us. Let's create a new user here. Let's call it, how about bluethecat@gmail.com. We click join now. And you can see it takes us back, which we can decide what to do. If we want to change that, I'll show you how. But now it says we've got 519 on our wait list. And I can refresh, I can stop the server, which we'll see how to do in a little bit. This will be 519. This isn't hard coded in. This is coming straight from the database. Okay, so that's it. Now let's talk about how it works. What's the workflow like? When I go on my computer, like I just did, and I refresh the page, or I enter that address, and I hit enter, a request is sent to our Node.js server, which we'll see how to set up in a little bit. And the Node.js server has code that says, oh, okay, this client is asking for our homepage. Well, on the homepage, we're supposed to have a number here of the total number of users in our database. So let's ask, hello, MySQL database, can you tell me how many users are in the database? And hopefully you're aware that would be a count. So we do a select count star from users. That will come back and we'll say, ideally, 518 or whatever it is, 1,000 users. And then my server, the code there, takes that number and it plugs it in, puts it right here, and it sends us the page. Sends it back, and I see the page. Same thing, roughly the same thing happens when I enter my email and I click join now. I'm sending my information, my email, to the Node.js server with a message basically saying, I want to add this. I'm signing up. So then my server says, oh, this time this person is trying to sign up. They're not just asking for the homepage, they're trying to sign up. Okay, MySQL, I'd like to insert this user with this email address. Then MySQL will say that worked, or, oh, we actually already have a user with that email, so we can't do that. Or something else, maybe there's an error. That will be sent back. Node.js figures out what to do. Do I send an error message, or do I send a congratulations success message? Do I just take them back to the homepage and refresh it? That's the decisions that are made here. So that's the basics. But then the next thing is, where do we start? There's a lot of pieces here, right? We have to talk about Node.js, installing that. We have to talk about how it communicates with MySQL. We have to talk about creating web apps and HTML and CSS and JavaScript, all of this stuff. There's a lot of moving pieces. So where do we start? Well, we're starting with this handy dandy green box. We'll draw your attention to the right side of the screen, which tells you we're starting basically with the relationship between Node.js and MySQL. How do we talk from JavaScript to MySQL? So we're going to start with basic things like I want to select the current date from JavaScript, or I want to insert a single user into MySQL. So no web app. This whole left side of the screen will be gone for the first part. But then once we have this relationship established, we figured out how to insert a user. We figured out how to select all users or select the count. Then we will then kind of expand into the web application and add in the logic for creating a web app. So that's our game plan. We're starting with this side. So the very last thing to discuss is what our table will look like. So for this web app, very simple, right? All that we need to store for every user, and we'll just call it users. We could call it, emails or interested people or whatever, wait listers, but we'll go with users. And all we need to store is their email address, right? That's the key thing, and that's all they're entering. But it's also would be really useful to store a created at. So we'd have a timestamps for when that user was created so that we could do things like figure out when most of our users signed up, or what day of the week most users are signing up, or just count how many users we've had, this year compared to last year. So it's really nice to have created at. It's very simple as well. So those are the two fields we'll be working with, the two columns, and that's it, nice and simple. And then the other thing to discuss is our game plan from here on out. And our first goal, we talked about how we're only working with this side of the table or of this diagram. What we're going to work up to is using Node.js to randomly generate and insert over 500 users into our database. So I had like 518 users in there. They all had unique emails. I did not code those by hand. I used a tool that generates them for me. And then I'm going to take that and insert them into our database. So basically shows you the power of using a language like Node, that we can very, very quickly generate data and not have to waste time getting 500 test users in there. So that's the first goal we're working up towards in this section. All right, so moving right along here, we've established we're working with Node.js. Now we need to set up our environment so that we can do that. Fortunately, Cloud9 makes it really, really easy. It's basically a single button press, maybe two, and we have a Node environment ready to go. One thing before I do that, I do want to talk a bit about what the course is and isn't. Yes, I know it seems like I'm leaving that a bit late, but really what I'm talking about is that this is not a Node.js course. This is not going to be comprehensive. This is not going to teach you, a tenth of what you would want to know about Node.js if you wanted to be a Node.js developer. This is not an HTML or CSS or, Bootstrap or whatever tools we use. It's not a course on those tools. They are helping us. They're serving a purpose, which is to make an app with MySQL. It's a MySQL course. And we're basically using those tools as needed. So I'll try and strike a balance as we go on here. I'm not going to just speed past and ignore, explaining what certain things are, and just assume or assume that you don't care what, a certain line of JavaScript does or what a line of CSS does. But I'm also not going to take the time to explain every single line, to have, challenging CSS and HTML and Node.js exercises and so on. We're still going to have exercises around MySQL. So I just want to throw that out there just to set your expectations. And also, if there is a chance that you want a full course on those technologies, I have a 45 plus hour course on those technologies that you can check out. But you don't need that course to get through this. That's kind of the point. I'm going to show you enough, but I'm not going to spend 10 hours talking about Node. Okay, so with that said, let's hop over to Cloud9. And we're going to go to our main kind of dashboard. So not inside of the editor, not inside the Cloud9 environment, but we're going to go to our dashboard. And you can get there by just going to c9.io, signing in if you're not signed in, and it will take you here. Now, I have a bunch more than you probably have, unless you've been playing around. But all that you need to do is click on Create a New Workspace. And we'll call it whatever you want. I'll call this Node and MySQL. You can call it whatever you'd like. And then what we're going to do is down here, this is the important part, click Node. So we could get away with any of these. We could install Node.js ourselves. It's not actually terribly difficult. If you want to install it yourself on your own machine, there are great instructions online. Just go to the Node.js website. You basically just download a package. But we're going to be doing this using Cloud9. It's going to make it very easy for all of us to be on the same page. And that's it. Node.js, give it a name. Create it. It will take a little bit. I'll use the magic of editing to fast forward through this. And we're back. And this is what we see. So there's a couple things. One, we have a new environment here. None of our old files are here. None of our old databases, the books or the whatever we've been working with, customers' orders, that's not here. It's not gone. You would just have to go back to that environment. But more importantly, we have Node installed here. And we want to test that out to make sure. So what Cloud9 does is they actually give you kind of a starter app that we'll just delete. But before we do that, we'll just make sure it works. So they have instructions if you want to try it. All that we have to do is type node server.js. And actually, before I do that, ignore my ice maker. It's very noisy. If we just do ls, all right, we see we have server.js. Let's just open it. There's code in here that we didn't write. We're going to get rid of all of it. And there's my fridge now. Oh boy, so noisy. Hopefully they're done now. So we've got all this code that we didn't write. This is Node. This is JavaScript. We'll be getting to stuff like this. We're not going to make a chat app. That's what this is, but we'll be working on something similar. So now if we do node server.js and I hit enter, we should get something like this. Chat server listening at 0.0 blah, 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 8080. Okay, so that's the first thing. If you get that, that means that node is working. If you get something like error, command not found, node, that means that node is not installed. And I highly doubt you would ever get that if you had created a new workspace and done this kind of the way that you're supposed to. But if you're just working on your computer or you're working in a different Cloud9 workspace that isn't set up with node and you try and type node, then you'll get an error. And then the next thing to discuss is, okay, we have our app running. We started a server. Now, how do we interact with the app? Which is something we'll be doing once we create our web app. We'll start it up, but we'll need to view it. You can actually click on this preview button and just go to preview running application. And here it is. Or you could also just copy this URL. I like to keep it in a separate tab and just paste that in. And we have a chat app now. If we wanted to, this isn't part of the course, this is not important that you understand, but we can send it. And I could do this in 2 windows. Now we have, Colt and anonymous, so I can decide on a name. It's my cat. And my cat says, meow, go away, send that. Anyways, you can see we have a chat app working. Here's a simple web app that we didn't create, but is running with Node, and that's important. Okay, so we can stop it using Control-C, just like we could stop the MySQL CLI. And that's where I'm going to end this video for now. Next, we're going to do sort of a 5-minute crash course on Node. But for now, what we talked about was creating the Node environment. We have this environment, and then we talked about how if we have a server running, we can preview it by clicking on preview, or we can open it in a separate URL or in a separate tab or window. One thing to note, I stopped it. So if I try and refresh the page now, I get an error. There's no application running. Okay, so it's time for a 5-minute crash course of Node and JavaScript. Obviously, that's not enough time to even scratch the surface, but I'm just going to show you the basics of what you need to know for us to continue on with the course. Okay, so back over in Cloud9, we will delete everything, get rid of it. So you can do that either if you want to use a command line, you could use rm and rm-rf, or just highlight what you need to delete, right click, and where is that? Delete. And then we'll say yes to all. We want to remove all of it. And we're home free now. Can get rid of some of this stuff. Perfect. Make some space. I'll bring this up a bit. And now all that we're going to do is make our first JavaScript file. We can call it whatever we want. You can either use touch app.js, or you don't have to call it app.js, or you can right click over here and click on new file. I'll do that one. And I will call this, well, I'll do app.js. It's a standard name. Okay, and I won't recreate it down here. Now we'll open it up, double click, and we'll add some JavaScript in here. So what I want to show you is this basic workflow with Node that we kind of saw already. We type some code in a file, we save it, and then we execute the file with the command node space and then the name of the file. So it's very similar, at least in principle, to what we did with the SQL files, where we would save a SQL file ending in .sql, put something in there, a query, then we would execute it using source and then some file name .sql. Same idea. So I'm going to show you some very simple code. There's something called, and again, if you know this stuff, feel free to skip it. Something called console.log, kind of the simplest possible command you can do in MySQL. It will just print something out. So we can do our basic hello, whoops, we don't need caps. Hello world, and we'll put a semicolon there, which should seem familiar from MySQL at least. And let's start with this, our first application, very basic. And all we need to do to execute it is come down here and type node and the name of the file, which we called app.js. And it runs. Silly, but it works. Okay, so that doesn't seem useful, of course, but it's something, right? And to see kind of why a programming language would be useful, let's at least do this 500 times. Maybe that's not useful, but we can at least see how it's helpful at doing something that we can't do on our own. So we can create a simple loop. We'll do less than 500. Now, in my other courses, this is like an entire video, 5 or 10 minutes with exercises, but I'm not going to spend time on that. What this here does is it says whatever's inside of here, repeat 500 times. Basically, this is a counter saying, okay, we're starting at 0. And every time through the loop, we're going to add 1 to I, which is what this does here. So we go 0, next time around 1, 2, 3, keep going while it's less than 500. As soon as it hits 500, we're done. Okay, so if I just put that in there, whatever is in these brackets here will happen 500 times. Let's do it now. One thing I could add that I probably should is this var keyword. It's just, don't worry about it, but it's important to have it there. Now if I run it and I scroll up, you can see we get hundreds of hello worlds. Well, 500. So imagine, you might be wondering, why do you care? Well, imagine instead of console.log, what if we had insert a new user into the database? That would be a fantastic way to quickly seed a database with a bunch of data. Remember how we had to do this obnoxious copy and paste? So I would give you a file, you would copy and paste it, like for the movies data and reviews, there was these big files, you had to copy and paste it in. It's an awful way of getting sample data. Well, we can use JavaScript to create data for us. So just a couple other things that I'll show you. We can do math and basic things like 5 plus 5, and I won't do this 500 times. We can comment things out, selecting them and doing command /, so that won't run anymore. So now I'm only running 5 plus 5. You can see we get 10. One other thing to address is what is Node, if you're not familiar with it? And that's actually a pretty common question. There's a bit of confusion about Node.js, which is what it's called, and regular JavaScript, and what the difference is. Basically, JavaScript is a programming language. It was created first. It's been around for a while, and it's existed as a language that you can use on the client side. So what that means is that back on this diagram, there's a line right here. Not right now, but imagine a line. This is the client side. So I could write JavaScript code that did things over on someone's, like on my computer. You could write code that would animate something or make a game or just add some pretty effects. That's not to say that it's not powerful, but traditionally it was used kind of to decorate pages, if you will. And it had nothing to do with databases. It had nothing to do with servers. You would use another language over here, like PHP, and you would use JavaScript on the client side of the front end. But then Node came around about 5 years ago now, and what it is an implementation of JavaScript written so that you can use it on the back end, so that you can do things like this. You can create a server with JavaScript instead of having to do it with Ruby or PHP, and it can talk to a database like any other server-side language. So to summarize that, Node is JavaScript. It uses basically the exact same syntax, but you can use it on the back end, which is what we'll be doing in this course. So I know that was a very brief introduction to 2 lines of Node and of JavaScript, but we're now moving on to more important things that are relevant to MySQL. And the first thing we'll do is talk about a package called Faker. So the first question you might have is, what is a package? And basically, Node comes with thousands and thousands of libraries. You might have heard them called, or packages or modules, code that other people have written that we can include inside of our application really simply. All I have to do is say install Faker, which is a package we're going to use. But we'll use another package later called Express, or we'll use one called MySQL. And all I have to say is install MySQL, install Faker. And there are thousands of them out there, like I said. And that's one of the biggest strengths of Node, is that it has a huge library of all these packages so that you don't have to do everything yourself. You can go and get some help by including somebody else's package. So the way we do it is through something called npm, Node Package Manager. And to install Faker, which, don't worry, I'll explain what Faker is. This is all we have to type into our terminal, npm install Faker. But before we go there, let me show you what Faker is. So Faker is a package that there's a bunch of different versions of it. I think the original one was for Ruby. I'm not positive, but there's Faker kind of implementations for other languages, including JavaScript. And what it does is it really helps us. It streamlines the process of generating fake data. So we're going to use it because we want to start off with a bunch of fake data in our database. I don't know, if you noticed, I had 518, 519 users in my database. I did not enter those manually. And they're all unique. They have a different unique email address. I did not generate those myself. So we're going to use Faker to do that. So Faker is very simple. I can say things like faker.address.county, and it will give me a random county name, and it has hundreds of them. Or I could say let's say name.job descriptor, and it will give me a random job descriptor. So there's tons of things in here: phone numbers, random numbers, file names, colors, avatars, emails, usernames, domains, passwords, like so many things that we could pick from. Credit card, fake credit card numbers, account numbers. You get it, hopefully. So back in Cloud 9 now, what I'm going to do is actually empty this file entirely, app.js. You can make a new file if you'd like. And now I'm going to install Faker so we can use it. So this video, I probably could have done a better job explaining this, is about two things. One, Faker, but on a higher level, packages in general and how you use them. So this is the workflow for using a package. We type npm install, the name of the package, and hit enter. And it will take a second. And that on its own installs the package. You'll notice I have a new folder here called node modules. Inside, there's all the Faker code, all this stuff. So all that is here now. I just had to type a single line. It's pretty awesome. Now in my app.js, I can't just start using it immediately. I can't just say faker.email or something. I first have to tell this file I want to use Faker. I have to include it or import it. And it's very easy. I'm just going to say var faker equals require Faker. So this right here, it's a variable. I can call this anything. I could say my Faker. I'm going to call it Faker standard. And this is the part that I can't change. This has to be Faker. So this is going to go find a package that I've installed in node modules with the name Faker, and then save it into this variable. So now whenever I use the word Faker, referring to this variable, I actually am referring to the package. So then we can do things with it. So we could do something like this: faker.internet.email. And that will generate things like this, or this, or this. Ori23, Simone Walsh, Aubrey_Daughtry, numbers. We've got Hotmail and Gmail and Yahoo. So this would be a pain if we were doing this ourselves to come up with 500 individual emails. And the other thing I'll show you is we're going to use it for dates. So I'll be able to say faker.date, and this is important, .past. So we don't want to have any future dates. Basically, we want to start with 500 users in our database who have signed up at some point in the past. So it will generate things like this. So we also don't want to have to do that ourselves. So let's start with faker.internet.email. And we need parentheses at the end, sort of like MySQL. It's a function, and we're telling it to execute. If I just do it on its own, and I run the file now, which is app.js, nothing happens. Well, that's a lie. It does happen. This runs, but we don't see the result. And that's because we need to print it. So we can do console.log like this. There we go. Now, if I run it again, I see, okay, we get a new email. Jared, Leila, Trevor, whatever. So we're getting these fake emails. We're going to use that along with, I'm going to copy this and do faker.date.past, which was the other thing I showed you. We're going to use those two to generate 500 users. So basically this is one user. So it's kind of fun to play around with Faker a bit. You could do, hacker.abbreviation or finance.currency symbol or Bitcoin address. Let's do address and then city. So we could do, I'll get rid of these two for now. Console.log faker faker.address.city. And if we save and run that, there we go, Robertoville. And if we tried it again, we get something different. New Alexandro Fort. So that's the basics of Faker. I will show you if you already know JavaScript, skip this section, but I just want to show a bit more, sort of the extended version of the crash course in Node, how we can string things together and make more complex logic. So let's say I wanted to generate a complete address. So I wanted, a number and the street and a city. Let's start with those three. So Faker has ways of doing that. We've got, what do we have? Street name and street address. So let's start with that. We've got faker.address.street address. Let's start there and run this again. Okay, so there we go. That's working. Then we've got the city, right? And then let's say we wanted to do a state as well, if we're working in the US. Perfect. So here's a complete address, right? Now every time, let's say I want 3 different addresses, I would have to copy these lines like that. Which is not the end of the world, right? We can copy lines. But there's a much better way of doing this. So what we could do instead is create what's known as a function. And I'll just call this generate address. Think of this as a way of reusing our code. And the syntax looks like this: function, a name, parentheses, and then brackets. And whatever we put in those brackets will be run every time I refer back to generate address. So on its own, if I just save this, nothing is going to happen. When I hit save, now I go down here to Node, we don't get anything. What I have to do is now call this function just like this. Now it's saying, okay, is there something called generate address? Oh, yes, there is. All right, well, let's run the 3 lines inside of it. So if I ran this 3 times, now it's only 3 lines to do that. And we get 3 different addresses. Of course, we might want to, compile these together so that they're not on 3 separate lines. Maybe we want commas between them. We could really improve it. But the point is that that's basically how you define a function. And we'll be working with functions later on. But for now, that's all I'm going to show. Okay, so that's the basics of Faker, the basics of packages. We'll be installing other packages, as well as the basics of Node. Okay, so we saw the very basics of using Faker, really just a single line. You know it's a thing and that it's a package. Now, our game plan from here on out is to use Faker to generate our data for us, get 500 users in there. But Faker on its own won't do that. So we'll use this faker.internet.email. We want one of those, or we want 500 of those actually, and we'll use the date.past. And the reason we need to use date.past is that when a user is created, yes, in the real world, we want to store the current time when they actually signed up. But when we're inserting 500 fake users, we don't want them all to have the exact same time that they're joining, because then that throws off our data, right? Having 500 users who joined at the same exact instant. So we'd much rather spread them out so that we could try certain things with the data, play around with it. So we're going to generate dates using this. So then the next logical question is, okay, we know how to generate a single email and a single date. How do we do 500 of them? And more importantly, how the heck do we get them in a MySQL database? So warning, up here, red letters, this is not really code that will work. Well, it's not code that will work at all. But I just wanted to show you. We would want to do something like this, right? Insert into users, email, and created at, and the values, we want a faker.internet.email and faker.date.past. This is sort of a hybrid between MySQL and Node. Unfortunately, this doesn't work. But this is what we're going for, right? We want to do something like this. Insert 500 of these where we get a fake email and a fake date. The problem is, insert into users, this syntax only exists in MySQL, and Faker only exists in Node. So how do we bridge that connection? Oh, and we want to do that 500 times, right? The answer is that we use something called MySQL, and it's confusing because it's a Node package Like Faker, it's another package called MySQL. What it does is it connects to MySQL, the actual database, and it talks to it. So every language, there are a couple different packages. PHP has a way of talking to MySQL. Ruby has a couple ways. They are kind of adapters. Think of it as a connector between the two, a tube or a pipeline. And there's a couple for Node, but the one we're using is the most popular. It's called MySQL, which personally I find kind of confusing. I wish it was called, MySQL Node or MySQL Connector or MySQL JS or something. And here's a couple diagrams of basically how it works. So we have Node on its own. This is where we've been working. And then we have MySQL on its own, our separate database. So this has our data stored in it. And the MySQL package will be able to say things like, hey, MySQL database, how many users are in there? Ask it to the database, and then the MySQL database will be able to say, well, looks like there are currently 518 users. Send that back to Node, and we can use it. Or it might be something like this. Hey there, MySQL database, how many users are in there? And MySQL might say, users, I have no idea what you're talking about. I don't have a users table in here. In which case, we would get that back to Node.js, and we'd be able to know that because of the package we're using, the MySQL package, is both asking the questions, right? It's querying the database, and it's handling the replies. So then in here, we can write logic that says, okay, if we don't get a response, if there's an error message, let's do one thing. Otherwise, do something else. Or a third scenario. Hey there, MySQL. Our adapter, our MySQL connector, might ask how many users are in your database. And there's no database. We don't get a response. Well, we need to figure out how to handle that in Node. And fortunately, the MySQL package handles that. So it will, start by freaking out. Are you there? What's going on? A bunch of sad faces. But then it will figure it out. It will basically time out, and it will figure out there's no connection. There's no database there. And it will be able to handle that as well, which is something that could happen. Your database server could go down. Something could go wrong. So these are different scenarios. Mainly we're working with this one, right, where there's good communication and everything's working how it should. But the key thing is that the package, MySQL package, works in Node, talks to a database. So without further ado, let's see how that works. All right, so we're back here now. And our goal for this video, I'll just lay it out there, is to have communication established between a MySQL database and this file of JavaScript of Node. It's not going to be crazy. We're just going to be basically running a very simple query like this. Select, we could do cur date, or we could do something even sillier like select 1 plus 4. But those are SQL queries that we could run in a MySQL database and get an answer. So we're going to run them from this file. And to do that, we need to first establish a connection. And even before that, we have a bigger thing to take care of, which is that we don't have MySQL set up in this Cloud9 instance. So if I'm back in the Cloud9 docs, you can see, remember when we ran this very, very early on, MySQL-CTL space start. And what it does is it starts MySQL in the current workspace that you're in. And if you read this note, it says the nice thing is that every workspace will run a separate database, so your projects will never interfere with each other. And that's really nice and useful. But what that means is none of our data from our previous workspace is available here. So all we need to do is just run this command. So we'll do that now. Here I am in Cloud9. I'm just going to run it. And all that we should see is that it installs MySQL. Everything's good. But something to take note of right now, the root user. So we need to remember this. And you'll see why in just a moment. So I'll just put a note down there. Don't make fun of my username, please. I regret it deeply. But it's here to stay. Learn with Colt. Yours will be something different, but we need that credential. Okay. So then the next thing, we now have a MySQL database. I'm going to open up a new terminal over here and just keep it open. And we're going to connect to the CLI. Remember how we do that? It's MySQL-CTL space CLI. Okay. And if we look at databases, we have nothing really. We have these kind of basic ones that we get from Cloud9. Let's create a new database. And we'll just call it join us. Already forgetting the semicolons. Okay, and then we'll use join us, just like that. So we have a database. And just to show you, if we run a command like this, select cur date, we get an answer. Or if we do select 1 plus 4 and I add a semicolon, we get an answer. So this is in MySQL. Hopefully that's no surprise that that works. Now the question is, how do we get this file, which is not SQL at all, it's JavaScript, how do I get it to talk to the MySQL server that's running and run some code in it? And there's a couple components to that answer. The first thing we have to do is install the package. So just like before, it's npm install, but instead of faker, we type MySQL. It's the name of the package. We hit enter, and once it finishes, if you open up Node modules, there's a new MySQL folder. So this is the code that connects. So on its own, it's not doing any connecting right now. It's a library, it's a tool set that we can utilize, but we have it on our machine now. We have it in Cloud9. So I'm going to come up here and require it just like I did for faker. I'll type MySQL equals require MySQL, if I can type. That on its own doesn't do anything. Well, that's a lie, but it doesn't actually talk to our database in any way. There's a bit more we need to do, and it looks like this. So what we do is establish a connection with the database. So we require this first. We require MySQL, we save it to a variable. Then we run mysql.createConnection, which is a method that it comes with, and we have to tell it a host, which we'll go over later. We're leaving it as localhost. Then user, which is going to be whatever your username was. Mine was Learn with Colt. And then a database name. So we just made a new database. I think it was called Join Us. That's the one we want to work with. So if we copy this over, I'm going to get rid of our generate address for now. I need to fill this in. So some username for me is this right here, Learn with Colt. That is what MySQL is expecting. It says, please make note of these credentials. We want to keep track of that. Okay, so we put that in there. And then the database that we want to use was the one we just created, which was called join_us. Just like that. So if we try this right now, we try running this file, node app.js, nothing happens. And that's actually a good sign. That means that there wasn't a problem, but at the same time, we're not running any SQL code. The point was, by the end of this video, we want to do something like this. So then the next thing to do that looks like this. And there's a lot to take in here. I totally understand that. We're going to start by just copying this over, or you can type it as well. But this is how we run queries. Okay, so there's a lot. First thing I'll show you is we have a query. I'll just do select, let's do cur date. That's more accessible. So we write our SQL code in here, okay? So we could do whatever SQL we want. We don't have any tables yet in there, so we're not going to work with tables, but we could do something like this, like cur date. Then we just save that to a variable called q. Now this is the trickier part. So we've got connection this is our connection we created. So we're referencing it, connection.query. We're telling it to run the query queue. So I could have just taken this and put it directly here. It just makes it a little longer of a line to look at, but I'll do that to consolidate it and to show you that it works. Then we have this whole function, error, results, fields, kind of a mess here. There's a lot to look at. What this is saying is when this query is finished, so we're going to reach out to our database over here. We're going to try running select cur date. And if we just run it here, you can see it works. So if we try running it from this connection, whatever happens, when it's done, run all of this code here. It's called a callback. And again, I wish I could go into more detail, but basically this will run. And if there is an error, there will be something stored in error here. If we get results, it will be stored in results. And we'll talk about fields later. We're not going to use that now. So I have this if statement that just says if something happened, if there's an error, then just stop, throw error right there. Otherwise, and we can even get rid of all of this and just print out even more. Let's just get rid of everything and just print results so you can see what we get back, just like that. So there's still a lot going on, I realize. Unfortunately, it doesn't get simpler, but hopefully you can see the core idea. We have our query, and everything else here is just kind of the JavaScript wrapper around it to run this query. Connect to a database, run the query. So let's see what happens. Okay, so two things to notice. One, we get this row data packet thing back. We have cur date, colon, and then the answer for what cur date was, which is great. But then we also have this other thing, I don't know if you picked up on, my cursor has changed. I'm not in the regular terminal. I have to hit Control C to get out of there. And that's because a connection was opened, but it actually was never closed, it never ended. So it's not a problem, but basically that connection is persisting. So at the end, we can do a connection dot, it's either close or end. Let's try it again. There we go. And it ends now. And you can see we're done. Okay. So now let's talk about our results. First of all, we should pat ourselves on the back for getting this far. We now are running simple queries, yes, but we're running queries here in this node file. This sets the groundwork for everything else we need to do. So imagine that instead of a single select cur date, what if this was insert 500 users and we're passing that in and we're running it from node talking to our database, which hopefully you think is cool. Let's try changing this to something like select 1 plus 5. Saving it. And you can see we're now getting row data packet 1 plus 5 colon is 6. So this, what we're getting back, this syntax is kind of wonky. I totally get that. The way we can get around it, if we just want the answer, we can start by adding in 0, which is basically, if you're familiar with an array, it's going to give us the first item. So if we try this again, now we're working with this row data packet in particular. And to make this easier to access, I can just go in here and add an as. So if I do as answer, for example, select 1 plus 5 as answer, I mean, if we run it over here, this is what we get, right? Well, this is not JavaScript. So the whole job of this MySQL library is to, or the package, is to figure out how to take this and turn it into something we can use. So if I do as answer, now I try it again, you'll see that it's stored now under the keyword answer. So I can access it just like that. Perfect. So last thing that I'll show you, let's do select, and I'm going to do this one in a separate line, or as a separate variable. I'll call it var q. And instead of just selecting 1 plus 6 or 1 plus 5, let's do select cur time as time, comma, cur date as date, then finally now as now. And I do need that right there too. Okay, so if we do that, and I put q here, I'm basically just saving myself from having to make a gigantic line. So by referencing q, it's referencing this query, which is very useful. It's going to run it. And rather than doing all of this, let's just look at results like that. See what we get. Okay, now if you look at our results, we can do results 0, which will just get us basically the same thing, but we don't have this array around it anymore. More importantly, we now have 3 items coming back, which should make sense, right? If we went and took this over to MySQL, don't forget the semicolon this time, we get 3 results: time, date, and now. So then the question is, okay, let's print them out all separately. So we'll have 3 prints, but we need to access them individually. So we'll do time first, and then date dot now. So by putting in this alias, the as, when it comes back from MySQL, so imagine that diagram, we're sending it over, we're saying, hey, please send me, let's say cur time as time, and it does that. Okay, here's curtime as time. I'm sending it back to you, JavaScript. This JavaScript library takes it, sticks it in the results under the name time, only because we gave it that alias. So whatever I change this to, I would need to access it under that name. Anyways, now if we do it, there we go. I'm getting the 3 different things that we asked for. Okay, so that's the extent that we're going to work with it here. Next up, we're going to create our table, and we're going to see how we start inserting and selecting data from this file. So rather than just selecting curtime, we're going to actually do something with the database, something that we couldn't do without MySQL. Okay, so in the last video, we got our node file, JavaScript, communicating with our MySQL database. Albeit very, very simple communication. We're not actually interacting with tables, but this is SQL code that we're running. So the next step, of course, is getting it to interact with tables. So we're going to, in this video, we're going to create our table. We're going to define our schema, create our table in MySQL separate from JavaScript, and then we're going to try and query it from here. So basically, we're going to go into MySQL, create our table, let's add 2 or 3 users, and then we're going to see if we can fetch them from Node. But before we get there, one thing I want to address very briefly is when we're looking at this code, this connection.query, function error, results, fields, or this code up here, var connection equals blah, 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 you might be wondering, how did you know what code to type? Where did I find this? It's not in the MySQL documentation. This is not an official MySQL sanctioned library. Basically, the way that it works is that random developers, teams of developers, solo developers, go and create these libraries that connect MySQL to other languages. Some of them are more supported than others. Like I said, some of them are just one person, but they usually have their own documentation. So the documentation for this is on GitHub. It's github.com/mysqljs/mysql. There goes my fridge again. Oh, very active today. But if we scroll down, you can see, well, there's a lot of stuff to take a look at, but it basically talks about installing it, talks about setting up your connection. It talks then, if you keep going down, about once you've established a connection, what can you do? Well, here's a very simple query. We saw something very similar, although this is just selecting one. We did something a little more complicated, but if we keep going, eventually you'll see we get to things about querying, which is where we're going just in a little bit. But basically, I want to show you there is a source of documentation. So here we talk about some queries, how it works. We'll come back to this in a bit, but I'm not just pulling this stuff from nowhere. And I certainly don't have it memorized. I'm not just, I don't just know how it works. I'd say the approach is more, okay, I know what I need to build. I'm going to be building it with Ruby. Now let me find the Ruby MySQL driver, or a gem, which is what they're called instead of packages in Ruby. Let me find a MySQL gem. Is there a connector? And then you find it. And then you look through the documentation and you figure out how it works. Okay, how do I connect first? That's the first thing you need to do. And there's not one syntax. It varies from language to language. Somebody made a decision. So if we go back to our slides here, somebody made the decision to call this method query, which, it makes sense to call it query, but it could have also have been called make query or perform query. Or when we're creating the connection, mysql.create connection, I don't know, someone could have called this could be database name instead of database, but somebody's making those calls. And I'm not disagreeing with the way this is named in any way, but I'm saying you have to play by the rules of whoever defined this. Just like when we're working with MySQL, we have to use the MySQL syntax. There's a specific syntax we have to learn. Same thing for using these libraries. So it's not something that comes standard with JavaScript or with Node. It's something we had to plug in ourselves. And that means we need to go do the work to figure out how to use it. Okay, so next up, we're going to create our schema. And it's pretty simple. All that we need are 2 fields. So we'll run create table users. We'll do email, and a pretty standard length is 255. So not that an email is that long, but for fields in general, text fields, people will do varchar 255. And we'll make it a primary key. Why do we want to do that? Basically, we don't want someone to be able to sign up twice with the same email address. Also, it gives us a couple more options for exercises, so it's a good thing to do, and it's good practice. This is probably the first time we've seen primary key without auto increment. Then we've also got created at, and that's going to be a timestamp. It could be a date time, but remember back to that video I did about the difference. Timestamp is smaller, it takes up less space in memory, and it works just as well, except for really far away dates in the past and in the future. 1970 up until 2038, I think it is the current range. We're not going to worry about that because we're dealing with current dates. We're creating a mailing list app or a wait list app. People are signing up now. So we don't have, nobody's entering a date from 1650 or something. Then we're setting the default value to be now, so that when someone signs up, it will automatically be filled in as the current time. But don't forget, when we're working with Faker, we are going to insert like 500 users into this table, and we are going to provide a created at time so that we don't get 500 users with the exact same time. So we want this default value to be there, but we'll also be able to override it manually if we want to. Okay, so let's hop over to Cloud9. And the first thing I'm going to do, close this down, is just make a new file. I'm just going to call it schema.sql. And the only reason I'm doing that is just to have a record of this. You could just open up MySQL and start typing create table. But I'm going to do it in here, create table, users. Okay, so we wanted email, and then we wanted created at. And email is varchar 255 primary key, and created at is timestamp. Would work just fine if you left it as a date time. And we want default to be now, or we could also say current timestamp. Okay, just like that. And we'll save. We'll hop down to our terminal down here. I'm in the MySQL CLI, and I'm just going to select database right now and see what we're working with. Good, we're in the join us database. So we made a new empty database. If we look at show tables, there's nothing here. That's good. So we're going to create this. You can either copy it and paste it in, or you can run the file, which I'll do just because it's been a while. Source schema.sql. Okay, now let's see if it worked. Show tables this time. Now we have a users table, and we can describe it. Perfect. So that's all in there, which is great. Now what we want to do is insert, let's say just 2 users, just so that we have something. So we'll do an insert into users. This will be one of the last times we're actually inserting stuff manually, rather than using our code to do it for us and inserting 500 at a time. So all we're going to do is insert email, and we'll leave off created at for now. We'll just have it be the default. So that means we'll have, what do we want to do? Let's do Katie34 at yahoo.com. And then we'll add in another one, which will be, let's do Tunde at gmail.com. Sure, just like that. So just 2 users. I'm not going to source this again unless I commented this out. Otherwise, it would try and create users again. Just copy this. Do we have any syntax issues? We'll see. Okay, it looks good. We can do a quick select star from users. There we go. Okay, so we have data in here. That's all we need to start. Now our goal is to come over to this file, and rather than doing these silly select cur time and cur date now, we're going to try and select from the users table. We want to make sure that not only are we connecting to the database, which we've already established, but we want to see if we are able to connect with that table and query it. And the syntax is actually the same. So I have a slide on it, but if you notice, we're just doing connection.query, and then we just have a query here that we can replace with whatever we want. So our query is what? How do we select everything from users? Well, we just did it. Select star from users. So we'll save that. And, again, you could just copy it and paste that right there. I'm going to get rid of all of this because we're not working with time, date, and now anymore. All I'm going to do is say, if there's an error, throw the error. And then we'll do console.log results, just like that. So I'm going to get rid of everything else here, just these. So This is just setup. We're not even using Faker. Can get rid of that. All that I'm doing, connecting to the database. Then I have a queue, which is just storing our simple select star from users. Then I'm doing connection.query. So take this connection we set up, run this query, which the first argument is select star from users. The second argument is everything. Basically, it's a function that will be called when our query finishes. So when it either comes back saying, great, it worked, or it comes back saying, hey, your database isn't running, or I can't find that table, whatever it is. If there's an error, throw the error. If there is no error, this is empty. There will be nothing there. And console.log results. So we need to go over to the correct terminal and run it. Make sure we save. I have a circle up there. So save nodeapp.js. Okay, take a look at that. We've got 2 results. Each one is a row data packet with an email and a created at. Email and created at. So that's looking good. We are getting our data back. And if we wanted to only take a look at Tunde and his information, we can drill down and just access results 1. They're indexed at 0. It's an array, JavaScript. So this is the 0th result, and this is the first. Save, run it again. You can see we now are only dealing with Tunde. And if we only wanted to print out, let's say, his email, we can just do .email. And there we go, tunde@gmail.com. Okay, so that's the first and most basic thing that we can do as far as selecting. So now when we're talking about this join us application that we're making, we're never actually selecting all the user information. We're going to have 500 or 1,000 users, ideally more. We're not selecting all of them. What we're trying to display to the user is just how many there are. We're trying to display how many users there are. And that is just a matter of counting. Now, we could do it a really kind of bad way. I was almost going to curse there. A really bad way, which would be basically select all the users and then just run results.length, which will tell us how many results there are, which gives us 2. So that's a really bad way of doing it, because if we have 10,000 items in our database, we're going to go select all of them, bring all of them back here just so that we can do .length on it. I don't think that's a good way of doing it. So rather than doing that, what we can do instead is just do count. Select count star from users, just like we've done before. Now if we do it, you can see we get count is 2. And a nice, remember, we can add in an as, so we'll call it as, let's call it total this time. And it needs to go here after the field before the from. And now if we run it again, you can see it's stored under total. And if we wanted to get that, it's just a matter of results 0.total. And now we get 2. So this is a much better way, because we're asking MySQL to count and just give us the count back. We don't actually need every row. So instead of 10,000 results back, just give us this count, and then we can work with that. So this is what we'll be doing. We will have a query like this when a user goes to the home page of our application. Bear with me while I scroll back. Should probably just edit this.
Speed it up. Okay.
But when a user goes to this page, this number is the results of our node, or Node.js, running that connection.query select count star from users. And whatever number comes back, we are sticking in the markup in the HTML. Okay, so then that brings us to inserting data. What if I wanted to instead insert a new user? So I'm going to copy this. Well, first I'm going to comment that out so we have a record of it. And I'll make a note. Selecting data. Okay. Now we're going to try inserting data. And you would think that all we needed to do is something like insert into users, specify, let's say, email, values, and then all we want is, we'll do 1 here. And we have to pay attention to quotes because we're working inside of a string. So we need to use double quotes here. And let's say we just make up an email. We'll call it Wyatt the dog at gmail.com. It's one of my family dogs. So if we do that and we insert that, so if we kept everything else the same, let's just console.log results, just like that. And if there's an error, throw the error. So this is regular SQL, right? If we ran this, and we could verify it, of course. If we ran this right now, it works. So now let's change this a little bit so that we don't end up with 2 of them. But everything else is valid. So let's do that. Run it, connection.query, this query, function blah, 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 blah. If there's an error, let us know. Otherwise, print the results. Let's see what happens. Okay, so look at what we get back. First of all, it says OK packet. We get field count 0, affected rows is 1. There's no message. Everything looks okay. If we went over here and did a select star from users, you'd see that Rusty the dog is now in here. So all of that is looking good. And that's correct. This is working how it should work, which is good. But this is not something that really is helpful to us. Inserting one item at a time that we're hard coding in, where I'm saying Rusty the dog, that's just not great. Like, this is SQL we're writing. We could, if we wanted to insert Rusty the dog exactly, we could just copy it and do what we did and paste it here. What we want is to be able to do dynamic data. So I want to be able to say, which we don't have Faker set up, but I want to be able to say faker.internet.email, which is going to give me a random email address. And I can't just stick that in here. That's not going to work because it's going to just try and insert an email address called faker.internet.email. So there's another syntax we use. In truth, you'll probably never use this for inserting, where you're actually hard coding in the data you're trying to insert. What you'll actually do looks something like this. So we have a slightly different syntax. First thing you'll notice is that I'm creating a variable that is storing the person or the user we're inserting. And it's a JavaScript object where I have a key, email, and then a value, jenny467@gmail.com. We'll come back to that. Then our connection.query looks the same, but our query is different. We're doing insert into users and then this weird set question mark thing. We've never seen that. Is that valid SQL? Is this something else? And then also we have a new argument. We're passing person in as well. And then our regular function with error and result. So what I'm going to do is copy this over. I'm going to comment this one out as well. And I'll call this inserting data take 2 and paste this. Okay, so a couple things to go over. 1, does it work? We'll try that in just a moment. And 2, how does it work? So we've got this insert into users. That's the same, right? That's what we had up here, insert into users. But then we had to specify exactly what we're inserting. So we'd say, email, and if we had 10 columns, we'd have to say email, comma, X, comma, Y, comma, whatever they are, right? As we're used to. But there's another way. What we can do instead is make a separate entity in JavaScript, an object, where I could come in here and do something like email is Jenny. We don't have name, but we could have, if we had it in our database, we could have name is Jenny. We could have 20 different things. And to insert it all correctly, all I have to do is connection.query, insert into users, and I add set question mark, and then the second argument is this object. And what will happen is this MySQL fancy library, this package, will basically take this object and it will figure out, okay, there's something called email. Well, then I'm going to turn this query into insert into users email values Jenny467@gmail.com. We have a quote issue again, so I'll make those double quotes. Okay, so it will turn it into this. But if I had something like email and, let me indent this a little bit better. Let's say we had email, comma, and let's say birthday is 2001, comma, 11, comma, or /11. We'd actually need dashes for MySQL. But let's say we have that. Well, by just passing it in here, I never have to mention birthday. It will know when inserting it to then have birthday equal to this. So I won't go and type the whole thing, but the point is that it can dynamically do that for us. And that doesn't seem that helpful when we're inserting one thing like this. It's the same problem or it wasn't a problem, but the same thing we ran up into here. Like if you're just inserting this one hard-coded email, why does it matter? And the answer is down here. Well, it matters because now we don't have to hard code it. What we can do is change this string because we're no longer part of up here. Whatever we're typing is inside this text. But down here, it's not. It's separate. So we can replace this with something dynamic, like using Faker. But let's start by just making sure that Jenny works, just like that. Jenny467@gmail.com. Let's save. And let's see what happens now. Insert into user set person is this. Okay. And it looks like we got an error this time. And it tells us, oh, okay, well, this is a silly one. This is my fault with the code, but it's something it's good to talk about. If you look at what the error is, it's telling me error is not defined. So it's saying this thing error is not defined. And actually, I was ignoring these, but I'm sure Cloud9 is trying to tell me. Yes, it is. It says error is not defined. And that's because up here I called it ERR. You can call it whatever you want. So I could call this mistake in all caps. It's a bad idea. It would be a mistake to use all caps, but as long as they match. So I'll go with ERR though. That's a standard thing, just like that. Okay, now we get a different error. This time, oh my goodness, it's the same one. Jeez. Now we get a different error. This time it's saying duplicate entry. Great, this is good to know. Now it's telling us we already have someone named Jenny467@gmail.com. And the reason we're getting this error is that we already have a Jenny in there. So this is interesting, and this is why I added that primary key. So we just like 1 second ago inserted Jenny467@gmail, and we hit this problem with the error coming back where we had a syntax error, but it was still inserted. Remember, this code only runs when the insert or the query is done. So we inserted Jenny467, then I screwed up our code, and so it broke right here. But Jenny was already added. So now we just added another Jenny, or we tried to, and this time it came back saying there's a problem. And if we look at the error that it threw, it says duplicate entry for key primary. So you can see now how JavaScript is talking. This is the kind of, remember those arrows, I won't go back to the slides, the two-way arrows, where we tentatively tried to insert from Node, hey, can we insert Jenny467? Waited until it went to the database. The database said, let me think. No, sorry, we already have Jenny467 and there's a primary key constraint. Don't you remember? You made the schema. Well, that's a problem. I'm going to have to refuse your request and send you back an error, which then is passed into this. And this part runs. If error, throw the error. Okay, cool. So that's good to know it's working. So rather than doing Jenny467, let's change this to something more interesting anyways. Let's go back to using Faker. So we need to require Faker again. Require Faker. And all we'll do is insert someone with a new email. So it's just faker.internet.email. Like that. So what this will do is instead of having us hard coded it, every time we run this file, it will insert a new email that it just generates. So let's try it, see what happens. Okay, it looks good. Something happened. Now you can see we got velma94@gmail.com. And let's do, how would we only identify the last one that was most recently added? Quick review. Well, we could do an order by created at. If we did it that way, you can see the last one is Velma. We're going in the wrong order, so we can do descending. And we could throw in limit 1. Now we get the most recent one. So if we go back to Bash, try running it again and again, we've got Sanford Gaylord 61. And actually, if I change limit to 2, because we just inserted 2, we also have Travis60@gmail.com. Sweet. So I'll end the video here, but we saw now how we can insert things dynamically and why this syntax is preferable to this one up here, where we're hard coding it as a string, as text. This works, but it's limited, right? We can only insert whatever we type. This allows us to be dynamic. And shortly, in our web application, we won't have faker.internet.email. We'll have, this is pseudocode, whatever the user entered into the form. So when we have that form, the user enters their email, whatever they type in there, we're going to stick here. And we don't know it, right? We can't type it out exactly. We don't know what the email is itself, but we can save it in a variable. Okay, so we'll go back to faker.internet.email and we'll leave it there for now. Okay, so let's refresh what our master plan was here. The whole point of using Faker was eventually we want to be able to insert 500 of these where we have an email that's randomized, and we also want to have a date, a created at date that is randomized. So let's focus on that part. We saw, just to refresh your memory, that we can do things like this. I'm going to comment all of this out and to just run one line at the bottom, which is console.log faker.date.past. And that just gives us date in the past. I think it's within a year and maybe two. And let's see what I'm screwing up here. We've got faker.date.past, console.log, and we'll go over to the correct terminal here and we'll run node app.js. Okay, now we're getting a date. Now you may have noticed a problem here. This date syntax, which I'll put here just so we can take a look, it's not valid JavaScript as it is, it's complaining, but this is not going to jive well with our database. Remember that our database, MySQL, is expecting something like this, where we have the year, I'll just do it as year, dash, month, dash, day, space, minute, or what do we have? Hour, minute, second. So sort of, the time part looks okay. Then we got all this stuff that we don't want. The year though, the month, the day of the week, we don't want the month spelled out. We just want the day. So this is a problem. So to prove that it's problematic, let's try something. Let's try taking, let's say this date right here, Monday, April 24th, 2017, copy it over, and let's insert it manually into MySQL and see what happens. So I'll do an insert into users. We have email and created at values, and we'll just pick a random email. Let's do dusty@gmail.com, comma, and then we'll pass in this giant JavaScript date, or the JavaScript style date string. What do you think will happen when we insert this? So I'm just going to paste it in and hit enter. All right, one row affected, one warning. Well, let's see what happened. Let's do a select star from users. Well, actually, let's do select star from users where email equals dusty@gmail.com. And look at that. Created at is all screwed up. It's set it to 00000. It's a problem. That's not going to work for us. It's wrong, right? So that's proving to you, the whole point of this is to show you that the JavaScript way of doing dates that we get from Faker is not compatible with MySQL. So let's just see what happens. I guess I can keep this here, but let's see what happens if we go to our app.js and we try and insert a person with a Faker date. What do we get, an error message, or what happens? So we'll do this. I'll make some space here. And rather than just email, we'll also do created at, which is faker.date.past. So the same thing we did down here, which generated this date, but now we're doing it dynamically here with an email and a created at date, both dynamic. We're going to insert person using the same syntax, and let's see what happens. Okay, hold our breath here. Node app.js. And what do you know? We don't get an error. So what's going on? Did it work? Let's come over here. Unfortunately, we're not able to do our select star and order by created at, because our created at dates now vary. So it's no longer that the last one added in has the most recent date. So we'll just do a select star from users. And what we'll look for, in my case, I happen to know the data that we were working with. This was the one that was just added. Lucio 38. Yours, of course, will be different. But notice that the date time, or the created at, isn't 0000. like we had for Dusty. This was the one where we manually took the same exact thing coming from JavaScript, but we did it ourselves and it didn't work. But then when we used person instead of variable, and then we used connection.query and we passed it in, it somehow worked. And basically it comes down to the magic of this library. And I'm showing this to you to illustrate another point, which is there's a lot of work that goes into sewing the stitches between something like Node and MySQL. So if we go to the docs here, if we do a search for, I'll just do date time, and I think it's down. Okay, here we go. If we look, there's something right here that says date objects are converted to year dash month dash day. Basically the syntax we're looking for. They're converted to that. So as part of this library, it takes it upon itself to bridge MySQL and Node. It says, all right, if this is a JavaScript date, which is what we're working with from Faker, well, I know that the user is trying to insert it into a MySQL table that has no idea about JavaScript dates. So we're going to convert it before we send it. And then one other kind of interesting thing we can do is save this to a variable, and we'll call it end result. And if I just do a console.log end result.sql, which again, all new stuff, I know it can be overwhelming. What this will do is show us the compiled SQL that is being sent over. So this is kind of before what person looks like, and this will be an after. Let's take a look. Well, we have to go to Node. Okay, so you can see before we had created at, looked like this. Tuesday, May, it's a wrong format. That's JavaScript format. But sometime before we actually sent this over, it was converted to created at is equal to 2016-05-24, and this is the correct MySQL syntax. So this is kind of cool to be able to see the end result SQL that's being sent over. This is, valid SQL that we could just copy this over. And yeah, it might look slightly different. These are escaped, which you do not have to do. But if you notice, this is SQL syntax, and we could just paste that in. Okay, so I'm going to get rid of that, but I just wanted you to see that you could do that. And more importantly, the whole point here was to show you that there's stuff happening behind the scenes, which can be great and useful, but it's also, there's stuff that you just don't know what's happening sometimes, and you run into it, you discover it. But it's the job of these libraries to connect the two, and there's a discrepancy in this case between how JavaScript handles dates and how MySQL handles or expects them. So behind the scenes, this library that we're not writing, we're not in charge of, somebody is, that library is patching them. It's fixing it for us. Okay. So we've inserted a single user. Now all we have left is to figure out how we insert 500. That's the next video. All right, so we're finally at the end of this section where we're actually going to insert 500 users at once. And you'd think that it'd be easy because we already saw how to insert a single user like this, create a single object, pass in email and created at, and we just pass in that single one. But then we have to worry about, okay, well, if we're trying to do 500, technically what we could do is repeat this entire process 500 times. But there's a better way than that. Because if you think about this, every time we're running a query here, that's 500 separate queries, inserting one at a time individually, which is not ideal. What would be much better is to generate all 500 users at once and then do a bulk insert, insert them all together, like this. Here we inserted 2. Not 500, but this is 2 people being inserted. We're passing in a list. Now this is MySQL though. Now the way we do that in Node using this library is a bit different. So I'm going to show you, I dug through the documentation and found out how to do a bulk insert. Rather than passing in a single object like this, what it's actually expecting is an array of arrays. So something like this here. So I'll show you a better example. We'll actually do it together. But rather than giving it an object, here is an array called data. Inside of it, 3 separate arrays. The first thing is an email. The second thing is created at. Then the query that we're doing is now insert into users, and we actually do have email comma created at, our traditional syntax followed by values. And then this question mark will be replaced with whatever comes after it, which is data. So then we'll take this array here and it will stick it here. And basically it will insert each one of these as its own row. So we'll say this is email, this is created at, insert that. Here's email, created at, insert that. So this is the JavaScript way of bridging that gap. This is how it's done with this library. And this is why it gets wonky and weird when you're working with other libraries and other languages where they don't, the syntax is different. They don't support the exact same way that you would work with MySQL. So it's kind of weird, but once you do it and you have it done, you can just refer back to the code you previously written. So let's test that it works first. Okay, so we had inserting data take 2. I'm going to comment that out and move down to the bottom, inserting lots of data. Just make this a little easier to see the division. Okay. So rather than just, we can leave it as blah at Gmail, I guess, and ugh at Gmail and meh at Gmail. So we have this array of arrays, only 3, but the difference between 3 and 500 is basically nothing. It's the difference between doing 1 and 2 that we're trying to get around right now. We saw how to do 1, so this should be easy once we get 3. So we save this here, and let's just make sure that it works. I'll also add my connection.end. And we'll make sure everything else is commented out except the connection part. And we'll run it from our app over here. Okay, it looks like 3 affected rows. That is good news. That means that they were inserted. If we go over here and do select star, we can see meh is in there and blah. And where are you? Ugh is at the bottom here too. So this worked. This successfully entered or inserted 3. The syntax is weird. I totally agree. It's different. I totally get that, especially if you're new to JavaScript. This must all be overwhelming. Don't worry. We're going to get through it. We're going to make the app. But what I want to show is that, again, it's different. You have to be prepared to kind of play within the rules of whatever language you're working in. Okay, so we've got this, but rather than these 3, what we really want to do is generate an array with 500 entries. And each one is going to have a faker email and a faker date. So to start, I'm actually going to make data empty, just like that. And all we would need to do to add in our first fake array would be data.push. And push will just add to the end of this array. It will add inside of it whatever we tell it to. So we want a new array. I'll make some space here. And all we want to do is push in 2 things. The first is faker.internet.email. And the second thing is faker.date.past. So what this will generate, if we just do a single one, and do a console.log data, and don't do our query here. Comment that out, and we run it. Wrong terminal. If we run it, you can see, all right, it did it. We've got our first result in there. So then logically, if we just repeated this and did another push and another push, when I rerun it, now we end up with 3. So we just need to do that 500 times. And we're not going to copy and paste 500 times. We're going to use a loop, and it's just going to be a simple for loop. So for var I is equal to 0, while I is less than 500, add 1 to I. So we saw one of these earlier. If you're not familiar with JavaScript, these are the bread and butter. It's a way of repeating code. So this basically says repeat whatever's inside of here 500 times. So we just pass that in, and this will now run 500 times. Each time it's going to generate a new email and a new date. It's going to push them into the data array. So we end up with one giant data array. So we can print that out. Let's see what happens. And you can see as I scroll through here, you'll have to trust that it's 500. But we've got tons of results in here, tons and tons of them. Awesome. Okay, so now all we need to do is uncomment this section. I'm going to comment out our console.log, but uncomment the part where we're actually taking that data, which is our giant array full of fake data, and we're inserting it. And nothing needs to change. We have email first, followed by created at, right? If you look at our last one, email, created at. Okay, moment of truth here. Let's try it. Save the file. It looks like 500 affected rows. Look at how fast that was. look at how short our code to do it was. If you ignore all the white space, it's just this part. Now let's head over here. Let's start by selecting star. Awesome. Look at all of them there. And I'm actually going to drop everything because we have some bad users in there that with, time created at set to 0, 0, 0. So we're going to just do delete from users. 518 of them gone. Now we do a select star. Nothing. But don't worry. We're just going to rerun our code one more time. And so easy, so fast. We now have 500 users in there. Awesome. Okay, so we'll end it here. I recommend that you delete everything and just remake it with 500 exactly. We have a couple of exercises using these. Of course, your data will vary, right? You're going to have different emails, different dates, but it won't matter for the exercises. And once we get past those exercises, we'll move on to working with this data in the context of a web application. So we saw a lot in this section. It's very kind of disparate, fast-paced, I'm aware. If you don't know JavaScript, I can imagine it's quite intimidating, but hopefully the takeaway is not that you're a JavaScript genius, that you could recreate this on your own, but more that you see that we're able to use JavaScript to insert or select from a MySQL database, and that we can do things that we could do on our own, like insert a single user, but we can also do really powerful things that we couldn't do on our own or would take forever, like inserting 500 users that are randomly generated with just a couple lines of code. So this is really our first thing that we've seen that takes advantage of the power you get from using a language like JavaScript. Awesome. Alrighty, so we inserted 500 users. It was kind of a behemoth of a section to get there, lots of ground to cover. But now that we're there, we're back in our comfort zone, hopefully, we're going to have a couple of exercises. I know we have a lot of them, but this is cool. We have a lot of data now where it was, a single, you hit the return key once and you got 500 users, much easier than having to copy and paste like 20 books. So we're going to play around with them. And again, your data is randomized just like mine. So your tables and your results will look different, but the queries will work the same. So here's the first thing. Find the earliest date that a user joined. And all we need to see is the date. And also notice how I formatted it. Pay attention to that. So just the earliest date. And then the next problem, find the email of the earliest user. Now this one's tricky. Remember how we talked about this with min and max way back a couple, 5-6 hours ago, about how when you use min and max, you just get the min, you don't get the row itself. So we had to use a subquery. So the hint is use a subquery to find the email that corresponds to the earliest user. Then take all the users, and I want to see a table where we have a month name and then the number of users who joined in that month. So it doesn't matter what year. We have some 2016, some 2017 most likely. So we're not grouping by that, just by the month. So you have to figure out how you extract the month name from the date and then go from there. Also notice the order. Then count the number of emails or the number of users with Yahoo emails. And the way that you can determine that is just if their email ends with @yahoo.com. So how do you do that? Count them all. And then finally, calculate the total number of users for each email host. And this one's a little bit complicated because you're basically going to be doing 4 different checks. You're going to say, all right, does the email end with Gmail? Does it end with Yahoo? Does it end with Hotmail? And then you need to calculate how many each end with these. So it's a little bit complicated. That's why I left it for last. Hopefully you're able to get it. If not, solutions coming up in the next video. Just remember, your data is going to look different. Don't panic if your numbers are different. All right, I'll see you with the solution. Okay, here we go. So let's first start off by just making a new file to work in. So we have some clean, we'll just call it exercises.sql, just so we have a nice place to put the answers. Okay, so our first one here, find the earliest date a user joined. And we're not selecting anything except the earliest date. So all we need to do is take advantage of created at and use the min operator, the min function. So it's just a matter of select min created at from users. And we'll save that. copy it, paste it, and the one that I get here looks like this. So 2016-501. Notice it says earliest date, so that's the easier part to fix. And then notice the format. So let's do as earliest date first. That will make it cleaner. Then we need to format the date. So I'm going to put this on a new line. And the way that we format, remember, is we use date underscore format. Think back to our date section. So we're formatting the result of the minimum created at, which is this. And we have a second argument, which is the date string, how we want to format it. And the one I gave you had the month name, which I believe is capital M, and then the day with the suffix, which is, I believe, capital D, and the year, four numbers, capital Y. So you need %, capital D, %, capital M, nope, backwards, capital M, %, capital D, %, capital Y. Let's see. Oh, I have to copy this, paste it in. And there we go, May 1st, 2016. Okay, look, we're only a day off from the first data set that I added. When I made these exercises, I had a different set of data, and you just watched me rerun it, delete it all, create 500 new ones. So these will be slightly different than my answers too. Next, find the email of that user. So the same one that we just found, this was the earliest date. How do we find the email? So let me label this challenge 1. In this one, we have to use a subquery, because basically what we're trying to do is, well, first we can clean this up a bit. We don't need to format this one. But basically what we're trying to do is take this earliest date, which looks like this. And then we want to do a select, we'll do an email from users where created at is equal to that date. How do we find that user? So let's just do it manually. It looks like our answer is colebailey@yahoo.com. So we can use a subquery to help us, where all we have to do, we can get rid of this and say select email, comma, created at, or we could just say select star to make it shorter, from users where created at equals, and then we have to do our subquery, select min created at from users. So those parentheses indicate that this is a query that needs to happen. So this is evaluated. What is min created at? Well, I need my parentheses to work there. There we go. What is the min created at? Well, it's going to be this. So then basically this whole thing is replaced by that. And then we're finding users, star from users, where created at is equal to that. So let's try it. There we go. Looks good. We've got email and created at. Of course, it looks different, but this is the correct answer, Cole Bailey. And we saw that because earlier we just manually selected it based off of that date, and it worked. Perfect. Moving on. So we're taking every user, taking their created at date, and then we're extracting the month name from that date, whatever the month is, combining them all, we're grouping them and counting how many exist. So how many users signed up in November. In our case, November was the highest. And then we're sorting as well. So let's start by just extracting the month name. So if we were to take a date like, where is that? This one right here. How do we get the month name from that? Because if we just do select month of that, it gives us a number. So what we can do instead is month name, and that gives us May. So we'll start with that. We'll do select month name of created at from users. And we get 500 different month names. Well, there's only 12 different ones, but 500 rows. So then what we want to do is a simple group by, and let's just give it a name like as month and group by month instead, rather than retyping that whole thing. Okay, so now we have 12, assuming that we have a date in every month of the year, which we probably do if we have 500, but we don't see how many there are. So then we need our second field. And our second field is count. We just do count star, just like that. And here we go, almost there. All that we need to do, I believe I gave this an alias of count. And then we also want to order by count, and we want it to be descending. Let's see if it works. There we go. November had the highest count as well with 52. Although it diverges, January was first, or was second, in my case, May, and then April. All right, so we use this month name, and we group them based off of that month. You could also just replace it with this, but it's easier just to type month, and then we're grouping them, counting them, and ordering them. Let me just put a note that this is challenge 3. Moving on, challenge 4, count the number of users with Yahoo emails. So for this one, it's a bit of a throwback. All we need to do is use like to figure out, which emails have Yahoo in them. So we'll do a challenge 4. Let's do a select star from users, where we just need to say we're created at like, and we don't just want to say Yahoo. Remember, that's only going to find, and what am I saying, created at? Where email like Yahoo. We don't want to do that because that's only where email is exactly Yahoo. So we need these, the placeholders, but we could improve this a bit because this would match anything that had Yahoo in the string anywhere. And we could have someone's email be, yahootim@gmail.com. Or maybe someone's last name is Yahoo or something, Yahoo's. So we don't want that. So all we want to change is we'll do @yahoo.com. And this will guarantee that the string ends in @yahoo.com. So now let's take a look. Here we go. These are all yahoo.com emails. And then all we wanted to do was count how many. So rather than selecting star, we'll do select count star as Yahoo users, I think is what we called it, from users, where email is like Yahoo. And this time there's 170. And finally, challenge number 5, calculate the total number of users for each email host. So this one involves using like along with a case statement. It's a little bit complicated. So we're doing the same thing where we're counting the number of users, but we're doing it dependent on the provider. So we're going to have a case statement. So we'll just start right off with select. We'll do case, and I like to do my end as, and I think we called it provider. Yep. So we'll start with that, and we'll do from users. And what is our case? Well, we can start with this Yahoo one. We'll say when email is like Yahoo, then provider is Yahoo, right? So we'll do the same thing, just basically copy this and say when email is like @gmail.com, when it ends in Gmail, then Gmail. One thing I should note, there is a kind of nicer way of doing this if you are familiar with regular expressions, but that's out of the scope of this course. But if you do know it, you could get by with that. So we've also got Hotmail, then Hotmail. There we go. Okay. Then finally we'll have our else, which will just be other. So we have this provider field now, a column that will have Gmail, Yahoo, and Hotmail, or other. So let's do email comma case so that we can see the email side by side against what we pulled out of it. So we got 500. Let's take this one. Ray.more1@gmail. We get Gmail. Ruben Medhurst at Yahoo. We get Yahoo. Perfect. So now it's just a matter of grouping them together and counting. So we can get rid of email. We don't need to display it. Then we're just going to group by provider, which is what we just created. So let's start with that. Cool. So we're grouping them together. Looks like we don't have any others in this case. We're We're going to group them, and then finally, we're going to count. After our case statement ends, we add a comma, count, star. Copy, paste. And there's just a small discrepancy, which is this is called total users. Also, this is sorted. Very easy to change. We'll call it as total users. I like to capitalize that actually. And then finally, well, let's just make sure that that works to start. Great. And now we need to sort it. Order by total users. And if we do it this way, you'll see that it's ascending. We want to do descending. All right. Now we've got all the providers on the left and their total number of users. Perfect. All right. So hopefully you enjoyed that chance of working with more data that isn't hard coded in. Some of it's dynamic, all of it's dynamic, 500 plus users. Next up in the next section, we're finally going to connect the database we just created, we just filled with all that seed data, and we're going to connect it with a web application and figure out how to get those to talk. All right, we made it. This is the section that a lot of you probably have been waiting for. It's where we connect MySQL not to just a random node file, but to a web application, which is really just a random node file that has some other code in it we haven't seen yet. But that's what we'll see in this section. So we're going to build a very simple app that serves as sort of a mailing list for a startup / cult, C-U-L-T, not C-O-L-T, a cult. It's very hard to say. But that's what we're going to build, a mailing list application that, we could collect emails before we launch a product or something, or collect emails before the world ends or whatever we're worrying about. So we're going to see how to do that in this section. It's going to be mainly a code along. So it's going to function really, I'm going to show you something, then you'll do it yourself, and I'll show you something else and you'll do it. There's not going to be, a ton of new content as far as MySQL is concerned, really none. It's really all the auxiliary stuff that goes into a web app. So if you don't know anything about web development, I should preface this by saying there's going to be a lot of stuff here. And this is one section, right? This could be a whole course on web development. In fact, some people have built courses on web development. This is not a course on web dev. So it's an hour or so of content, not 40 hours of content. So don't get overwhelmed. Just follow along and build it. If you are someone who knows web development, some of this may seem a little bit slow for you. For example, when I'm talking about HTML and CSS, feel free to skip whenever you want, but in particular, those sections. So that's pretty much all I have to say here. Congratulations on making it to this point. Very exciting, hopefully. We're going to see how to make an app. Blue's very jazzed about it, aren't you, Blue? Blue. That's about the most excited she ever gets. I miss dogs. Hey, welcome back. Very high energy because we're moving on to a very exciting portion of the course. We've now seen how to take a database in MySQL, everything we know, and combine it with a node file, a single file that doesn't do, it depends on your impression of it. It doesn't do a whole lot, it just inserts, but it inserts 500 things, which is pretty cool, and they're all randomly generated. But that's not an application. That's still useful for our application. We'll be able to use that. Just to recap, the whole reason we're doing that is so that when we start up our application, we have some data in there. We have something to work with. Rather than totally empty database or something that has 2 users, we have 500 realistic, randomly generated emails and created at dates. Okay, so we've done that. We have that. Now we're moving on to the web application portion. So remember, this is Join Us, our mailing app or waitlist app, where there's a nice page with, it looks styled, it's nice. It says Join Us in big letters. It says how many users have currently joined. And there's also a guarantee 100%. It's not a cult. And then there's a form at the bottom where you can actually enter your email to join the list. So we have to get there. We're going to start with the basics of a web app. So just like we had to start with the basics of Node, we're now starting with the basics of building web applications. Okay, that brings us to something called Express. So if you've taken my other course, or if you're familiar with Node and you've used it in any web development capacity, you've probably come across the framework Express. It's a web development framework. It helps us make applications faster. So if you're not familiar with frameworks, in 10 seconds, what they are tools, libraries, that are a bit more complex, a bit more controlling of how you write your code. They dictate things for you. You play by their rules, but they help you make things faster. So a web development framework helps you make websites faster. There are iOS or game development frameworks that help you make games faster. So they kind of limit your freedom a bit, but they empower you because they speed you up and they let you focus on the things that matter. So with all that said, Express is very simple, a lightweight framework. What it allows us to do is once we install it and include it in a file, we can very quickly make a web application. So something like Faker is a package that allows us to quickly get random data, a very small kind of feature it's useful, but it's a small thing. Express is a package that when you use it and install it, it does a lot. It sets up a server for you. It listens for incoming requests. It figures out how to respond to requests. It handles HTML and CSS and responding with that. It figures out how to parse a response body. All these things we'll go into, but it does a lot. So let's take a look very quickly at the documentation, expressjs.com, a fast, unopinionated, minimalist web framework for Node.js. As you can see, you can just install it. npm install express. We'll talk about -- save in just a second. And you can read more about it here. Basically, it provides a robust set of features for web applications. It's lightweight. So what that means, if I go over here to Node.js frameworks, it's a site that I found, it has a list of some of the most popular Node frameworks. There are a ton of them out there because people love using frameworks for good reason. They help you make things faster. There's two categories that this person has categorized them into, Sinatra-like and Rails-like. Basically, this comes from Ruby. These are two Ruby frameworks, Sinatra and Rails. Rails, you might have heard of. It's a bigger framework, very popular in Ruby, but it controls everything. It's very strict. Sinatra is much lighter weight, meaning that you have more freedom to make decisions. It's less opinionated, which means that you can configure things how you want, but also the advantage of something like Rails is that you don't have to make decisions. For example, how to structure your files. Where do I put my CSS files? In Rails, you don't have a choice. In Sinatra, you have to decide. So with that said, there are all these frameworks for Node. Express is the top one here that we're going to use, but there are other ones. There's Sails and Getty are two that I've used. Koa, I don't know if it's pronounced Koa or KOA, is one that's becoming popular now. A lot of people are using too. So anyways, I'm just trying to point out here that there are a bunch of frameworks. Just like when I said we could have used any language to talk to MySQL, we could use any Node framework to make a web app. We're happening to use Express. Okay, so the first thing I recommend here is to look at the documentation for Express. If you're curious, if you haven't taken a course in it, you're not familiar with it, or you have never worked with a web framework, the documentation is pretty straightforward. If you click on Getting Started, you don't have to go through all of it. But if we actually go, let's do like a hello world. Here's a simple app that we'll be making in just a moment. But it has a nice kind of walkthrough of using Express, how you write certain things, what the syntax is, and then there's a guide that's much more in depth, and then there's a reference. When you click on API reference, make sure you're doing 4.x, the most recent, and this is sort of like think of the MySQL docs. There's all these methods that we see over here, and you can read about them over here. So we'll be referring back to these docs as we go through the course, and for now, that's where we'll leave off. All I wanted to do in this video was introduce Express, tell you that it's a Node framework, show you the website, the documentation. Then in the next video, we're going to install it and create our own first application, first web app. Okay, so we saw Express, or I introduced it. Now let's get down to work, let's install it, and let's make our first simple web app. And I don't want to get your hopes up too much. This web app is going to be very, very bare bones. Basically, will be a website. You hit enter, or you go to the URL, and we just get a single message back saying whatever we want, congrats or hello or something. So nice and simple. But the difference between doing that and then responding with, I don't know, a big, beautiful website with images and big text and animations isn't that much as far as the code we have to write on the back end, which is what we're focusing on now. It's the same idea. You respond with some content. What you respond with, well, that's a different story. Okay, so don't run this. It's a big red letter say, but to install Express, like we've installed Faker, or we installed the MySQL package, you just run npm install and then the name of the package. However, rather than doing this, this will work fine. It will install. I'm going to show you another way of using NPM that's a little bit nicer, a better practice. And it involves running this first command. What does this do? npm init creates what's known as a package.json file. So if that doesn't make any sense to you, don't worry. Basically, when we make a new project, let's say we're working on a big node project with like a web app, and our web app might have 20 packages involved. So we're only working with a couple right now, but it could have 20 involved. Rather than just installing them individually and leaving no record of what's been installed and what version's been installed, what we can do is create a package.json file. And it acts as like a log file of everything we install. So that if I send my code to someone else across the world, or I post it on GitHub, for example, all that the person has to do to run it is take that package.json and then run a single command, npm install, which will then go find the package.json and install every necessary package. So let me show you an example. This is actually the GitHub repo for Express.js, the framework we're about to install, which is itself, it's a node package, and there's a package.json file in it. And if you look, there's this giant dependencies section. These are all different packages that Express needs. So when we install Express, it goes and installs all of these things as well. So we don't have to do it, right? If this package.json wasn't here, we would have to manually install array flatten and content disposition and cookie. Thankfully, we don't even have to worry about what these do, let alone the fact that they exist. So that's the point of a package.json. It's a way of storing not only the packages that are necessary, but then the version. Because this version of Express might be totally broken if we used 0.6, if that exists, or escape HTML 0.0.3 instead of 1.0.3. So that's all we'll say about it for now. But to actually create the package.json, what I'm going to do is first make a brand new folder, just so that we're working in a different folder, and I'm going to just call this one Join Us. And that's where we'll be building the application. So everything else we've done up until now hasn't actually been building the app. So what I'll do is now cd into Join Us with the terminal down here, and it should be empty. If I type ls, we're now in this directory, there's nothing there. So we're going to run this npm init command, and this will just generate a new package.json. However, it's interactive, so it's going to ask us for a name. And what you can do is just hit enter if you want it to just accept what its the default value is. But if I hit enter now, I'll get a message saying, sorry, name can no longer contain capital letters. So let's do join us underscore. Version, we'll say it's 1.0 of our app, that's fine. Description, we can leave it blank for now. Entry point, I like to change to app.js. This is just the name of the file that we're writing our app in, or the main file of our app. We could have 20 files, but what's the start point? Index is fine too, but I'm going to do app. Then I'm just going to hit enter until we're done. You could put author in there as well. And a license. Then you can see the basic text it generates for us, the JSON, which is the data format. And I'll hit enter. Now I have a package.json file up here, and it's ready for us to install things. So now what I'm going to do is run npm install express, but not on its own. I'm going to add -- save, and that will save a record of our install into our package.json. So right now it's not here, but if I do npm install express -- save like that, takes a moment, you'll see, first of all, we have our node modules now inside of join us. So we installed it in this directory, which is good. Then in our package.json, we now have express saying 4.15.2 is our version. And while we're here, why not also just reinstall npm install two other packages we need for our app. The first one is Faker, and then the second one is MySQL. You can just separate them by spaces and add -- save, and then we'll just add both of them in here too. Not a deal breaker. We already have installed them on this machine, but it's nice to have them in this directory too, and also have records of them in our package.json. So now if I wanted to upload this to GitHub or something and share this with someone, I wouldn't have to, send them the node modules folder and send them the actual Express directory and Faker and MySQL. I could ignore that because This is the largest part of our directory structure right now. This, I don't know how many megabytes it is, but it's a lot more than this single file or our single app.js file. So it's better to just have our friends or other developers download what they need remotely. So I just send them this recipe that says, oh, by the way, you need these 3 things. Here's my code plus the package.json. Then they go take package.json and they install these things. And the way that you do that, by the way, is running npm install, and you don't add anything afterwards. It will try and install everything in the nearest package.json. All right, so we have Express installed. We don't have an app yet, not even an app.js file, but we have the structure that we need to create the app. Woo, okay, very enthusiastic now. We're actually getting to the web app and writing code in this section, in this video. We installed Express now, we're ready to go, but we need to discuss what we're going to make with our first, most basic pass at a web app. So here's a nice little, hopefully you think it's nice, a little diagram I made of a typical request and response cycle that we'll be working with in Express. So here's a computer. Let's say it's Blue's, my cat's. And then there's our Express app that we'll be creating, which is Node, JavaScript. And Blue types in the name of our app. Let's just say it's www.app.com. She hits enter. A request is sent to our Express app saying, hey, I would like the slash page. And slash right here is referring to the URL that we're asking for, the path after. So if you notice, I'm on webdev.slides.com. This is basically like our entire Express app, what we'll be creating. And then individual pages we ask for by varying what comes after the slash. So if you take a look, if you never noticed that before, the path that comes after a slash on a web page, that is usually what dictates what content you see. So when we don't ask for anything, if I just go to webdev.slides.com, that's going to be the home page. And the way that we would kind of write that is the path is slash, just / nothing. Okay, so hi there, I'd like the home page, please. And then the Express app has to figure out what to do. Says, sure, here you go. And sends back our super simple hello from our web app. That's it. It just is a 1 line of text that says hello from our web app, no colors, no animations, nothing like that. And there's no logic involved to start. Every time Blue goes to this page, she gets hello from our web app. Now, what we're working towards is creating dynamic pages that will vary, that will say, hey, we have 518 users, or here's a list of all of our users in the database, or something like that, that varies depending on when the user asked for it, who the user is. There's a whole bunch of different conditions. So that's the flow we're trying to get. We send a request asking for a particular thing, and our Express app has to figure out, 1, how to handle that. How does our Express app know what we're asking for? Second of all, how does it respond? So it's these 2 arrows that are really the important part, the request and the response. So let's get started. Here's what the code looks like. So there's a little bit here that we haven't seen any of this. We've seen requiring, so all we're doing is importing Express and saving it into an Express variable. Then we're doing this weird thing that we haven't seen, where we're actually executing the entire Express package that we just imported. And we're saving that to another variable called app. Basically, these are the first 2 steps of any Express application. Copy and paste them every time. I mean, they're not very long, so you could just type it, but you can treat them as just cookie cutter every time. Then, every time we refer to this app, like we have here, app.get and app.listen, both of those are referring to this app. So anytime we work with Express, it's going to be a lot of app.something, app.get, app. All these other things, which on the documentation, you can see over here, we have all these app.delete, app.enable, app.get, app.listen, app.param, all these different things. They all start with app. Of course, if we name this variable something different, Apple, then this would be apple.get and apple.listen. So far, this doesn't do anything. These are just 2 lines to require stuff. The magic is really here and here. The first thing is what's known as a route. This is the bread and butter of Express, pretty much every web framework. What it does is this code inside is only triggered whenever an incoming request is made to this path. So we're basically defining the code that runs when a user asks for a home page, where the path is nothing. It's just slash. And what are we going to do? Well, we are going to send, this is a special method from Express, hello from our web app. And res is coming from here. There's a lot to take in, I know. Res is the response object. Request is the incoming request. So every route, there is a callback. Just like when we were working with MySQL, a callback is code that runs after something happens or at a later date. So this code only runs whenever a request is hit to slash. So eventually we'll have code where we have 5 or 6 routes, different web pages. We want to run different code depending on the web page that's being asked for. So this is how we do it. This is basically saying if a request comes in for slash, run this code. We could have another one down here that says if a request comes in for slash log out or slash log in, then do something else. Show the login page. So that's the first bit. Then every route has a function, a callback, with 2 arguments, a request and a response. Request, again, is the incoming request. So if we wanted information from the incoming request from the user, which we'll be working with later, when a user types their email into the form to sign on to our waitlist, that information is sent to us. And so we'll need to work with the request coming from the user. It's this arrow. That will contain the information. Hello, I'd like to add my email, blue@gmail.com, to your database. And so then with the request, we'd be able to pull it out of there. The response is what we're sending back. It's this arrow going that way. And so that's why res.send, hello from our web app, will send this response. Of course, you don't have to name it rec and res. You could call this request and response. You could call it R1 and R2, apple and orange. All that matters is that you refer to it the same. And then we have this second component. And this is also kind of cookie cutter. You'll have this in every app, app.listen. And all that this does is starts a server. So this starts the server going. We have to tell it what port, which on Cloud9 will always be using 8080. And then if we want, we can give it a callback function. And this is just a line of code that will run once we start our server. So it will just say in our terminal, hey, your app's listening on port 8080. You don't have to have this. So let's go over to Cloud9. And the first thing I'm going to do is make a new file. So inside of join us, new file, and it's going to be app.js. And I'm going to just start by requiring Express, just like we saw. Then I'm going to do var app equals express, which is referring to this, executed as a function. So we have app there. Let's just see if it works. Nothing will happen. We may get an error if we didn't install Express, but we did, so everything's good. Then let's start actually at the bottom with our app.listen. And we tell it the port, which is, if you're not familiar with the idea of ports, think of it as the entry or exit point on a computer. You can have 20, 50, 100 different ports for different things going on at the same time. You may have had to work with ports if you ever had to like mess with a firewall that was blocking something you didn't want it to block, or if you work at an office where they don't allow you to go to certain websites. That's running on a certain port. Anyways, app.listen 8080, and we could just leave it at that like this. But if we do that and I start it up, notice my cursor has gone to the same thing that happened with the MySQL connection when we didn't end the connection. It's just hanging. And that's because I started the server. It's listening on port 8080 to see any incoming requests, but we're not doing anything. And it's also just not very, it's not a great experience to just see a blank cursor there. So we can just add this blank callback, and it will just console.log server running on 8080. And it's just a nice message for us developers to see. So now if I do it, you can see, of course, that we get console.log server running on 8080. And that's just because this code runs, whatever we put in here will run only once the server starts. So that's the first thing. But now we have the task of actually writing the code. So we have our server, it's going, but we can't actually reach it. We can't do anything with it. I don't have anything to respond with. So actually what I just said is kind of a lie. We can reach it. We could request it, but nothing would ever come back. And actually if I try and preview it right now, so to do that, we can click on preview running application. This is hitting this server, but we're not getting any response. So I'm going to just leave it here for now. We'll come back to that. We'll know that our app is working if we get a response here. To do that, we just have to do our app.get and then the URL or the path, which is slash function request response. And then in here, we put some code. So we could start with just a console.log. Someone requested us, just like that. What do you think will happen? First thing I have to do is restart the server. Anytime you change this code in here, the server was already running. We need to save the file and restart. But now, if I try and request slash, so I'll just hit enter here. Notice what happens. It says someone requested us because this code ran. But over here, we still don't see anything. So console.log is only printing to the console here, the terminal. So now what I'm going to do is open a new tab and put this in that tab so that we have our app and then our terminal down here. And I'm going to close this one just to make more space. It's the same thing. Notice though, every time I hit enter, I get someone requested us. But if I tried to go to slash log out or something that doesn't exist, I don't get someone requested us because this code is only happening, it's only firing off when we're requesting slash. And you might be wondering about the get part. If you're not familiar with HTTP requests, there's a couple of different types, different verbs. Get and post are what we'll be working with. A get request, though, think of it as just asking to see information. You're not sending any data with it. So when we are asking for our homepage of join us, we're just trying to see information. It's a get request. But when we are trying to join, we are sending an email, and that is going to be a post request. We'll get there in a little bit. I know it's a lot of stuff and overwhelming if you've never done web development, so hopefully you understand this is not a web dev course, but there are some great ones out there. And I highly recommend if you're curious and you are enjoying this part that you continue down that path. Okay, enough of that. So rather than just console.log, there's this other thing we can do, which is response.send. And then we can put any string in here, like you've reached the home page. I'm sorry about that siren. It's like 100 degrees in San Francisco today. Oh, that's a lie. It's 90 degrees. I have to have the window open. Okay. Hopefully it's not too loud. Now we need to restart the server. This time, we now have some different code. Same thing. If we hit slash on this app that is running on 8080, which in Cloud9, this is our URL. Yours will be different. You have a unique URL you need to access, but this is where your app will be running. Just like when we first installed Node and I showed you that chat app, it's the same idea. This is where your app runs by default. So now all we need to do is hit that page, but we need to ask for slash rather than slash logout. If I do slash logout again, I get nothing. But if I just do slash or nothing, we get our message. You've reached the home page. And that is our most basic web app. Of course, you could change this text. Something that people ask a lot is, can you have two res.sends? The answer is no. You can only have one. Every route is going to respond with one thing. But the real answer is that you're usually not going to use res.send. You'll instead be responding with files. So we'll have a file of HTML to respond with our nice formatted page with style and fonts and colors. For now, this is the very basics. So we'll stop here. You can feel free to move on to the next video where we add more routes. But at the very end, I'll take some time to review if anyone is curious or anyone feels like you need more review of how this works. So we started by requiring Express, which is the library or the framework we installed. Then we execute it and save it to our app variable. And really, there's a lot of magic happening there. That's what a framework does. It takes care of stuff in the background. But now what we've done is, first things first, we started up our server, app.listen 8080. And every time we do that, our server starts running. And basically, that is this block right here, represented by this block. And it's just sitting here listening. It's a patient server. Nobody might talk to it for years or maybe ever. But as soon as someone sends a request, and in our case, the request goes to this URL, Node and MySQL, learnwithcolt.c9users.io. Yours will be different, but this is where I make a request to, and that corresponds to our server we started down here. So there's an invisible connection here that's kind of taken care of for us by Cloud9 or by any computer. Although your URL would be different if you weren't using Cloud9, of course. But whatever we're running here, our server, it's waiting and listening for a request coming in. Then we write code that differentiates between something like log out, or let's do log in. We don't have any code expecting login. So that's why we get an error. It says cannot get login. It's basically our server saying, I don't know what you're talking about. All that our app knows about is slash. That's the only thing it will respond with. Oh, I know that. Let me give you that. It's you've reached the home page. Otherwise, we get cannot get whatever we do. But we do have this one case where it works, the home page. And again, the typical terminology for this is the root route, the home, the root, the empty route, basically slash. So app.get slash, this code runs, and all this code does is it responds with you've reached the home page. One thing that's interesting to take a look at, there's a lot here, but if I do a console.log request, this will contain all the information from the incoming request, from this arrow. There's going to be a lot of stuff in there. So if we take a look, try it again, and I make a request, I'll refresh it by clicking. Over here, we got printed out this giant thing. This is all the information contained in that request. So all of this is put together by Express. It's handled for us. Let's see if there's anything interesting to take a look at. Basically, I can't find anything terribly interesting or that would be very useful without me having to explain a ton of other stuff. But this contains all the information. You only get one or two things usually that you care about in here. This is all behind the scenes stuff that it works with. With that said, when we make our request that is sending our email, when we type it into a form and hit submit, that email will be contained in a request somewhere, and we'll need to pull it out, which we'll get there at some point. All right, next up, we're continuing on with this, but we're going to add a couple other routes. Okay, welcome back. So in the last section, we saw the syntax to add a single route to an Express app. Our app has one URL that you can request to get a response. Everything else, we get that error message that says cannot get, and then whatever you tried to get, whatever you tried to request. So we'll try fixing that now. We're going to add some more routes. So the first one we'll do is going to be silly. It's a joke route. When you go to /joke, it just gives you a joke. Rather than just doing hello or hi or goodbye, we're doing a joke. So when we request from a computer or from a phone even to our URL, and then we have our Express app that we're requesting, this time our request is, hey, I would like the /joke page. So that's like this. Rather than just hitting enter here, we would go to /joke. And yeah, you're usually not, typing these URLs manually, you're clicking on links. So maybe there would be a link that takes us to /joke. Just as there are links down here, this is an error page for Cloud9, but there are links. Each one takes us to, this one is c9.io/support. If you can see that in the bottom left, very tiny. Here, you can see /support. So there's code that is listening, that's taking this /support, and it's figuring out, oh, we need to show the support page, the need help, all these buttons on support. Anyways, so we're going to ask for /joke. Our Express app is going to say, sure thing, here you go, and send back a really stupid joke. What do you call a dog that does magic tricks? A labracadabrador. I had to pick something that is politically neutral. It's not going to offend anybody. So we're just going with labracadabrador. So to implement that, it's very similar to what we've done. We just basically duplicate the code we have, except we change the route, the string of what we're trying to match. So basically in our app.js file, we'll have two questions, which are pseudocode. The first one is, did the client request /? That's what we already have. If they did, respond with welcome to the homepage. Then we'll also have, did the client request /joke? And if they did, respond with knock knock. So only one of these is going to run every request, because you can't send a request that is simultaneously to / and /joke. So we get one response depending on what we request. So without further ado, this is all we have to do. I apologize, it's kind of long because the joke is long. Otherwise, the code is pretty short. app.get/joke function, request response, and then in here, we just have a joke variable equal to our dumb joke, and then we're doing a res.send joke. So if we compare that over here to our existing route, it's very, very similar. So we'll get used to typing app.get. Yeah, that was just terrible, but you do it a lot. App.get, and then we'll do joke. And that's just something I picked arbitrarily, right, to have a joke route. When we're actually working with our app, we'll talk about the routes we need for join us. But for now, we're working with /joke. Request and response. Once again, we can call these whatever we want, but rec and res is pretty standard. Then in here, I'm just going to copy the joke. I don't want to make you watch me type that. All right, so we have that. And what we can do is the same thing we did earlier, console.log requested the joke route. Quick quiz. What will happen when I run node app.js? Well, when I just run it, nothing will happen unless we had an error. But what will happen when I make a request to /joke? And the easiest way to do that is if I do preview running application. And if I change this to /joke here, or I could go over here and do it in a separate window. But if I do /joke and I hit enter, what do you think will happen? It just keeps spinning and spinning. We get requested the joke route, which is what we wanted. We console.logged. That means this route is being hit, and we're running this code. But now over here, it's still spinning and spinning. And eventually, it will stop, and it will give us an error message saying cannot get /joke. Basically, that's saying, I tried. We waited and waited and waited, but there was no response from this server. So the server received it, we did something, but we never sent anything back because we're missing res.send. So very simple remedy. We can have this console.log if we want it, but it served its purpose. Now let's do a res.send, and all we want to send is the joke. Okay, so I'm going to stop this one. Well, actually, I'll just restart the server, and that will kill it immediately. Now I'll do node app.js again, make this bigger. If I can get it, go to /joke, and I hit enter. And now I get this hilarious joke we've never heard before. What do you call a dog that does magic tricks? A labracadabrador. It's pretty good. Pretty good, whoever came up with that one. And that's it. We have our two routes now. So we could toggle between them. Whoa, eBay. I don't know where that came from. Here we go. So I've got the home route, / the root route, or /joke. And that's it. So really the point here is just to show you can have two routes, and usually applications have a ton of routes, 10, 20, depending on how complex the application is. Something like Cloud9 or Udemy might have 50 or 100 different things. Well, 100's extreme, but there's a lot of different routes. To wrap up, let's add one last route. This one is a little different. What it will do is return a random number, randomly generated. So it's not going to be hard-coded in like you've reached the home page, or what do you call it? A dog that does magic tricks, a labracadabrador, haha, very funny joke. Rather than that, it's going to be dynamically generated. But everything else is the same. So it's app.get / and we're doing random num or number, either one. I did num in the notes, comma, function, request, and response again. So whatever's in here will only be executed whenever someone requests /random num. So we'll do our res.send. And let's just start by just hard coding a number like 7. I'll do it as a string just to be safe. If we restart the server now, go over here, joke still works, home still works, but now we have random _num, and I get the number 7. So now all that's left is to generate a random number. And the way we do it in JavaScript is kind of obnoxious. It's much easier in other languages. So there is a math.random. And what this will do, I'll actually just show you right now. If I copy it over, I'm going to stop the server. I'm going to open just regular Node, which is not something I've shown you, but Node has, just like MySQL has a CLI where we can type things and get a response immediately. You can do 1 + 1 and get 2. Node has the same thing. If you just type node without a file name, then it opens up a node shell. So if I do math.random and I don't capitalize that R, now I do math.random, notice that it gives me a random number between 0 and 1. It's really annoying that it does it this way, in my opinion. So if we want, let's say, something between 1 and 10, there's a couple of steps involved. We need to generate our math.random. We need to multiply it by 10, so we'll start with that. Okay, so now we're getting 1.7, 7.4, 8.6. Then what we need to do is get rid of that decimal. So you can either round. What's more standard is to do a math.floor. So what that will do is just chop off the decimals. So we end up with 8, 9, 8, 2. But then we have a problem, which is we never actually hit 10. We're doing a number between 0 and 9, which you'll just have to trust me, that's how it works. But you can see we have 0 here. And it's because when we did our original math.random, this is a number between 0 and 1, not including 1. So up to 0.99999. So all we want to do is then shift it by 1. So it's kind of a lot of work to generate a random number between 1 and 10. But now we've got it. Just to prove, okay, there's a 10, we're in the clear. So now we'll just make that a variable. We'll just call it x maybe, equals, well, maybe num is a better name, make it a little clearer. And then we'll just send it back. We'll say and I think I said lucky number is plus num. And that will just concatenate it in there. Let's try it. So to get out of node, we just do Control-C twice. Now we actually execute our app.js. Now if I go to random num, it says my lucky number is 3. Now it's 10, now it's 8, 8 again, 4. You get the picture. And of course we still have our home route and our refreshingly adorable and hilarious Labracadabrador joke. Okay, we're done here. Moving on in our next video to actually integrating MySQL with this web app. Big step. Okay, welcome to this big step. What we're doing next is integrating MySQL into a web app. So we saw again how to integrate MySQL with Node in a single file that has nothing to do with the internet or web applications or servers or routes, where we just inserted 500 users at once. Now what we're going to do is take our web app that we've created, super simple, unstyled, but something like this. When we go to the home page here, right now it says you've reached the home page. What we're going to try and do is take it to this. We have 519 users, and that 519 is not hard coded in. That's coming from our MySQL database with the 500 something that we inserted. So this will change depending on how many users are in our database, and we'll see that that works. So to do that, we're basically, I have another diagram that took ages to put together. I apologize if it's the colors aren't perfect or there's not nice typography. I wish I was better at that stuff. But here's our trusty red rectangle that represents a client computer. Here's our Express app, this mint green. This time we're requesting the home page / the root route. We ask the server for it by going to this URL, hitting enter. The server says, oh, hang on. It says here that I need to ask MySQL for a user count. Okay, so MySQL is now involved. This arrow represents the connection between Express and MySQL. We've already seen how to do that, how to connect MySQL to a JavaScript file. We ask, basically with a select statement, select count from users. We get a response from MySQL. Hopefully there's not an error. We get a response 519. Then our Express app can take that and say, okay, we're all set now. Here is your final result. Here's the page we get. We have 519 users. All right, so there's a couple steps involved that we need to do. Basically, it boils down to, we've already seen how to make a simple route, and in the last section, we saw how to connect MySQL to a file. Now, we just need to combine them together. So the first thing that we'll do is go over to Cloud9, and we need to connect our app, this file, to our MySQL database. And what we can do is just go to our previous app.js and just copy this code, var connection equals mysql.createConnection. So I won't make you watch me type this whole thing again. But remember, this is using the MySQL package, and we already installed that earlier we ran npm install --save MySQL. If you didn't do that yet, go ahead and do it so that you see it here. And that inside of our join us folder, inside of node modules, we have MySQL. We need that. But we're still missing something, which is we need to require it. var MySQL equals require MySQL. So this is all review. We did it earlier when we made our seed data that inserted 500 users. So we've got this, and let's just make sure that that works without problem. So we'll just start node app.js. Everything looks okay. All right, so now we can focus on interacting with the database now that we've connected to it. But just to reiterate, this database name needs to be the name of the database inside of your MySQL server that you created with the users table. So it's the same as what we were doing earlier if you've been following along. If you named it something else, this has to match. So what we're going to do is, instead of you've reached the home page, we want to find count of users in database, and then we want to respond with that count. So we've got a res.send. Eventually, what we're hoping to do is have something like we have plus count plus users in our database, or something stupid like that. That's what we're hoping to do. Of course, right now we don't have this count variable, so that's what we need to aim to get to. So I'll start by commenting that res.send out. So to find the count of our users in our database, we need to do a connection.query, which we've done before. Remember, it's all the stuff we were doing over here. Connection.query, connection.query, connection.query. And what is the query we want to write? Let's do it in a separate variable. So var, I'll just do q again, equals a string select count star from users. Just like that. If we were to just copy it, go over to our MySQL, we get 500. Okay, so that's what we're hoping to get, but of course through JavaScript. So we've got our query written as a string. Now we just pass it in, connection.query. Then we add in that fun callback where we have error, and let's call it results. Okay. So whatever code is in here will only run when two things happen. First, when somebody requests slash. Then we have to wait for this connection to run the query, which is select count from users. So then when that is done, whether it worked or not, this code runs, and there will either be an error, so we can add our if error, throw error, which is not actually a great thing to do in a web application. What would probably be better is to say, if there's an error, what do we want to do? Redirect the user to a different page or send them a different response, which we can see how to do in a little bit. But we're just going to leave it as that to keep it short. And then otherwise, let's do a console.log results and just see what we get. Okay. So again, to go over this, we connected to our database. Then only when somebody requests slash are we trying to select count from users. We could do it inside of joke if we wanted to, or random num, but the way that our app is going to work, the home route, when we go to the home page, we see, welcome or join us, join the 519 users or whatever it is, and then there's a form at the bottom. So we're just going to do it on the home route. Let's see what happens if I try running node app.js. Looks like we have a syntax error, and that is because we're missing parentheses around error there. Okay, now we're good to go. Now if I try and just go to the home route, not joke, well, joke will work just fine, but if I try and go to the home route, what do you think will happen? And the answer is that we're not responding with anything. Assuming we don't get an error, we're not actually responding with any res.send, so we're not going to see anything over here. It just waits and waits and waits until it gives up. So I'll stop it here. But notice we get this row data packet, a single array with one item in it. So we're going to want to do result 0. And then what is nicer is if we give it that as, alias. So we'll say select count as count, just like that. So now if I start the server up again and I refresh the page, this time we get row data packet count is equal to 500. It's inside of an object, so all I need to do is do dot count. So this will print 500 now. So let's save it to a variable, var, and we'll just call it count as well. So now we have a variable with the count in it. So then the last step, and I'm going to get rid of this pane here and just work over here. But now that we have our data coming back from the query, we're going to want to do a res.send. Now, something that trips people up, is when you're working with callbacks like this. It might seem like this code is going to run after this, but in fact, we have no guarantee of that. What we want to do instead is only run it inside of this callback. So this is a very common pattern in JavaScript, and in Node in particular, is that you have these nested callbacks. And it can get out of control sometimes. There's something called callback hell, but this isn't too bad. It's not bad at all. So we have our route, app.get. When this route is hit, run all of this code. Inside of there, we're defining a query. And we're doing that query, and it takes time. It might take half a second, although that would be pretty long, but it might take, a tenth of a second or something. And so what we want to do is wait until it comes back and run this code. If it's an error, throw the error. Otherwise, select or isolate the count from the results. Then we do a res.send. We have space count space users in our database. Let's try it. And there we go. We have 500 users in our database. And to prove to you that it's working, let's go over here. Let's do an insert into users. And we'll just do an email. And we'll do what's something we haven't done. So unoriginal here. Austin at gmail.com. Still struggling with the originality there. So we'll insert that single user. Okay. So there now should be 501, and we can double check. And it works. Note that we didn't have to restart the server or anything. That would kind of defeat the purpose if our data was only refreshed whenever the server restarted, because we're going to have people interacting with this. When we set this app up and we finish it up, it will just be left running, in perpetuity until, we have to fix something, or we launch our startup app. So it will be waiting, just running constantly. So our database will be changing all the time, and it has a connection to that database. It can kind of check in with the database, see how it's working, what's going on, and get the results back and do something with them. So still very simple, but it's a start. So we're connecting with our database. The next thing that we'll need to focus on, which will take us a bit to get there because we have to create the form and talk about HTML and a thing called EJS, but our next goal is to also run the insert query that will insert a new user in. But like I said, to do that, we have to set up the route that will insert, and we have to set up the form to actually do the insert for us. But that's where we're heading. Okay, so now what we're going to focus on is actually getting HTML implemented with our web application. So right now we're responding with these little ugly things of text like this. And before I go too much further, just another note. If you know HTML, great. If you don't know HTML, you'll just sort of have to hang on for the ride here. I'm sure you've heard of it. Well, I guess hopefully I'm not assuming too much, but you've come across HTML. Every web page you look at is built with HTML. Behind the scenes, there is this markup language that is dictating what elements go where. And then there's CSS, which we'll get to later, which makes it look pretty. So what we're going to do is focus on writing HTML so that we can have things like a form and a button, or we can have large text, which is known as an H1. And we actually can do that right now in a really hacky way. So let's say rather than just, let's do it for my joke. What I could do is make this joke italicize part of it. So I'll say, what do you call a dog that does magic tricks? And I'll italicize the answer by putting around it the EM tag, which is how you make things italicized. It stands for emphasis. So if I just put HTML inside of this string, and actually I can make this bold too, so I'll do strong. First thing you should notice, if you've ever written HTML, this is a horrible way to write it. Instead of a single line like this, it's just not a good experience. So we're going to see how to get around that. But I'm more just showing you it's possible to have HTML in there. So if I go to /joke, you can see I'm getting HTML that's being rendered properly. So if we wanted to get like a form on our homepage, which is what we want eventually by the end of this video, we could put all the HTML to make a form inside of this string, but it's going to be significantly longer than this. So we're not going to do that. And there's a bunch of reasons why. The main one is that it's a pain, but it's also hard to change things, and it doesn't really allow us to style it with CSS when we get there. So to jog your memory, this is what we're working towards. This is what our app will look like. We have a big background photo of a beautiful mountain in Argentina. Then we've got join us, big text, different font, different color. Then we've got this other text, enter your email to join 500 or whatever the number of users is. Others on our wait list, we are 100% not a cult. And then we have a form with a single item in it, or a single field, a text field, and then a button that will submit the form. But if we strip away all the pretty styling, all the makeup or paint on top, this is what it looks like. This is, the bare bones of it. So this is what we'll get to by the end of this video. So this will be our home page. We're going to replace the content here, this single string, with this. And to do it, there's a couple steps we have to take. So here is the HTML itself. If you don't want to type it, this is the HTML we need. We've got an H1 that says join us. We got a paragraph. We'll come back to this class. We don't need that actually right now. But then we've got enter your email to join, strong, which is the bold, around 518. Then we've got a form, which we'll also come back to. So I'm just showing you this is all we need to actually make the HTML, or the correct HTML to make that page. Now, how do we actually get this to be sent back? What we want is, in this route, when you go to / basically give the user this. But we can't just make that a single string. So what we do is use something called EJS. And you'll have to bear with me here. There's a couple of steps we have to go over. And if you're new to web development, this will be a bit intimidating, possibly. It's probably a terrible thing for a teacher to say. But just hang in there. Just know that we're going somewhere. And some of the steps along the way may be confusing, but once we get there, it won't be too bad. So EJS is what's known as a templating language, stands for embedded JavaScript. It's an alternative to writing just plain HTML. It allows us to add in variable values and code logic. So this is, where's that slide? If we go back here, this is HTML, but this right here is not always 518. So we couldn't do that in a normal HTML file. We would want to be able to say, okay, this is HTML, but right here in that strong tag, in the bold area, there's a variable. But you can't do a variable in regular HTML. So that's what we're going to use EJS for. It stands for Embedded JavaScript. It's just HTML that allows you to embed JavaScript inside of it. So we'll see how to do that in a moment. But the first thing we have to do, npm install -- save EJS. This is to, you should know by now, hopefully, that this is going to tell our app and our package.json that we want EJS installed, and it should install it and save a record to package.json, which you can see now we have EJS there. That's our first step. Then we're going to do something else. This is configuring our Express application, app.set view engine, EJS. So app.set is a method that allows us to set certain settings in our app. View engine is the most common one to change. There are other templating engines. There's things like Jade, which is a common one, Haml. There's other languages. So basically they are similar analogs to EJS. Okay, so we'll go do it at the top. It's a traditional place to do it. Just like we're setting up, our connection up here, it makes sense to set and to configure application-wide things up top. So we'll do that. And then the next step is, okay, where do we actually start writing these files? And to show you that, I'm actually going to work backwards. So the line that we'll be running in our route that will actually render a file is res.render some string, in our case, home. And the process that will happen behind the scenes that Express doesn't really show you or tell you about is it will automatically look for a directory called views. That's a standardized name. So it's going to look for a directory called views. You can change that if you wanted to, but we're not going to. And inside that directory, it's going to look for a file called home dot whatever the view engine we said, which is EJS in our case. So it's going to look for home dot EJS in that views directory. So what that means is we need to create a views directory, and then we need to create a file. We'll call it home, but you could call it landingpage.ejs or root.ejs. Whatever it is, you just need to remember the name. So let's do that now. We'll do right click, or you could do make directory if you're more comfortable with the terminal. New folder, views. Inside of there, we'll make a single file, which we will call home.ejs. Again, you could call it whatever, as long as it ends in .ejs and you remember what you call it. And we'll start with a single h1. We'll just say this is HTML and save it. Then we go to our app.js, and let's just work with our root route. Rather than sending res.send, we have count. We're no longer working with res.send. We have a res.render home. I'm going to be a broken record, but it's looking for home.ejs because we added this view engine is EJS, and it's looking in views by default. So we need to make sure we have that file. It's going to take the contents of this file and send it all back. Rather than a single line, we can write our code now in a separate file. So let's see if it works. Start our app. Let's try going to the home page. There we go. This is HTML. Our other pages still have, well, this one is HTML, but it's not coming from a separate file. Okay, so then what we can do next is I'll just show you. You could, use res.render home. You can send the same file in all of these instead of res.send. You can reuse files in different routes. It doesn't matter. So here we have the same thing for joke. So if I go to /joke as well, I get the exact same thing. Okay, so these don't care about what they're called. The name of this has nothing to do with the route, although it should if you're just following best practices. Okay, I'll get rid of that. So now let's just copy the HTML that I provided here so that we don't have to type it all ourselves. So in home.ejs, I'm just going to paste this in. We'll go over what some of this is, in particular the form we haven't talked about. But let's just get this in here and see how it works. So we have to save the file. Now we get our form. So we have join us, which is our H1, which is what we started with. Then we have a paragraph. Again, don't worry about the class at all for now. You can actually just get rid of that if you want. Just focus on keeping it simple. Then we've got enter your email to join inside the paragraph. All of this is in the paragraph. There we go. 518 is hard-coded for now. We're about to replace that. We are 100% not a cult. And then we've got this form, which we're just going to ignore for now, except know that there's a text input and a button, which we get. That all looks good. And in fact, we can clear out that form and just leave it like this to start. Okay, so now what we want to do is figure out how we get our data in here. Because right now, this is just plain HTML. There's no use for this EJS stuff that I was talking about. But the whole point is that we want this to be 519, 520, 499, 10,000, whatever the result of this is, whatever count is. But how do I get count, this variable, over here? What we do is after res.render, we can pass a comma and pass a JavaScript object, and I'm allowed to pass data through. So what we want to send is count, but first I have to give it a name. So typically you'll see something like this, count, count. Rather than that, I'll do data is count. I'm going to change it later, but just to show you they're distinct. So what this does now is it says, okay, take count, whatever it is, which last time we counted was 501, send that to this template and give it the name of data. Basically put it in an object under the key of data. So inside of here, if I refer to data, it will be referring to whatever count was. The problem is I can't just say data. If I just do that and refresh, we just get enter your email to join data, others on our wait list. So I need a way of saying, hey, this is not HTML, this is special, this is code. And the way we do it, it's weird if you've never seen it before. It looks like this. So we have brackets, just like we would with HTML, the angle brackets, but then percent equals and then percent on the closing side. And this is basically a signifier that says this is not HTML. Whatever is in here is going to return a value that we want to put in the HTML. So if data is equal to 500, it will be replaced with 500. If it's equal to 12, it will be replaced with 12. Kind of a lot to take in, as I was saying. There's a lot of moving pieces here. Unfortunately, we don't really have time. I guess we could have time, but the course isn't on EJS. It's not on web development. This is just a vehicle to showing you how to make something. Okay, so data will be count, whatever's coming through there. Let's try it. And we've got 501. And of course, we could insert one more user very quickly. Let's do Austin 234. Refresh our page. Now it's 502. So we've accomplished our goal. If you feel comfortable with how it's working, go ahead, stop, move on to the next video. If you have a couple of questions though, I'm going to go through the process again. I'm not going to recreate it, but I'm going to step through what's happening. So we'll start with this app.get / that's activating the route when I go to this URL. We still have our /joke, for instance. But we're talking about the root route. When I hit that route, first thing that happens is this code runs, which the end result is it figures out how many users are in our database. It's running this code in our database. Select count * as count from users. That's coming back, stored in results. Inside of results, we're finding it. The reason it's stored under .count is because of this as. So if I called this counter, then this needs to be .counter. Okay. So then we're storing that in a variable called count. So this has something like 501 in it. Then what we're doing, we can get rid of this line now, is we are rendering the home.ejs file, which is automatically looked for in the views directory, which is right here. We have a bunch of HTML in here, some of which we haven't talked about yet. But then we have this one variable with this very weird syntax that we haven't seen before. This is our way of saying, hey, this is not HTML. This is a special value. We can put JavaScript in here. And just to show you a couple other things, I'll do another H1 and then our funky bracket thing again. And I can actually just do simple math in here. Let's do something like 4 times 98. This will run as JavaScript. Whatever the result is, I'm terrible at mental math, will be printed there. So if we refresh our page, we get 392. And we could also pass in, another piece of data like favorite color. And I'll just say it is purple, which is true. It's my favorite color, highly underrated. Pass that in. Over here, I can refer to favorite color. Why we would do this? Well, that's another question, but I'm just showing you that, oh boy, here we go. Favorite _ color. We have access to whatever we pass in here. So favorite color is the string purple. I will need to restart the server if we are changing our app.js file. Now we get purple. It's coming through. So the only difference is that data right here is not something we're coding in ourselves. We're not hard coding it. It's coming from the database from all this work, running the query and then basically extracting the data out, saving it into the count variable. And the last thing I'll do is change this to be count because data is just it's a bad name for a variable. Everything is data. But the reason I called it data again was just to kind of show you that there's a difference. It can be confusing at first if you see count, which one is which. This is the value we're passing and this is the label for it. This is the key. Okay. So let's just make sure it's still working. Refresh. Enter your email to join 502 others on our waitlist. We are 100% not a cult. Perfect. We're done. Okay, so picking up where we left off, if you remember in the last video where we got the HTML up and running, the EJS file, I said ignore the form for now. We're coming back to that. Well, now is a video where we're going to get that form working. And it involves a couple of new concepts. So hang in there. The MySQL part is the same. We've already seen how to insert If we go back to this early, where is it? Here we go. We've seen how to insert this single file. We inserted this single Rusty the dog. We also saw how to do it with this object syntax. And then we saw how to do a bulk insert with a lot of them, which we don't need to worry about. So we've seen how to do this. Now we need to figure out a couple things. One, how do we get the data from the form? This form here, unstyled, so this form. A user types their email and hits join now. First of all, where do they send that request to? We need to figure that out. And maybe you guessed this, we need to define a route for that. But there's a slight difference in that route, which I'll get to in a second, because there's another problem, which is how does that data from the form get there? Well, what we want to do is use what's known as a post route. So there are different types of requests. I briefly touched on this get and post request. This is not a course on HTTP, so you'll kind of just have to take me at my word here that we need to use a post request because it allows us to send data with the request. The form will automatically take the data from here and send it as a post request to the destination that we tell it to send it to. So let me show you how we do that. We've already seen, we deleted it honestly from the form, so there's no suspense here. We create a form element, and the first thing we can do is add in method. And method we will set to be post. It can be all caps, all lowercase, it doesn't matter. You'll see both. And that is saying that when this form is submitted from this button, the last button, or if a button is the last thing in a form, it will automatically submit the form. So when it's submitted, it's going to be a post request, and we'll send it to a route that doesn't exist yet. So we send that with action equals, and then we could send it slash, but that would just redirect us back here, except that needs to be a get request, so we'll get to that in a moment. But we could do slash register. We'll make up a route that doesn't exist. So right now this form is going to take us to a page that doesn't exist. And if I try it, massive. Oh, this is still much bigger than it is in reality. It's about this size, but that's harder to read, so I'm just increasing the font. So if I enter something in here, blah, I click join now, it tells me cannot post to slash register. Great. So we need to define a post route to slash register. And again, the reason we're doing post is it allows us to send the form data. But what I could also do, if I did a get request, I'll show you what happens. We already have a get route defined, a couple of them. Let's do a get request to slash joke. So what that means is that when this form is submitted, it's going to send the data to slash joke as a get, which we already have. That's what this get comes from, app.get slash joke. So if I restart and try it again, this time if I enter whatever there and I click join now, you'll see it takes me to slash joke. There's also a question mark here, so that's something to consider. What's happening is that our data isn't being sent because we're not giving it a name to be sent under. So what we do is assign our input here a name. And this will be the label for whatever this is right here, which is email. So that's the best thing we could put there, email. So when our data is sent off by the form, it will be referred to as email. And there's only one piece of data that we need. If we had multiple things in our form, we might have email and first name and last name, and they could all have a name. So now if we do it, actually don't need to restart the server to do that. But now if I do blah@gmail.com and I hit join now, notice that my URL, it's hard to read, but it says slash joke. We sent a get request to slash joke, and then it appends email equals blah, %40 is what it's doing for the @gmail.com. So you can see our form data is making it here to a different request, but this is not a post request. And we want it to be a post request for really the main reason is that we don't want our data just to be appended like this in the URL. We could get away with that. The standard way of sending data from a form, if you're adding it into a database, is to do it as a post request. This is known as a query string. There's a lot of terminology here. This doesn't matter. We don't want it to work this way. I'm just telling you that it's not a conventional, it's not a good practice. If you're doing like a search form or something, this makes sense. And you may have noticed search forms and search results will often have query strings after the route. We don't want that. We want to send our data using a post request, and not to slash joke, but to slash register. Now the problem is, how do we create a route that will listen for that? Essentially, what we're trying to do, back to this handy dandy animation, is something like this. hello server, I would like to sign up. Here's my email. Pass the email to the server. And then our Node app, our Express app, is going to take that email and run an insert query with MySQL. MySQL hopefully says, great, it worked. Then we get back either something like this, a thanks for registering page, or we just redirect back to the home. So we'll decide on that. So how do we get the Express app, the right side here in the green, to accept this email or to even know that a request is being made to /register? With this app.post. This is how we define a post route. Just like a get route, except it's app.post, everything else is the same. So let's do that now. App.post /register, which needs to match whatever we put here. So if this was registration or create user, then this needs to be registration or create user. And our same request and response. This will only be triggered when a post request is sent to /register. So just to prove that, let's do a console.log post request sent to /register, just like this. And now if I restart my server, I have to go back here. If I submit this form, I'll make it take up half the window here. Watch down here, and I go here and I type whatever I want in here and I click join now. Notice that we get our post request sent to /register. And if I try and get there another way, like by just going to /register, this is sending a GET request. We haven't actually discussed that, but when you just go click on a link or you enter a URL manually, that is sending a GET request. And that's why it's telling me it cannot get /register. So essentially the only way that we're going to be able to, in practice at least, that we'll be able to get to this route here and trigger this code is through the form. So one more time, put something in here, watch down there. A post request is being sent every time. So what we want to do now is be able to extract the data that's being sent. And for now, you have to trust that it's being sent, that our form data is being sent. We don't have a way of seeing it. And the way that we see it, oh boy, it's a little bit complicated. I'm going to walk you through the steps here. This is the annoying setup we have to do. So we have to install something called Body Parser, and I won't waste much time talking about it. What's happening is that Express is a lightweight framework, which means that it doesn't come with everything that you would possibly want pre-installed. So we have to go and select certain things, and Body Parser is one. What it does is it parses the request body. So remember that when a request is sent, there's all this, it's just a giant block of text, and somewhere in there it says email is equal to whatever we typed in here, but it's in a giant block of text. It's not JavaScript or anything. So Body Parser will intercept that and turn it into JavaScript that we can then use and manipulate. So then what we need to do, and I'm just doing this quickly, it's just copy and pasting, importing Body Parser equals require Body Parser. So we can save that. Make sure our package.json has Body Parser in it. Then finally, we need to tell our app to use it. So I'm also just going to copy that line and put it next to app.set so we have our configuration lines together. We're not going to go into detail on this line, but this is just requiring Body Parser doesn't do anything. We have to tell Express, which is app, right? App is from Express, that we're using Body Parser. And this now allows us to extract information from post requests. And here's the magic line. Request.body.email. So what this will now store in the request body in that post route under email will be the email address coming from the form. So let me show you that. If we go to our post route for register, rather than console.log post request sent to /user, we'll also add plus request.body.email. Email is, how about that? Request.body.email. Okay. So we definitely need to make sure that we have name equals email, and then we should be good to go, assuming our install went okay. Let's start the server again. It looks good. Let's go over here. Just going to refresh this page. Now I'll type c@gmail.com, join now, and what do you know? Post request sent to /register, email is c@gmail.com. So whatever is typed into that form is being stored in request.body as email. So body parser is doing the heavy lifting for us here. We had to do kind of a couple of annoying lines, but let me show you what body looks like. So request.body on its own. So I'm going to comment that line out. We're not console.logging anything. Now, if we go back to the form, refresh, and I type, h@gmail.com, and I click join now, this is what our request body looks like. Email is h@gmail.com. Again, email is coming from here. But if I get rid of body parser, let me show you what life is like without it. And I do the same exact thing, h@gmail.com. Now there is no request.body. It's undefined. I did everything else the same. So just this single line telling our app to use body parser is what allows us to access request.body. So the information is still being sent to Express, but Express is just not doing anything with it. Request.body is what we need along with this body parser line to start using it. So it's kind of confusing, but that's the whole kind of ethos of Express, is that you add the tools you need as you need them. So rather than giving you everything at once, and you might only use 1 out of 20 things, it gives you 1 thing, 2 things, and then you go and grab the other things you need. So if you need post requests, you need a request.body to be filled in with data, then we need body parser. Okay. So then all we really need to do now, if we're isolating request.body.email, that's the email that's being sent. Let's save it to a variable. Now we just need to insert that, make a new user, which we've already seen how to do. And I won't make us type it from scratch, but hint, hint, we're going to be doing connection.query. And we've already seen how to do the query. It's going to be an insert into. If we go back, let's just copy this code here. This is what we've done in the past, where we inserted a single user. Go to app.js. So I have it commented out. I'll uncomment it. There's a couple things we're doing. The first, I made a variable called person with an email and created at, but we don't need that created at anymore because this was for Faker. We actually have a real created at. And then for request.body.email, we can just replace that. Okay, so we can get rid of that variable too. So this is just preparing the data to be inserted. We'll have a person object that has an email, request.body.email. And then all we need to do here, we don't need to store it in a variable, is just connection.query, insert into users, set, we pass in person, and then we have our callback function. So this is review. We've already seen how to insert, so I won't spend a ton of time on it. We can start by just console.logging the result, which will be a lot of stuff, hopefully. Let's see what happens now. We have body parser working again. Okay, good. Now, if I go over here, this time it will insert a real user. So let's do a more serious email address. Well, I guess that doesn't matter. How about Miranda? Let's not do all caps. Miranda54 at hotmail.com. Miranda. There we go. Join now. And look what we get back. Affected rows 1. It's this OK packet, all this other stuff. And if we went into our MySQL, if we wanted to do a select star, well, it's going to take a bit. We'll have to type it ourselves. Select star from users, order by, created at, limit 1. We don't have a users table in all caps, oh boy. We get the wrong user, scared me for a moment. We need to also change the order at, or order by, created at, to be descending. And here we go, Miranda54 at Hotmail. So it worked. Long story short, it worked. And we're pretty much done. The only other thing we have to decide is, okay, our web apps is just kind of hanging here. You can see that. What do we do next? And we could either do something like a res.send, thanks for joining our waitlist, let's say. We can start with that. And if we restart the server, do it again, have someone try and sign up with a new email, let's say Jane Doe at gmail.com. Click join now. Now we get thanks for joining our waitlist. So it's totally up to you how you want to structure this part. What I'm going to do is just have it redirect back to the same page, to the original page here, and we'll be able to see 503 or 504. It's really up to you. This is how you wouldn't use res.send, but you could do a res.render, and you could make a thank you page if you wanted to. But what I'm going to do is show you another line, which is just res.redirect. So res being response up here, res.redirect to /. And that will just take us back to the home page. So effectively what's happening, right, restart one more time, is we're on the home page. 504 is how many we just got from the database. I entered a new one, dave@dave.com. I click join now. It's going to hit this post route /register. We're extracting the email from that form data in the body, and then we're inserting it as a new person or new user in our database. When that finishes, we're redirecting back to /, which starts this whole process over. It's going to then select all the count of all users. Then it's going to, oh, there's my cat. Then it's going to render our home page with that count. So to the user, it will just look like this page refreshes, and this goes from 504 to 505. But behind the scenes, a lot more is happening. And there we go. Okay, so that's awesome. Hopefully you think that's cool. All we have left is to style it. If you would like a little bit more detail on the insert part, and I can go over that a bit more if you'd like and what's happening here, but if you feel like you've got a grasp on it, you want to move on to styling, go ahead. Okay, so just to reiterate, we could have also done it a little bit more manually if we wanted to. We could have written a query like this. If I did var query, and I could have done insert into users email, so this should be more familiar, values, and then I would do parenthesis plus request.body.email plus closing parenthesis like that. And that could be our query. So this would turn into, let's say request.body.email is dave@dave.com. It would turn into dave@dave.com like that. So we could also do this query this way, and then all we would need to do is pass Q right here, if that makes sense. So that's another way of doing it. But this is kind of the standard way of doing it with the MySQL library, or the MySQL package that we've been using. So I'm going to get rid of that. But either way, maybe the syntax is more unfamiliar if you don't know JavaScript, but this is what we already saw as to how to insert a single piece of information, a single row into a table. And it's working. Great. Okay, so we're at the end of this project. All we have left is to style it. And it's kind of funny, I think for a lot of people, this is the most exciting part, even though it has like the least to do with the course, but I get it. It's nice to have it something visual to make it look nice. If you know CSS, skip this. You can just copy the style sheet in, take a look at what I did. This is not going to be, like I've said a couple times, not a course on X. It's not a course on CSS. So what I'm going to do is, rather than spending 2 hours of video going over, styling this one piece at a time and talking about my workflow and why I'm doing certain things, what I've done is just copied over the finished style sheet and our finished markup. But we still have our empty markup, or our basic markup, and we don't have a style sheet. So what I'm going to do is just walk through and kind of copy bit by bit over and explain what chunks do, but not everything. And these two files you can find yourself. They're not in the slides, they're too large, but I've included them along with this video so that you can copy from there, unless you're someone who likes to type things manually, which some students do. Okay, so again, these are two files that are not connected to our app. These are the solution files I'm going to refer back to. But for now, we're stuck with this, our basic HTML, and we don't even have a way of styling it. And for those of you who don't know CSS or know what it is, it's how we add style, color, font, images. Well, not how we add images generally, but it's how we can add a background image to something using CSS. And the way we usually write that is by creating an external style sheet, a CSS file, and writing our styles in there like this. So we need a way to actually connect them And I'm not going to go into too much detail, but so usually what we do looks like this. We'd have a link, rel equals style sheet. This is an HTML tag that includes an external style sheet. So if I do that and I just paste that in here, there's two problems. One, we don't even have an app.css created, but two, Express isn't going to know about it. Hi, Blue. What we can do is start off by creating a new directory. And this is just a conventional name. I'm going to call it public. That's kind of standard for a web app, but you can call it whatever you want. And inside of there, I'm going to create a file called app.css, like that. And then we'll put our code in here. And let's start with something really simple, like turn the whole body, make its color purple. So all our text is purple. Oh, like that. Color purple. Ow, Blue. Hey. My cat just attacked me. Hey, why don't you let me record, okay? Hang on, I'll be back. I gotta handle this. All right, that's been handled. Crazy cats. So back where we were, we've got our app.css, body, color purple. This is not connected to our app. If it were, then our text would be purple, but it's not. So how do we get it connected? Well, there's a problem. Long story short, we need to add this line. So this is another app.use, and this tells Express, if I go into our main file here, app.js, just add it with the other app.use, keep all our configuration, and it's basically saying, take whatever is in the public directory, which is right here, take all the contents, and serve them so they're accessible by our views, or from our JavaScript. So now, if I restart the server, app.css is going to be available to this file. Hopefully. And if we refresh the page, we now have purple text. Okay, so we now have a style sheet connected. And if you had, just as a quick aside, if you had multiple different views here and you wanted them to have the same style sheet, you could use this line in all of them. Or there's actually a better way, which I'm not going to talk about in this course, called partials, where you can basically have code that runs on all of your views. But you could also have a separate style sheet for different views if you wanted to. Just put them all in public. Okay, so that's the first simplest thing. The next thing you'll notice in the finished markup is there's also a Google API or a Google font that I included. So I'm going to put that in here too. This is for a font called Roboto. Pretty common one. If you're not familiar with Google Fonts, really great resource, free fonts that you can use on your own websites, and they look good. So now let's also go back to our finished CSS, and let's copy some of this body stuff over. For example, font family. Let's start with that. So we don't want things to be purple. We can get rid of that. But let's change the font so that we now are using that Roboto font. There you go. Our font has changed. Slowly getting there. Next thing that we'll do, if we go back to our CSS, is we'll take the color and the text shadow and the text align. So I don't need font family again. I'll get rid of that. So line this up. Okay, so this color is like a slightly purpley gray, if I remember. And we've got this slight shadow, which I don't know if you could pick up on the original. We're getting close. Well, that's a lie, but we're getting close to being done with body. Then we've got a couple other things. First off is the background image. And if I just show you this image in its entirety, it's a massive image of beautiful mountain in Argentina, down in Patagonia, that I took on a backpacking trip. It is called Cerro Torre. And yeah, that's my little plug for my photography. Maybe I'll have a photography course one day. So here's this photo that we'll use. We just need the URL. And we're setting the body's background image to that photo. Save and refresh. And it worked, but you can see it kind of just looks like a solid color. But it's using the image. It's just so big that it's taking up the, I don't know, 5 or 6 of these screens or more. So that's actually something that if this is a real app, it would be good to just use a smaller image so we're not loading such a big image. But what we can do is use background size and set that to be cover. And now it will basically take the image and make sure it covers the entire background. So we've got that. It's getting a little closer now. The next thing that we can do, if we scroll down, we'll come back to this flex container. We've got our H1s and our paragraphs. And if you notice, I'm setting the font weight to be 100. I'm actually going to get rid of that in both of them. There's a better thing that I can do, which is just set the font weight to be 100 in the body. And what that will do is just make our font thinner so that we get this thinner text. Okay, so we've done that. And let's see, moving on, let's work on the H1 next. So the H1, this giant, or well, it's not giant yet, but this join us that will be giant in a bit. We've got a couple things that we're doing. We're setting, well, let's just copy it all over. Margin to be 0, font size 500 pixels. Line height is 400 pixels. Okay, so it looks massive right now, and that's because I'm super zoomed in. So it's not as massive now. It still is big, but nowhere near as bad. So we've got join us, and that's big, looking relatively good. What we want to do, of course, is position it downwards, but I'm going to wait to talk about that. So we'll move on to the next thing. We've got our paragraph that we can style, and really all we're doing for the paragraph is changing the font size. So this here gets bigger. Then after that, we're onto the form and the button. So I'll just copy everything from the form to start, and I'm going to comment things on and off as we go. Okay, so look at our form right now. Quite ugly. Let's start by taking a look at, well, line height is simple, but border none. What that will do, I'll make it bigger. If you look at the form down here, as I refresh, I don't know if you could see, but a border went away, the default border. Then what I'm doing is adding in a line at the bottom. And actually what will make this easier is if I just show you the finished app, just a moment, here you go. See how we have that white line running underneath? So that's what I just added in. It's very hard to tell because we still have the rest of the form there. So the next thing, let's make the background transparent. Okay, so it's easier to see even though it's very small on the screen right now. Now there's no white background. Then a couple other things. I made the fonts, get rid of that. Made the font size bigger, made the form or the input itself bigger, and then included a margin, a color, and some padding. Also, I'm using a class here. I could also just call this input, but what's being styled is not the form itself, but if you look here, we have a class equals form. So it's the input right here. Refresh now, and we're getting closer. Let's go back to 100. One thing that you may notice is when I click here, I get this annoying focus effect. We can get rid of that with CSS, which if we go to the bottom, we've got this input type equals text, focus, and what this will do is say when an input with type equal text is focused, when someone clicks on it, there should be no outline. So if we save now and try it, I don't get that weird outline. Also, if you notice, I have the text white here. I don't know why I decided to do that. This is placeholder text is what this is. So as soon as I start typing, it turns white, but the placeholder is dark. To change placeholder text is a bit annoying. I'm not going to even bother spending much time on what this is, but if you notice, there's this fancy, basically it's a CSS3 browser-specific way of doing this where we're targeting the input placeholder text, and I'm setting the color to be slightly see-through. So now if I do it, oh, that's not what I wanted to refresh. Now if I do it, it's slightly transparent, but I start typing. There we go. Okay, moving on along. That takes care of our form for the most part. Now we've got the button. The button is pretty straightforward. Let me format this a little better. I'll just copy it all over and save. Mainly what I'm doing, we can actually get rid of this, is adding in a 3-pixel solid border. Then I'm making the font size bigger. I'm making the color, I'm changing the color, adding some padding, adding a background color, and then so the color here is referring to the text. a border radius to make it rounded, and then making it slightly see-through again. So you can see that change was made. I'm not a designer, so I'm sure there are many better ways, things we could do to just make this look better. I'm not terribly happy with it, but it's good enough for a MySQL course. So that's pretty much it for the button, which then leaves us with basically positioning things and formatting them. How do we get this to be centered vertically, roughly vertically in the page, which is what we did here, or what I did here. And it's not too bad. All that we need to do is change our markup a little bit. So we've got basically two divs that everything is wrapped in. The first one contains everything, and then there's a second one that also wraps around everything. The first one I just called flex container, and the second one gave a class of container. I'll just copy this and paste it over into home.ejs. But it's the same content. We've got our join us, we've got our paragraph, our form, but now we also have these two divs. And on its own, if I refresh, nothing changes. However, if we add in this little bit of CSS here, what this will do is help position things vertically. So we can put this, we can put it wherever we want, but I'll put it towards the top. Now if I save and refresh the page, now we've got everything vertically centered. So this isn't a course on CSS, so it's not a course on things like flexbox or positioning or what these fields do, but this is a nice and easy way to position things. Well, relatively easy. And so we're basically done here. Just to review what we did, the first thing that we did was to allow or to set up our app so that it was serving a public directory, which was this fancy line here. Everything inside the public directory is now available in our views. So what I'm going to do, I'm actually going to close down our CSS and markup so we just focus on what we actually have. So then in our home.ejs, we can link to app.css. We do need that slash, and it's referring to this app.css there. Okay, so then aside from that, we added a font, and then in our app.css, we added a bunch of styles, which we mainly copy and pasted. It's not the point of this course, but things like changing the font, adding a text shadow, changing colors, adding the background image, changing the background image size, how it's positioned or how it's sized, taking up the whole screen, but not, overwhelming it. And then also the font weight, making our font lighter weight. Then we've got our form and our button that we formatted, and then also we position things using these two divs and styling those. One thing that we could do to make this a little bit more kosher is to add a head and a body to it. So if you're familiar with HTML, you've probably been asking why we haven't done this. We should have it there, but we don't have to have it. A browser will add it automatically, but it's definitely an improvement to follow convention, to not rely on a browser to do that for us. So now we've got a nice, officially formatted, kosher home.ejs file, and just double check that it still works. All right, and let's make sure our form still works. No reason it shouldn't, but let's add in a jared@gmail.com. And we hit join now, and we see we've gone up to 506 now, and we could go over to MySQL, run the same query, select star from users, order by created at descending, this time limit 1, and we get jared@gmail, and we get the correct timestamp. And we're officially done with this app. So if you wanted to, of course, you could create a second page to redirect to that said thank you or congratulations, or you could, restyle this, or you could collect more information if you wanted a challenge. Instead of just an email, collect a name or a birthday or a phone number. That's more useful than an email if people will give it away at least. So this was a lot, 2 sections just to make this work. Although if we really think about it, the bulk of it was introducing things like Node and NPM and the MySQL package and CSS and HTML, EJS. So much groundwork for a simple web app. But the MySQL part was super easy, hopefully. Creating a table and inserting a single thing or selecting a count, stuff that we've been doing for a long time in this course. So hopefully you feel good about that. And this was more of just a high-level survey of creating an app, but I wanted you to feel like, you leave this course making something, even if it is simple, but you've now seen how all the parts fit together. Alrighty, welcome back. So this is a new section, not just to you, obviously it's new if you're watching this, but new to the course itself. I added this, it's basically a month right now since I published the course, and I'm adding it because a lot of people have been requesting this topic. There's been a bunch of comments and people have been asking about this, so I decided to add it. And that topic is database triggers. So if you're worried about it, if it seems super advanced, it's actually much simpler than learning some of the earlier topics. Things like joins are much more complicated conceptually. So this is nice and easy. There's just a little bit of new syntax we need to talk about. But before we get there, let's talk about what the heck it is. What are database triggers? They're just SQL statements, bits of code, that are automatically run when something happens, when an event triggers them. So when a specific table is changed. So this is actually really, really useful in certain situations. So I should start off by saying this is not something that you'll be using all the time. Even in a big, if you work at a big company with a big production database, you're not going to have a bunch of triggers. You're not going to be writing this type of code often. So it's not central to using MySQL in any way, but it's a nice thing to know how to do. And when you do need it, it's really nice to have. So again, it's basically SQL code that will automatically run when they're triggered by certain events. So here's the syntax. It's not going to make a bunch of sense just looking at it like this, but here's the rough pattern. So there's this new bit of code, create trigger, and then we provide a name. And the name is not all that important. It's really for your purposes for referring back to it or if you're trying to remove that trigger later on. But as always, you want to give it something meaningful. But then we have three really important components: the trigger time, the trigger event, and then the table name. And then the syntax for each row, begin and end. So we'll talk about the syntax a bunch more. We'll write some code, but let's dive into these three things: trigger time, trigger event, and table name. Hopefully it will make a bit more sense. So as I said, these triggers run code when a particular event happens, when a table is changed. And these three components are very important to that. So the first one is the trigger time. And there's only two choices: before and after. So do you want this code to run before something happens? Let's say an insert. Do you want this code that you have to run before you insert or after an insert? Then moving on, we have trigger event. There are three choices here. So three changes that can trigger this code to run. We have an insert, an update, and a delete. So you can run some code right before something is inserted into a specific table, or you can run code right after something is deleted. And I'll show both of those examples actually, as well as update. And then table name has basically infinite choices. It's just the name of a table that exists in your database. So we could run some code before you insert into photos, or immediately after updating the users table. So whenever that happens, when any single item in the users table is updated, whatever code that we have between the begin and end, and there's a lot of new syntax, I know, so don't panic, we're going to get to that in just a bit, but whatever code you have there will automatically be executed right after a successful update on any item in the users table. And we could do the same thing for delete or insert. So the last thing I'll talk about in this quick intro video is what kind of things would you do with this? And there's really a couple of categories. The first has to do with validating data. And this is a bit controversial, in my opinion as well. And I'm not just saying other people think it is, but I actually don't think this is the best use of triggers. But what you could do is enforce specific things on your data. For instance, you don't want to let somebody sign up for your application unless they have an age that's greater than 18. You can actually write a trigger in MySQL to prevent that creation or that insert from happening if the age is less than 18. Now, the reason I say that it might not be the best use is that you could also do that in your application code. So if you have a web app, an iOS app, a computer app, it's much easier to write code that just says, is this age less than 18? Well, then don't even try to insert it into the database. But because this is a course on MySQL, I am going to show you how to do those validations. In fact, it's going to be the first thing we do. And the way that that works is you run code before inserting into a table. So we would have run this code that checks if age is less than 18 right before inserting into the users table. So we'll do that. But then the second category has to do with manipulating, creating, deleting other tables relative to your trigger table. So the example that I'll give that we're going to do, if we have our Instagram data, where you can follow, or any social network really, where you can follow people, you have friendships, it might be useful to actually know when somebody unfollows someone. If we're a company, we want that data. It could be relevant. We could, we could sell it, or it would help us understand when certain ad campaigns backfired maybe, and I started unfollowing, or our users started unfollowing particular accounts. Well, currently, there's no way of keeping track of that. If a user unfollows someone, if they delete their following relationship, essentially, it's gone. What we could do, though, is use a trigger to say, okay, right after a follow is deleted, we're going to create some new row. So you can think of it as sort of logging your history, which is a common use for triggers. So that's just one example of 2 different ways of using triggers. We're actually going to see 3 different examples in this section, but those are the 2 broad categories. So validating your data, and then the second one is manipulating other tables based off of an initial table triggering that action. So I think it will make a lot more sense once we dive into the code. So in the next video, we're going to go ahead and create our very first trigger. Okay, welcome back. In this video, we're going to create our very first trigger. And as a heads up, there's a lot of new code, a lot of syntax. The way that this is going to work is that we're going to run the code first, and then we'll ask questions later, which is maybe not always the best approach, but I think here it will help just illustrate how things work, kind of the overall goal, because you can get lost in the woods. Is that the expression? Whatever. You'll get lost potentially if you focus on these new things like this here, all this stuff here that we've never seen before. And I don't want you to get hung up on that. But we will address it in future videos, the next 3 videos after this, in fact. So in this one, we're just going to get this running and see that it works. And what it is, it's a very simple validation that basically we have a users table with any data, let's say name and age, username and age. And all that we want to do is prevent new users from being created if their age is less than 18. So it's pretty straightforward, the idea behind it. Like I said in the previous video, it typically would be better to actually do this on the client side of your application rather than waiting for the insert statement to get to, or rather than initiating a statement, sending some code to your database, having the database try and insert it, and then realizing, hey, age is less than 18, then sending an error back to the client side. That can take time. It's much better to just say on the client side, let's say of a web app, have a validation on the form that is going to check, is age less than 18 on this form? Well, then don't let the user submit the button, or don't let them click the button, or display an error message or something like that, rather than bothering with all this database stuff. But it's important to know that you can do this. So I'm going to show it to you, and it's a nice, simple example. So a couple things. I'm in a new folder here, just called triggers. I'm going to make a new database as well. And I guess this is a good time, as good a time as any, to let you know that I have seriously injured my wrist on one hand. So I'm typing one-handed. I'll try and edit around it. Hopefully it's not too noticeable. So we've got create database, and I'm just going to call this one trigger demo. Oh man. Okay, here we go. Then we're going to use that. All right. Now I'm going to make a new file just while I'm here, and I'll just call this users.sql. And we're going to make a simple table, create table, very, very simple, users. And like I said, it's only going to have, let's go with username, which will be a varchar. And then we'll also have age, which is an int. And that's it. Okay, so we can go ahead and run that just to validate that or to check that it works. So we'll do source users.sql. I ran this in the same directory. Okay, we should be able to do show tables, and I should be able to insert a user. Let's do insert into users, and we'll do username, comma age. Should all be boring review at this point. We'll go with Bobby. And age is, let's go with 23. Okay. There we go. And as always, select star from users, just verifying that everything works. All right. Pretty boring stuff. Now we're going to go ahead and create this trigger. And what this trigger is going to do is right before a piece of data is inserted into users, right before a new row is created, we're going to say, hang on, there's a trigger that's just been triggered. And it's going to check if this new user row, if the age is less than 18. And if it is, then we're going to throw an error. We're not going to let it happen. Otherwise, proceed normally and insert the user. So the syntax, I've already typed it up here. You can just copy this if you'd like. It's going to be easier. Well, like I said, we'll go over the ins and outs of it as we go through this section. But to start, we'll just copy it. And what I'll do is make a new file. You don't have to. You could just add it down here and just rerun this whole file. But then you've already created the users table, and so you would have to recreate it and drop it and then recreate it. Anyway, it doesn't really matter. I'm going to make a separate file. I think it's good to keep your triggers separate. So I'm just going to call this users trigger.sql. Okay, and then I'm just going to paste it in and hit save. And then I'm just going to source this file just like any other SQL file that we've run. It's just a little different than what we've done before. This is sort of like meta SQL, where we're not actually interacting with the database immediately. We're not creating tables. We're not inserting things. We're creating restrictions or triggers on another table. Okay, so I'm going to source it. I called it users trigger.sql. Oh, actually, before that, let me just verify that you can create a user who is less than 18. So let's say Sally is 16. And that works just fine. They're both in there. But now when we source our users underscore trigger.sql, we get this silly error, which is my fault. And rather than editing around this, I'm actually going to leave it. It's somewhat educational. I have a table called people that it's expecting. Before insert on people, well, there is no people table in this database. It is a users table. So let's recreate that. Okay, so now I do that, and we get this message that, like we get every other time something works, query OK. Now let's see what happens. So let's start off with something we know works, like let's do Sue, who is 54. That should work, and it does work. But now let's do, man, this is the hardest part. Let's go with Yang, who is 14, less than 18. And we get our message, error. We'll talk about this, 1644, 45,000, all that fun stuff. Must be an adult. And it's not just an error. If we actually go select all our users, Yang doesn't get inserted. So it's not just like an error that gets thrown out just as a FYI, but it also prevents things from actually being inserted. So that's the basics. We've got it working. In the next video, I'm going to break down some of the new pieces of code, in particular, what the heck this is here and here and here. Also, what this new thing is, new.age, and most importantly, what is signal, SQL state, 45,000, message text, all this stuff. All right, so we ran the code first. Now we're asking the questions. So going back to the code here, there's a couple of things I want to point out. We'll come back to the delimiter stuff at the beginning and end, but I want to focus first on the basic syntax. So create trigger, that's standard. We give it a name. I called it must be adult. You could call it whatever you want. It doesn't actually have any impact. Again, it's really a label so that if you do want to delete this trigger later on, you have a name to call it by so that we can delete must be adult, but give it something meaningful. Then we have the important stuff. So this is the meat of the trigger. We have our trigger time, the trigger event, and the trigger table. So this is the users table. That's the simplest one to start with. We want to run this code here right before something is inserted into the users table. Now, if we had said after, it wouldn't really do much because it wouldn't prevent a user from being inserted if their age is under 18. It would still check, and it would still give you an error if age was less than 18, but it still would insert it because it would be running afterwards. So it's not really a validation. So because of that, we definitely want to have before. But I will be showing you where you can use after in another example in just a couple of videos. But in this case, before insert, so it will run immediately before anything is inserted into the users table. Then we have for each row, that's just default syntax, begin and end. Notice a semicolon here, we'll come back to that. And whatever's in between begin and end is the actual code. This is SQL code that runs every time right before something is inserted into users. So let's start off by talking about this if new.age less than 18. So first of all, we have this if syntax where we have if, then, and then end if, which we've seen before. But more importantly, we have new.age. And new in this case is just a placeholder. It's referring to the data that is attempting to be inserted. It's referring to the new user that's going to be inserted into the table. So if new.age is less than 18, do this. Otherwise, don't do anything. There's also an old, OLD, that goes along with new that we'll see later on. Once we've deleted something, we want to have access to the data that was deleted. We can use old dot whatever. So new.age less than 18. New is a placeholder for whatever user is being inserted. Then we move on to the slightly trickier thing. What the heck is this signal SQL state 45,000 set message text equals must be an adult? So this second part is probably more self-explanatory. Set message text must be an adult. We saw that message text here, must be an adult. But this SQL state thing is kind of confusing. So according to the MySQL docs, there are 3 components to a MySQL error. There's a numeric error code. 1146 is a common one. And these are actually MySQL specific error codes. But then there's these other things called SQL states, and that's what we care more about in this situation. It's a 5-character value. It's not just numeric. It can have letters. And they're taken blah, 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 blah. This is from the docs, by the way, if you want to read more about it. But they're more standardized across SQL databases. So it's not just MySQL specific. This signal state code can be recognized essentially across different databases. And then along with that, there's always a message string, a textual description of the error. So that's important for humans, for us to recognize what's happening. But for our code to recognize what's going on, it's much easier to work with these numeric values or these SQL state values. Those are easier to recognize. You can write code that says, hey, if we get an error equal to 42SO2, then do this. Rather than saying, if we get an error that says exactly must be a number, must be greater than 18, there's sort of a lot of wiggle room there depending on how it was implemented. But these numbers, these hard-coded values that never change are much easier to check against. And as a side note, on the MySQL docs, there's this page, server error codes and messages. If you scroll down, you'll see there are tons of these messages or there's these errors and accompanying messages. Let's just pick one. Let's say, here's one here, error. So the MySQL error code is 1005. The SQL state is HY000, and the message is can't create table. And then inside of here, it will put the name of the table you try and create. So this would happen if you tried to create a table for some reason that you couldn't. I'm trying to think of actually how exactly this would happen. It says a foreign key constraint, potentially. It doesn't matter that much, but however you get this error, it will show you the error code, the SQL state code, and the message. And in fact, if we go try this, cause an error on your own, feel free to do whatever you want to cause an error, but here's one we could do. Select star from this table that we know doesn't exist, just gibberish. If we try and do that, go over here, we get an error. So it says error, and then we have 1146. So that error code is the MySQL specific code. Then we have the SQL state, 42SO2, and then we have this text, table, trigger demo dot blah, 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 doesn't exist. So this is the message, this is the SQL state, and this is the code. What we care about is the SQL state and then the message. And if we go over to the docs again and we try and find that code, so we had the SQL state was 42SO2. You can see that it shows up a couple times. There's an unknown table, message unknown table, but there's also bad table. And is there another one? Yes, table doesn't exist, error no such table. So those all use the same SQL state, but they use a different MySQL error. There we go. So 1051 versus 1109. This is really getting into stuff that doesn't matter that much to us. And the reason that it doesn't matter to us is that we're going to use one and only one SQL state, which is 45,000. So 45,000 is sort of like a wildcard state that is generic, and it represents an unhandled user-defined exception. So it's kind of just left out there for us to use it, for developers to return 45,000 as a way of saying, hey, this is something I've come up with. This is not a MySQL. This is not a SQL thing like, unknown table or a syntax error or something. This is something that I've defined, and I've set the message. So signal, SQL state, in quotes, 45000 is what we'll have anytime we want to throw an error. Then we have set message text, and that's important. That has to be set message text. It can't be set anything else. Set message text equal to whatever message we want returned alongside that. And then if we go look at what happens, just to refresh your memory up here, when we try that, we get error. Here's our SQL state, and then must be an adult. So that's the basics of this kind of new stuff in here. But then we move on to what the heck is going on here with this delimiter, $, and then $2 here, and then delimiter semicolon. What is that? So basically, if we take a look at, let me go to a cleaner version of this back here. If we take a look at the code, we have semicolons in certain places. That's because these are multiple line statements. So we need a semicolon after something like setting message text or an if statement or this begin and end. And if we just used a semicolon and didn't have this delimiter, so just pretend this isn't here, all of this, each of these lines would be treated basically as the end of our code. Remember that when MySQL sees a semicolon, by default, that is the delimiter, and that basically means this is a signal that I'm done with this line. Go ahead and execute it. But we don't want that to happen. So we don't want this thing to be read in, and it gets to this first semicolon, and it says, all right, time to execute this. This is the end, because it's not, in fact. So what we do instead is change the delimiter temporarily to, and it doesn't have to be $. I've seen people do it with slashes. $2 is most common though, just because it's not used anywhere else. So delimiter space $. That says, okay, from here on out, the actual delimiter is $2. So the end of our code is when you see $2. So then all of this is treated as one chunk. We hit the $. That says this is the end. And then we can change it back to a semicolon. If you didn't have this line, which I've done before accidentally, so we can actually do this now in the console. You can just change the delimiter anytime you want. So if I run it now and I try and do, let's say, select star from users, semicolon, and I hit enter, nothing happens. And that's because it thinks that I'm still going. It hasn't hit the delimiter. So I add $2, which now says we've hit the end. So you have to use $signs now, which can be kind of annoying if you forget. So you can see that now replaces the semicolon. However, we don't really want that. So I'm going to go back and just change it to semicolon, and now semicolon works. So that's all you need to know about the basics here. There's kind of a lot of pieces, but the most important thing, the template for any sort of trigger that you do usually has delimiter up top, and then you're using the $signs or whatever you set down here. And then you have create trigger and a name. Then you have a time before or after, an action or an event, insert, update, or delete. And then you have a table. And then for each row, begin and end, those always are the same. And then you have something happening inside of there. And just to summarize, new refers to the new piece of data, the new row we're trying to insert. And then SQL state, signal, all that stuff is just involved in sending an error message back. It's kind of a lot, but going forward, so we have 2 more examples. We're not going to spend a lot of time on the nitty-gritty details. We're just going to get going and just see how they work. Because honestly, whenever I create a trigger, I just go up to an old one that I've done before, I copy it, and then I tweak it. I don't start from scratch like I would with creating a table. You just don't do it that often. So no pressure to feel like you have to memorize all this or take it all to heart immediately. Just kind of be comfortable with understanding it if you see code in front of you. All right, welcome back. So we're continuing on with triggers. We're going to take a look at another potential trigger we could write. And in this case, we're going back to the Instagram data, which hopefully is fresh for you. It was just the last section. It's been a couple of weeks for me, so I had to refresh my memory on how the data looked. But basically, we're going to focus on one table, which is the follows table. So remember, we have users, and they can follow each other. It's a one-way relationship, unlike something like Facebook. It's like Instagram or Twitter, where I can follow someone, and it doesn't matter if they follow me back. So right now, all that we're storing is a follower ID and a followee ID, and created at potentially. But really, it's those 2 IDs that are important, both foreign keys. What we want to do is prevent users from following themselves, which is something a lot of people have commented on. It's a logical thing to want to know about because it seems like a pretty big flaw right now with our schema. But again, just like the previous trigger example, the validation of age, this is another situation where there's more than one way to solve the problem. You don't have to do it on the database side of things. You can do it on the client side or in the application side of things. Basically, rather than sending the request to the database to insert, a new follow with the, let's say I have ID 5, where follower ID is 5 and followee ID is 5. You could just prevent that from being sent in the first place by checking on the client side. But there are certain situations where you would want to do this. And one is this case where we're not working with external code. We're not working with another application. We're only doing MySQL. So I'm kind of doing this because a lot of people have been asking about it, but I'm not fully endorsing this as the best solution in an actual application. But for us, it's really the only one that works. And it's a perfect example of doing a validation with triggers. So what we want to do is just check. Basically, when something is being inserted, a new follow is being inserted, check if the follower ID is equal to the followee ID. And if that's the case, throw an error. Okay, so I'll hop over to Cloud9. And the first thing I'm going to do is actually copy over the old starter data file from the Instagram section. Now, you can just add this to your existing Instagram database, but I'm going to keep it separate just so that if people are following along and looking at the code from the previous section, they're not getting confused about this trigger stuff, which they haven't encountered yet, but not all that important. What I'm going to do is just make a new file here. I'll just call it ig.sql. Paste all of the stuff that creates the tables and the starter data. Again, you don't have to do this. You can just work with your old database. But now I'm going to source that file. Source ig.sql. Perfect. Takes a little bit because we're inserting a bunch of rows. But now if I do show tables, oh geez. Remember, I have a screwed up wrist. I'm blaming that for my typing. You can see we have all these tables. So to illustrate the problem really quickly, I could do something like insert into follows, and we'll just do follower ID, comma, followee ID. Just like that. Values. And let's just pick an ID. We're just going to assume that someone has the ID of 4. I don't actually know that for a fact, but I'm pretty sure somebody does. So if we do that, no problem. So our goal here is to prevent that from happening. We don't want someone to be able to follow themselves. So I'm going to go ahead and make a new file to write our trigger inside of, and I'll just call it igtrigger.sql, or triggers in case we have multiple later on. Okay, and then inside of it, I'm going to copy this boilerplate starter code that I provided, just so that we don't have to type all of this from scratch. We can kind of fill in the blanks. So we change the delimiter to double dollar signs. Then we're going to create our trigger, and we'll just call it prevent self follows. And the table name, we'll start there, is follows. Now, the two most important parts are when this happens, basically the time, is it going to be before or after, and then what event, what change to the follows table. So we know we want to have it happen on insert. So when something is inserted into the follows table, and we want it to happen before the insert because we want to check if we're going to insert it or not. If we do it after the fact, it's not very helpful because the data is already in there. So we're going to have before, and then the event is insert on follows for each row, begin and end. We fill in our code here. So the actual logic here is actually pretty straightforward. All we want to check is if the follower ID of the thing that's attempting to be created is the same as the followee ID. So that's going to be an if statement. We'll have an if, and then we can use new dot follower ID, the order doesn't matter, equals new dot followee ID. If that's true, then we'll have a then, and I'll also add in the end if with our semicolon. So if that's the case, we'll do the signal SQL state 4,500 or 45,000, and we'll also do set message text equal to, and we'll just say something like, you can't, oops, need to watch our quotes there. You cannot follow yourself, just like that, and add our semicolon. All right, so we can save that. Now let's see if it works. So to run this, we're going to source ig triggers.sql. Make sure we've saved the file first and we spell source correctly. Missing the L on the end. Okay, so it looks like it worked. Let's try another insert. Instead of 4 and 4, let's do 5 and 5. And we get, you cannot follow yourself. Great, that's good. Let's just make sure that we still can follow things how it's supposed to work. Oh, well, that's a duplicate entry. How about 7? Oh, come on. These already follow each other. How about, okay, let me pick something maybe that hasn't followed a bunch of people. 4, 2. Oh my gosh, they're all following each other. Well, all right. It took me a second, but I went back and looked at the data. Seems like this should work. 7 doesn't follow many people. There we go. Sorry about that. So basically all of this was a problem just because we had a lot of people already following each other. So I had to find some combination that wasn't already following each other. So 7, ID of 7 now is the follower, 2 is the followee, and that worked. But if we tried to do 7, 7, can't follow yourself. Okay, so that's that. The solution is here as well on the slides if you want to take a look. So to wrap things up, we used before insert again. So that's a common pattern if you're doing a validation. And we used new to compare the incoming new follow entry, the new row, the follower ID to the following ID. And then this is basically the same. So there's a lot of kind of boilerplate code that you can copy and paste. Hopefully you see that by now. So we have one more example coming up, which is a little bit different. It's not so much a validation. We're actually going to be inserting data into another table inside of a trigger. All right, so our final example here, as I mentioned, is a little different. We're not just going to be validating data before it's inserted. We're actually going to create new data based off of another action. So we're working with Instagram still, but the idea is that we want to keep track of when somebody unfollows somebody else. Right now, when a follow is deleted, when that entry is gone, it just disappears and we don't have a record of it, which is typical. That's how most databases work. But sometimes there's information that you would want to keep, that you might want to store, so you could refer back to it later because it could be meaningful. So in a site like Instagram, if there's a pattern to people unfollowing certain companies or other users, and you can discern that pattern, that's potentially really important to figure out why people are unfollowing or when these mass unfollow events happen. It's valuable information. So the idea is that rather than doing something before an insert like we've been doing here, we're going to do something actually after a delete. So after a follows is deleted, we're going to insert a new row into a separate table that doesn't exist yet. So we're kind of going to be transmitting it from one table to another. Now, you could argue there are other ways of doing this. You could, instead of creating a new entry in a table, you could take the original follows table and have a status active or deactivated or following and unfollowed or something like that you could toggle on and off. There are merits to that. There are merits to both sides. But because this is in the trigger section, it's a great example. And it's a really common application, just logging information, logging events that happen. It's probably the most common use for triggers. So hopping over here, what we need to do first is actually define a unfollows table. So we have our follows table. I'm just going to copy the entire thing and change it to unfollows. And we'll keep it as follower ID and followee ID. That's fine. Created at, everything else can stay the same. Now we have basically a duplicate table just called unfollows, and it will start off empty. But then let's say, someone with ID of 5 is following someone with ID of 6, and then they delete that, or we delete it because they've unfollowed them. We would then take that and insert it into the unfollows table. The same order, follower ID and followee ID are the same. But then we have a time created at for when that event happened, when the unfollowing happened. So that's pretty much it. Now what we want to do is have it happen automatically whenever a follows is deleted. So first things first, I'm going to rerun this file. I'm dropping the database, creating it again, using the database, and then creating all these tables, inserting all this data. You don't have to do that. If you just want to follow along, just run this code here. Okay, source ig.sql. Perfect. So we've got that new table. If we take a look, unfollows, and it's empty. You'll just have to trust me on that. So what we want to do now is actually create our new trigger. So we could do it in the same file. I'm going to do it in a separate file just so it's easier for you to see if you're going through my code here. So we'll call this the unfollows trigger. Perfect. And I'll go ahead and copy this starter code again and paste it in. So the trigger name, we could call it anything. Let's go with capture unfollow or something like that. And what we want to do is, rather than doing it before something is deleted, we can do it afterwards. Because maybe there's a problem, potentially something wouldn't be deleted. I'm struggling with a good example, but there could be some situation where the delete doesn't actually go through, in which case we don't want to create an unfollow. So we're going to do it after something is deleted. So after delete on, the table name is follows. That's our follows table here. So when one of these is deleted, immediately afterwards, our code goes in here. And all that we want to do is insert into the unfollows table, just like this, insert into unfollows. Then we'll have follower ID and followee ID. There we go. And then our values. And the question is, what are those values? Just like before where we had new.follower ID and new.followee ID corresponding to the new row that's going to be inserted. When something has been deleted, we have access to old.follower ID, comma, old.followee ID, just like that. So this works on its own, but I'm actually going to show you another syntax that I like for this situation, which is using set. So the set syntax is another way of inserting something. Actually, we'll just go to my solution to show you. It looks like this. Insert into unfollows, and then we have set follower ID equals old.follower ID, comma, followee ID equals old.followee ID. So it's really up to you what you prefer, but I just wanted to show this syntax. There we go. Just like that. So essentially all you're doing is using an equal sign to assign them rather than values, parentheses, that old syntax that we're used to. So I'm just going to mix it up here. But to be clear, you absolutely can use the other example as well, the typical insert. So we don't need an error message or anything here because this isn't a validation. We're not responding with something. We're not preventing something from happening. All that we're doing is connecting these two tables so that when something is deleted from follows, an analog is created in unfollows, which, as I said, is a pretty common situation, not follows and unfollows necessarily, but capturing kind of metadata or capturing other information based off of SQL happenings, if you will. So events, things changing, being deleted, updating, that you're then capturing and logging somewhere else so that you can refer back to it. So you usually don't just do this willy-nilly. Typically there's a reason you want to store that information. Otherwise it can get bloated very quickly, especially if you have a lot of triggers going on. I'm actually going to spend a couple seconds at the end of this section with some advice about when to use triggers and when not to use them and how they can get out of hand. But for now, this is perfect. So let's save it, make sure we don't have any syntax issues, and let's see what happens. So we'll do source unfollow trigger.sql is the name of the file. Looks like it worked. So let's verify right now. Select star from unfollows, nothing there. Let's do a select star from follows, and let's limit it to 5. If I can spell that correctly, select. Okay, so what we're going to do is say that follower ID 2 unfollows person with person with ID of 1. So we're going to delete this right here. So let's do it now. We'll do a delete from follows where follower ID equals 2, and we could just leave it at that, and that would delete all of these that have follower ID of 2. So we'll do and follow E ID equals 1. I need that D there. There we go. Okay. So it should be gone if we select it. Now it's gone from there. And if we looked at unfollows, there we go. We now have follower ID 2, followee ID 1. So just to show you that one more time, let's go ahead and delete all follows where follower ID is 3. So that should be quite a few. 99. And now if I look at all unfollows, we have 99 new entries. So pretty cool, very easy way to kind of transfer that data over into another form. And you're not always strictly duplicating data like this. Sometimes you're summing data together. So when something is inserted or deleted, maybe you're keeping a tally in another table somewhere. Maybe you're keeping a total. Like if you have a shopping cart, you have a cart table, and then you have your items or your products table. And anytime a product is entered into a cart, anytime a new product is created, you're going to update the total, and you could do that using a trigger as well. So it's not just copying exact data like we're doing here from followers or follows and transmitting it identically into unfollows, but that's a simple example that makes sense in the context of our Instagram data. So that wraps up kind of what I want to do with triggers. Hopefully you see some of the possibilities around them. The next video is going to be pretty quick, just talking about how you can delete triggers, how you can view your triggers, kind of managing them. And then we'll also talk a little bit about kind of a warning around triggers. So I'll see you then. All right, so we've got one more video here, and this has to do with managing triggers, which sounds a bit like a chapter in a self-help book, but really it has to do with how we make sure our triggers are working and mainly delete them. So this is where the name of our trigger comes into play. And then also I'll end with a quick warning about triggers. So the first thing that we can do is just list the triggers that exist in a database. So we can just use show triggers to see what we have going on. And I'll warn you, this is not my warning I already talked about, but I'll warn you that what you get when you run this is kind of a mess to look at. But we can see we have in our Instagram data, we have 2 triggers: prevent self follows, and then you can actually see the code inside of that trigger. And then we have capture unfollow, and you can see that code as well. And if I switched over to the other database, I believe it was use trigger demo, and I do show triggers, we have one here. This is our must be adult. All right, so we have that. I'll switch back to my Instagram clone. Okay, and do our show triggers just to make sure they're still there. They shouldn't go anywhere anyways, but we've got 2 of them. So that's pretty much it to listing them. Moving on. So if I want to remove a trigger, it's pretty simple. It's drop trigger and then the trigger name. So let's go back. Let's say I want to remove this prevent self follows. I want to allow users to follow themselves. So I want to get rid of that. I'll just copy the name just so I don't have to type it. And we just do drop trigger prevent self follows. And if we do our show triggers again, it's gone. And just to verify that it works, it's not just deleting the trigger from show triggers. Let's try and trigger it, if you will, with something that would have caused a problem or thrown an error in the past. So insert into follows, and we have follower ID, comma followee. This is the worst part. Values. So let's insert something where they're the same. How about 7 and 7? No problem. So in the past, that would have been a problem because of that trigger, but it's now gone. Okay, so that's really all there is to managing triggers, or at least all that I'm going to talk about here. We can look at them using show, and we can delete them using drop trigger. So that brings me to the last thing that I warned you about, which is I wanted to just briefly address a potential hiccup with triggers. This is kind of a concern that a lot of developers have, and it has to do with debugging code, debugging applications that make use of triggers in your database. So imagine that you're a developer on a team with a bunch of people, and something's not working how you expect it to. Let's say when you insert something into a table, you realize that actually 2 items are being created for some reason, and you have no idea why. And you might think, okay, maybe that's something happening on my side of the application. Maybe that's my code. That's something is wrong, with our logic on the front end, with our, let's say, Objective-C code. And you could scour that forever, but you would actually never get to the core of the problem if it was because of a trigger. And triggers are kind of stealth little bugs waiting to happen because you have no way of identifying that something is happening because of a trigger. It happens kind of behind the scenes. Like remember, if we go back here with our unfollow, if I can go find that, way back here. Oh boy, where is that? Here we go. Here we had 99 entries created automatically when all I did was run a single line of SQL to actually delete things. It ended up creating 99 things. Now we knew that was going to happen, but if you have a bunch of triggers and somebody doesn't know about them on the team, or you forget about them, it can make things difficult to debug because it's basically magic happening behind the scenes, things that are hidden. Typically, when you're debugging, your code is up in front of you. You can see where the problems are happening. So triggers cause problems sometimes because of that. And the other thing I would say is that some people have a tendency to chain triggers together. So with our unfollows example, you could have another event trigger. So let's say here when a follow is deleted, we're inserting into unfollows. We could have another trigger for when something is inserted into unfollows to do something else. And you can chain them together. And there's actually situations where, believe it or not, that actually makes sense, but it's kind of frowned upon by a lot of people. So just be conscientious if you're using a lot of triggers. Typically, there's a better way of doing it without having to make use of triggers. And if there's not, then you know that it's a good use case for triggers. I'm not saying you should never use them. By all means, they're very useful. It's just that you should be conscientious about them and try and find ways to not use them. Okay, so to wrap that up, just be aware that triggers can make debugging more difficult, more problematic, because stuff happens behind the scenes. It's not explicit when something happens. And then also be aware that too many triggers can often be a problem, and you want to avoid triggers as much as you can. Not at all costs or anything. I'm not saying they're bad. Just be careful with them. All right, so hopefully that answers some of your questions about triggers. Hopefully you can see the utility in them. And I know a lot of people are asking about preventing people from following themselves. So if nothing else, hopefully it was nice to see that, how you can actually prevent people from following themselves. All right,